This course covers every objective in the AZ-801 Configuring Windows Server Hybrid Advanced Services certification exam. Let's now review the training course lesson by lesson. We begin with Lesson 1, Secure Windows Server. Here, we work with native Windows Server security features such as exploit protection, Microsoft Defender, and SmartScreen. In Lesson 2, Secure a Hybrid AD Infrastructure, we harden both read-write and read-only domain controllers, as well as manage password policies. Lesson 3, Secure Azure AD Identities, has us working with built-in Active Directory administrative groups and delegating administration. We then turn to Azure in Lesson 4, Manage Windows Server Security with Azure, to learn how to use Azure Security Center and Azure Sentinel. Lesson 5, Secure Windows Server Networking, involves us managing Windows Defender Firewall and implementing IPsec connection security rules. In Lesson 6, Secure Windows Server Storage, we manage both BitLocker drive encryption on-premises and Azure Disk Encryption in the cloud to protect Windows Server storage. Lesson 7, Implement a Windows Server Failover Cluster, marks the beginning of a mini-series focused on Windows Server 2022 high availability. Specifically, in Lesson 7, we create a Windows Server Failover cluster and stretch that cluster across both local data centers as well as Azure regions. In Lesson 8, Configure a Windows Server Failover cluster, we configure cluster sets, scale out file server, and Azure witnesses. We also implement load balancing for failover clusters. Lesson 9, Manage Failover Clustering, involves us implementing cluster-aware updating and managing failover clusters by using Windows Admin Center. Lesson 10, Implement Storage Spaces Direct, wraps up our coverage of Windows Server Failover Clustering. Here, we build a failover cluster by using Storage Spaces Direct and configure the service. Next, we launch on a deep dive of hybrid disaster recovery for Windows Server 2022. In Lesson 11, Manage Backup for Windows Server, we back up and restore Windows Server machines to an Azure Recovery Services vault. We also learn how to use Azure Backup Server. In Lesson 12, Manage Recovery for Windows Server, we recover virtual machines both by implementing temporary snapshots and recovering failed VMs to new Azure VMs. In Lesson 13, Implement Disaster Recovery by using Azure Site Recovery, we configure site recovery for Azure VMs. This task involves us creating a recovery plan and implementing VM replication in Azure. Lesson 14, Protect VMs by using Hyper-V replicas, teaches us to configure Hyper-V hosts for replication, as well as how to actually perform failover and failback. Lesson 15, Migrate Local Storage to Local Servers or Azure, involves implementing Storage Migration Service to migrate on-premises VMs to Azure VMs. We also learn how to migrate local file shares to Azure file shares. Lesson 16, Migrate on-premises servers to Azure, has us migrating on-premises servers to Azure by using Azure Migrate. In Lesson 17, Migrate Workloads to Windows Server 2022, we migrate IIS, Hyper-V, Remote Desktop Server, Dynamic Host Configuration Protocol servers, and Print servers to Azure. We extend IIS migration in Lesson 18, Migrate IIS workloads to Azure, by migrating IIS to Azure Web Apps and Azure Container Services. In Lesson 19, Migrate ADDS to Windows Server 2022 ADDS, we migrate Active Directory Domain Services objects to domain controllers running Windows Server 2022 by using the Active Directory Migration tool. The last phase of the course deals with Windows Server monitoring. Lesson 20, Monitor Windows Server by using native tools, involves using Performance Monitor and Data Collector sets to keep an eye on local Windows Server performance. We turn our attention again to Azure in Lesson 21, Monitor Windows Server by using Azure Services. We deploy the Log Analytics agent and then monitor VMs by using Azure Monitor tools and features. In Lesson 22, Troubleshoot Windows Server Hybrid Networking, we troubleshoot both hybrid network connectivity as well as on-premises connectivity to our Windows Server machines. Lesson 23, Troubleshoot Windows Server VMs in Azure, has us troubleshooting deployment, booting, and performance issues, both for on-premises and Azure-based Windows Server machines. We wrap up the course with Lesson 24, troubleshoot Active Directory. Here, we restore objects from the Active Directory recycle bin, recover sysvol, and troubleshoot hybrid authentication issues. If all this sounds like a lot of information, it certainly is. However, I encourage you to stay strong and confident. I'm here to walk you through every single one of these skills, and I can assure you you'll emerge from this course much more proficient in Windows Server hybrid administration. So, are you ready to become a certified Microsoft Windows Server Hybrid Administrator Associate? Good. Let's get started. Welcome to Lesson 1, Secure Windows Server. In this lesson, we tour several Microsoft local and cloud-based products to help us secure our Windows Server systems. We begin by configuring exploit protection, and then launch into a consideration of Windows Defender Application Control, Microsoft Defender for Endpoint, and Windows Defender Credential Guard. We conclude the lesson by configuring the Microsoft Defender SmartScreen filter and reviewing group policy-based security settings. Let's get to work. Microsoft Defender Product Family. Now you'll notice I'm being a bit cheeky in the slide title, that the exam objectives, at least as of this recording in early 2022, haven't yet been updated to reflect the product name change. It's not a big deal. It's just that many of these Defender products used to be called Windows Defender, and because many of these products are cloud-based and they work across non-Microsoft operating systems, hopefully it makes sense that these products are called Microsoft Defender now for the most part. These are cloud-based services. They exist in the Microsoft Cloud Platform. And there are a number of them in the family. We just need to be concerned with a subset of those for our AZ801 success. We've got Microsoft Defender for Endpoint. This is going to give us centralized command and control over our anti-malware scanners on our systems. There's Microsoft Defender for Identity, which we look at in a separate module in this course. This is going to leverage artificial intelligence, predictive analytics, and cloud services to scan and keep safe your on-premises Active Directory domains. There's Microsoft Defender for Cloud. These are all the AI-based protections that exist specifically in Azure, but we'll see in the demo in this lesson that Microsoft Defender for Cloud can and does touch servers both in cloud and non-cloud contexts. Now, as far as local system services, these services are installed and available natively in Windows Server and in Windows Client. However, I say system services, they do have dependencies on the Microsoft Defender Cloud services on the back end. We'll be taking a look at Windows Defender Exploit Guard next, and then we'll do application control. And then somewhat inscrutably, SmartScreen is called Microsoft Defender. Now, it's kind of a losing battle to try to understand Microsoft naming conventions here, but my operating definition is that if it's a cloud service or a service that's relatively OS agnostic, it's Microsoft Defender. But if it is a service that's native to Windows, it's normally called Windows Defender. But SmartScreen, unfortunately, breaks that trend. Anyway, let's proceed. What is Windows Defender Exploit Guard? Well, first of all, we need to understand what an exploit is. In information security, an exploit refers to a tool or a technique designed to take advantage of a flaw in a computer system. And when I'm talking about a flaw here, I'm not just talking about a bug that may be in your line of business application or Windows operating system, although that's pertinent. I'm talking about hardware-based flaws. Those are much more difficult to remediate. If you have a vulnerability in your memory chips or your CPUs, that could be much more problematic for you to just swap out. So Exploit Guard can step in and help with those kind of issues and to help block those preventable exploits. The Exploit Guard bits are contained in the Windows Security app, the successor of Control Panel in Windows Client and Windows Server. And as I said, it's a set of built-in remediation for common exploits dealing with memory, memory access, and CPU. The actual exploits aren't as important for our exam success because they get pretty high level and pretty deep. This certification, remember, on hybrid cloud administration is not an InfoSec skill set. We're going to see as a common trend throughout all of these tools, we can use group policy objects to manage policy for these different security services. Here's a screen capture of Windows Server 2022. It looks the same in Windows 10 and Windows 11 as well. This is the exploit protection module in the Windows Security app. And like I said, there's control flow guard and data execution prevention. You can read about the details of those, but for our purposes, we're just looking at known vulnerabilities in hardware, and this is making sure that exploit guard protects against those common vulnerabilities. So essentially, it's set and forget. So you might be wondering, well, why would I use group policy? Well, in my experience, it would be to make sure that your end users couldn't disable exploit guard. In other words, to force it on always. What is Windows Defender App Control? It's also called WDAC or WDAC. This again is native in Windows Server and Windows Client. It protects your servers against malware and untrusted software. That's a pretty generic explanation. App Control is pretty powerful because what you're doing is creating an explicit allow list for device drivers and software, which means that an app control deployment requires careful planning and architecture, careful testing. You know, it's one thing to allow all code to run by default. That's the most common, but least preferred runtime option for a server. On the other hand, if you're blocking all software and device drivers except those that are allowed, hopefully you can immediately see, if I'm not careful, I could create an unintentional denial of service because this server can't start a service because of this app control. It can't invoke an app or a script that it might need because of app control. So it's a very strict alternative to AppLocker. Now, AppLocker I like to define as a V1 method for application control in Windows Server. AppLocker does allow you to explicitly block apps from running and scripts from running, and you can get pretty close to an allow-only configuration, but it's not as robust as Windows Defender Application Control. For example, AppLocker can't touch dynamic link libraries or device drivers, whereas WDAC absolutely can. And the system requirements for AppLocker are much more relaxed than they are with WDAC. So whether you want to go for AppLocker or Defender Application Control is going to depend on a number of things. Number one, do you want to protect the full runtime environment, including drivers and libraries? If so, you need WDAC. Do you have the necessary hardware? Do you have secure boot capability? Do you have a trusted platform module on the motherboard? If you have all of these prerequisites satisfied, and then lastly, you have a very clear picture of the code that you want to run legitimately on those servers, then yes, I would say WDAC may be for you. Again, we use group policy objects. Now, this is another trend I want to mention, that although the default management option for all of these security products is group policy because, let's face it, it's baked into Active Directory, it's convenient, it's got a wide scope. It's not the only management platform. You can use, for instance, Endpoint Manager, Configuration Manager. That is what used to be called System Center Configuration Manager. You also could use Microsoft Intune, the cloud-based alternative. Here's a representative screen capture of where we can find the Defender Application Control policies in group policy. You can see on the left, we're walking down under Computer Configuration, Policies, Administrative Templates, System, Device Guard. Now, don't be thrown off. Let me bring my drawing tools out by the nomenclature here. Again, Microsoft loves to rename products. What is now called Defender Application Control used to be called Device Guard. And again, as of this recording in spring 2022, the GPO directory is still listed as Device Guard, even though the actual policy reflects the correct product name, Windows Defender Application Control. And like I said, not only are you going to have quite a bit of hardware prerequisites to satisfy, but you and your team are going to need to skill up on how to create a code integrity policy. This is a binary file. As you can see, we provide the path in the policy, and this is going to tell the system what code it's allowed to run, and anything else it's just implicit block. All right, so it's a pretty strict way to work. From the end user perspective, this is the dialog that an end user would see if they attempted to run code that was in scope for blocking with application control. Now, I'm old enough to remember the dawn of antivirus. It was called antivirus software, and then for a while there was a separate distinction with anti-spyware, and then it became anti-malware. Well, Microsoft Defender for Endpoint, it's gone through so many different iterations. That would be a fun conversation, but we don't need to worry about it now. I want you to understand that this is Microsoft's mainline business anti-malware client. However, Defender for Endpoint is more than an anti-malware client. It gives you threat and vulnerability management. It's available on Windows, Mac, Android, iOS, so it's pretty universal. Hence the Microsoft Defender rather than Windows Defender. It gives us centralized management via a dedicated web portal. We can integrate with Defender for Endpoint if we're using Microsoft Azure, and we have an Azure subscription. There's Microsoft Defender for Cloud. And when you onboard your servers in Microsoft Defender for Cloud, you get license rights. This is part of the Microsoft Defender for Servers product. You get license rights for Defender for Endpoint, which is nice. I mean, licensing, I'm very grateful to say, is not covered on the CERT exam, and I'm glad because that's an entirely other subject. I have friends who make their entire careers by teaching people how Microsoft licensing works. Now, historically, antivirus, anti-malware client software is a separate application. Here you can see that the Defender for Endpoint is actually baked right into the Windows security setting application, as you can see here, virus and threat protection. And you have your typical configuration options, scheduled scans, ad hoc quick scans, quarantining, this kind of stuff. But the idea is we're concerned in this module not with client device endpoints, but with server endpoints. So we're concerned with centrally managing the state of these machines because these machines aren't being used necessarily by humans for 8 hours a day for all sorts of different purposes. Windows Defender Credential Guard protects users against NTLM pass the hash or Kerberos pass the ticket type of attacks. Basically, they're attacks against credentials that are in memory and are in use on a system, on a server or client system. And normally, those credentials, including password hashes, ticket information, etc., for Kerberos, is available in conventional system memory. So Microsoft created Credential Guard as a built-in capability of Windows Server that gives us what's called virtualization-based protection. So basically, without getting too far into the high weeds here, instead of having your tickets and hashes in memory where they could be plucked out of the air, as it were, we're leveraging hardware components and software virtualization components in Windows to basically put those in-memory hashes and tickets in a safe to where it makes it much more difficult for that data to be captured by a malicious party or process, you see. Now, when you're putting credentials in that special virtualization safe, hopefully it makes sense that those credentials, those fresh credentials, will be incompatible with delegation technologies like CredSSP and Kerberos constrained delegation. We looked at both of those elsewhere in this course. And you should also know that Credential Guard is not available on domain controllers. And then you know the last bullet point. I pretty much don't even need to mention it. GPO-based administration is the main option for enabling and configuring Credential Guard. And then in keeping with my pattern to just show you a relevant screenshot here, it's the same path for Credential Guard that we saw with application control a moment ago. Computer configuration, policies, administrative templates, system device guard. And the specific policy here is called Turn on Virtualization-Based Security. And just like we saw a little bit with Windows Defender application control, your servers that are going to use Credential Guard have to have current hardware. So you can really monitor code integrity from the boot process and beyond. So we're talking UEFI and not BIOS for your boot firmware. We're talking about trusted platform module and secure boot. So you need to have all of the hardware prerequisites available before the Credential Guard even becomes a viable option, okay? Microsoft Defender SmartScreen, by contrast, is a product that you as an end user, let's say, on your client device might have seen, as opposed to Credential Guard and application control, which are frankly a bit more niche. So what SmartScreen does, it's going to alert you, and then if you're using a central command and control like Defender for Endpoint, it's going to alert your administrators on potentially malicious software and websites that are either attempted for download or installation, or if it's a zip archive, unpacking it if it's got malicious code in it, or driving by to different websites. It can also trigger on that. So SmartScreen is pretty cool. The smart means that you don't have to feed it a list of known malicious software and websites. Microsoft has their own internally curated filter lists. Now, due to operational security, Microsoft doesn't publish those. It's proprietary. But it's, as you can imagine, with all the signal logic that Microsoft sees each day from customers, it's going to be a pretty robust list. And if you have administrative rights on the system, you normally can override SmartScreen, but the idea is that if you or the user is running as a standard user, they would not be able to. And once again, we can manage SmartScreen centrally using group policy, or we could use Microsoft Intune, let's say. Like I said, you may be familiar with this dialog, Windows protected your PC. This is the SmartScreen modal dialog when it triggers an alert. And I've seen this happen for unsigned software, which brings up the question of false positives. You're going to see in our demo that the Defender for Endpoint portal, one of its many value propositions, is that you can centrally define exclusions. So if you do have some unsigned software that is legitimate and you want to suppress these sorts of blocks, let's face it, if one of your employees hits a SmartScreen block when they attempt to run some code or install some software or whatever it is that they're doing, that's a work stoppage, and depending upon how agile your support desk is, it can take a while to unpack. So I hope you're seeing as a general theme here that in securing Windows Server, we need to be doing much due diligence and much testing to try to isolate these issues and make sure that we reduce or eliminate false positives. All right, now lastly, notice that this SmartScreen dialog has run anyway. That would be something you could do if you're running with administrative token, but if you don't have the administrative token, you can't run it. Yeah, well, we've been mentioning group policy a whole lot, but I think this AZ801 objective deals with the old school security. Really the theme for most of, or really everything we've done in this lesson is very 21st century. It's very agile and artificial intelligence and cloud-based. Here we have these group policy security settings under computer configuration, policies, Windows settings, security settings that have been in the product as long as Active Directory's been around, and even beyond that. I remember in Windows NT seeing just at least a couple of these, like the local policies and the account policies. Those are prehistoric options right there in terms of user rights assignment, in terms of account expiration, password expiration, all that kind of stuff. But this is also a place where we can customize event log retention, where you can enforce group membership. You can ensure that key system services are always started or always stopped. I don't need to explain every one of these. Really, looking at the AZ801 skill set, we wind up covering most of these security options anyway. So this is just a reminder that even in 2022, the central role that group policy plays in Windows Server configuration management and security. In this demonstration, I want to focus specifically on Defender for Endpoint and how it relates to Microsoft Azure. After all, the AZ800 and AZ801 exams are about the hybrid cloud administrator, Windows Server admin. So you're looking at the desktop of a Windows Server 2022 machine. And if we go into the Settings app, specifically the Security app, we have the various security controls that I've mentioned before. This is where we can get into app and browser control, where you've got exploit protection settings. This is what I showed a screenshot of before. We've got our anti-malware. Now I've onboarded this machine to be managed by Defender for Endpoint. So it's actually, I don't see any indication on this screen that it's being managed centrally, but I will show you in just a minute that it absolutely is. So that is our client application available on Windows Client and Windows Server. And then as far as how you would get Defender for Endpoint up and running in terms of how you would onboard one of your Windows Server systems, I want you to understand that it doesn't matter whether your system is a native Azure virtual machine or if it's a VM that's running on-prem or in another cloud. Let me show you what I mean by that. Let me go into the Azure portal, and I'm going to come to Defender for Cloud. Now, Defender for Cloud used to be called Azure Security Center, again, with the product renames. And even more so, Microsoft tends to shift around where to find stuff, so it may take me a moment to find what I'm looking for. But what you can see just from a high-level overview is that Defender for Cloud is meant to be a general-purpose recommendation engine for all of your Azure and hybrid cloud infrastructure. All right, so let me go to getting started. I think that's where we go right now. Yes, and we can take a look at our subscription, and this is where you can change your Defender plan, okay? The default is the free tier, where you get what's called a secure score. That's just a numeric assessment of how secure your environment is according to Microsoft proven practices. And you will get assessment and recommendations. But in order to light up all of the real value, you'll want to enable some or all Microsoft Defender plans. And if you scroll down here, there are a number of different plans available for different services. Now notice that we've got Defender for Servers. I thought for sure I had this turned on already, to be honest with you. Okay, I think I did. I must have just switched it off temporarily. Yeah, so if I select Enable, we've got Microsoft Defender for Servers. We don't need to worry about pricing, but notice it's generally a fixed cost per instance or per server per month. And although we've got all these other options here for storage accounts and containers and databases, I again just want to limit our consideration to Defender for Servers. Now you might be thinking, hold on a second, Tim. Our workload is almost all on-premises. How could we get those on-premises machines onboarded into Defender for Servers? Well, let me show you that. What I did, of course, with Microsoft, there's always so many different ways to accomplish any goal. What I did is I created entries in Azure Arc for Server for my on-premises servers. It's really easy to do. To onboard one of your off-cloud Windows Server machines, you just run a PowerShell script. And then using HTTPS port TCP 443, that system will report into Azure like my DC1 Windows Server. And then we can manage this machine centrally in Azure. And specifically with regard to endpoint protection, if we go to security, this means now we can surface recommendations and view alerts for those off-cloud servers the same way that we do with our native Azure machines, you see? So it's giving us some recommendations. Now, some of this may be a little out of date. Let me see. Machines should have a vulnerability assessment solution. Exploit guard should be enabled on machines. I thought I had that already enabled. But I just want to show you as we're going through here that you can then take action and Microsoft will either auto-remediate if it can, or you'll get instructions on how to remediate that system, you see? So those are some of the recommendations that we see here. And it looks like I've got some alerts that have been surfaced by the It's registered here, notice, as Microsoft Anti-Malware, but because I've onboarded this machine into Defender for Endpoint, it's technically running Defender for Endpoint. Yes, it's confusing. No, don't think about it too much. Now, these are kind of generic alerts, anti-malware action taken. You'll find that a Defender for Cloud is meant to be more of a general purpose security solution. In terms of your hybrid cloud infrastructure, there's Sentinel. If you've ever heard of Azure Sentinel, is a more robust SIM-SOAR, a security information event manager, security orchestration, and automated response platform. There's that. You can get much more data there. But if you're going to go in with Defender for Endpoint, I'd mentioned that there's a separate portal for that. So as long as you're licensed for Defender, which, as I just showed you, if you onboard for Defender for servers, you are licensed for Defender in general. And you can go to security.microsoft.com, sign in with your global administrator Azure AD account, and you've got action to all of these endpoint controls. So if we come down in the left-hand navigation, under endpoints, we have our device inventory, where it's going to show us all of our devices that we've onboarded into the system, and then we can report on them. As you can see over on the right, there's a risk level, an exposure level, the underlying OS platform, etc. So there's quite a bit of metadata here. Let me try to find my DC1 machine. I think it's this one right here, yes. This is the machine that I've been showing. We can see who the currently logged on user is. We can go to the dedicated device page for that onboarded host. And we can see, again, I don't need to read it. You can see if there's any open incidents, if there's open or associated alerts. And I've been intentionally running a lot of test code. What you'll definitely want to do is once you onboard a machine into Defender for Endpoint, you'll want to make sure that the machine is actually doing what it should. You see what I mean? So what I've done, there's a really great malware test page here called wicar.org, wicar.org. There's another site called icar.org. It's a European antivirus research place, eicar.org. They have a number of tests that you can run. You can download zip files that have fake malware. You can go to drive-by websites. So all of these are harmless, but they'll trigger and then test the capabilities of your system. So you can see that this is what you see with SmartScreen, as you can see on the lower right. When you visit a website that is in the Microsoft Defender SmartScreen list of blocked websites. Similarly, if you have a zip file, I think I've got one in here, at least I did. I think I've got it right here. I've got it off screen. So let me bring it into my VM. Let me Control V. So if I attempt to unpack this icar test file, in this case 7-zip, which is my compressed file utility, it says it did not complete because the file contains a virus. And notice that the zip file actually disappeared. That wasn't 7-zip. That was the Defender for Endpoint. And so we can see all of those alerts show up if we go back to our Defender for Endpoint Management Console. So that's what we have there. We've got our device inventory. We've got vulnerability management, where you can take a look at specific recommendations and remediation options. And what I want to show here that I think is so powerful, Defender for Endpoint goes beyond just the old school, this is a virus file, or this website is a known phishing site kind of stuff, which is important, don't get me wrong. But you also know that zero-day vulnerabilities can show up in regular software. So again, when you onboard a system into Defender for Endpoint, these recommendations are actually touching installed software. And so if there's an update available, you can see that show up as a recommendation, and you can trigger automation based on these recommendations. That's pretty cool, isn't it? So basically what I'm saying is that the Defender client will perform a software inventory on those managed systems and give you a level of threats. And this actually, again, it used to be part of a separate product. I believe it was called Cloud App Security, Microsoft Defender Cloud App Security, where the idea was you can explicitly allow and block applications. It's very similar to what you have on premises, what we already discussed with application control. But in my experience, the Defender Cloud App Security, or whatever it's called this week, is a lot easier to implement because you don't have those strict hardware requirements like I mentioned before. Lastly, I want you to see under evaluations and tutorials here, there's an evaluation lab with a whole bunch of tutorials and attack simulations that are going to be really useful for you and your team to work through, because they're going to allow you to be able to go through all of these different elements in the portal so you'll understand what you do, for instance, when you're doing threat hunting. And you'll understand, for example, the difference between an alert, which is a specific incident. Like, for example, here we have not one, but 2 remote code execution attempts that happened on one of my systems. Now, the problem with these individual alerts is there may very well be a correlation among several of them, but you don't see that in just a straight list. Incidents, again, using artificial intelligence on the back end, is able to correlate individual alerts and tell more of a story, see? So in this case, it says remote code execution attempt on multiple endpoints, and it's grouped together those 2 individual alerts. And you can see, in this case, the detection source was actually Microsoft Defender for Identity. And you can go on from there to drill into the incident and so on and so forth. Affected devices, users, apps, etc., etc. Because a lot of these Defender products function together, they don't necessarily have to be purchased together. So as I had mentioned, that this particular incident was originally surfaced in a separate Defender product, specifically Defender for Identity. Notice that the portal here has a Trials tab, and this is where if you do realize that you might want to onboard an additional compliance or security product, you can light up a trial to those here just by clicking the mouse a couple times. Welcome to Lesson 2, Secure a Hybrid Active Directory Infrastructure. We begin our work by configuring password policies and block lists using both Active Directory and Azure Active Directory. We then move on to protecting Active Directory users and managing account security on Windows Server 2022 Read-Only Domain Controllers, or RODCs. Lastly, we consider ways to harden our domain controllers with a special focus on Active Directory authentication policies and authentication policy silos. Ready to begin? Let's get to work. Well, passwords have been the main way that we protect user accounts, and you protect your own user accounts, wherever those might be, historically. Why do we do this? Well, we don't want compromise. Some common password attacks include the brute force attack, where a bad actor will just repeatedly attempt different letter, number, and non-alphanumeric combinations on a password, and they may do the same thing with various usernames. I see that in Azure AD a whole lot. You can't use well-known administrator names like administrator and admin and SA on your Windows virtual machines. But again, I've seen quite a bit of variety of people attempting brute force attacks on Azure Windows VMs. A dictionary attack is where you take a huge file of words in multiple languages and try those in the password field when you're trying to break an account. A password spray attack is where the attacker knows the username that they're going for. They're just spraying multiple passwords. Again, it could be a brute force or dictionary type, all in the goal of compromising the account. And we know that depending upon how highly privileged that account is, a compromise could involve devastating consequences for your company. Now, the NIST has a special document, the most recent one, their Bulletin 863, gives you some updated guidance on passwords. Now, it used to be, for the longest time, it was recommended to change your password regularly. But fortunately, NIST now recognizes how unworkable that is in practice because, you know, I'm guilty of it, I have to confess. When you're forced to change your password frequently, it's too easy to just add a 1 or a 2 at the end of your old password. So the current guidelines include at least 8 characters, and there's reasons for that guidance that we don't need to get into. Some other ones, let me just bring out all of the bullet points. Infrequent password changes. So the idea is it's better for your users in general to have a single secure password as opposed to recycling a weaker password that gets weaker each time you change it. Rather than enforcing all sorts of complexity with uppercase and lowercase and numbers and non-alphanumerics, the guidance now is more towards avoiding sequential or repeated characters. Because, with compute power getting stronger and stronger, these brute force and dictionary attacks can do more work, especially if an attacker is using parallel compute, you see. And when you're repeating characters, that's making the password cracking easier yet. What we're going to focus on in this lesson in Windows Server and Azure Active Directory is the banned password list, where you've got all of the world's worst passwords. You can do a Google search. It can be kind of funny, but tragic at the same time, to see each year's top worst passwords. 1, 2, 3, 4, 5, I love you, password, that kind of stuff. But you may also, as a hybrid cloud administrator, want to make sure that your users aren't including company names, locations, product names in their passwords, because any kind of seed like that reduces the security of the password. And then we have multi-factor authentication. This is critically important. So even if an attack on a password succeeded, if the account is protected with MFA, the attacker would also have to have that second factor in order to complete compromising the account. So this is some good guidance here. Let's continue. Now, historically, in Active Directory domain services, we use group policy, particularly domain-scoped group policy, to do our password policy. And we can do things like enforcing minimum password length, password history, complexity requirements. But the issues with group policy-based passwords is, number one, it hasn't really been updated in many, many years, so it's not reflecting current best practices. But the biggest pain point was that it was the password policy, that is, was scoped to the Active Directory domain. In other words, it was too broad. What if you had work groups where you had people, users and groups, who had different password requirements? Well, I remember a time when if you really had that as a hard requirement, you'd have to create an additional domain for those users and then have a separate domain-scoped group policy-based password policy. That is a bad day indeed. But fortunately, Microsoft fixed that many years ago with fine-grained password policy, where we can scope custom password policy requirements to Active Directory groups and users. I'll demo all this stuff in this lesson, all in due time. Let's continue. This exam objective deals with Azure AD Password Protection, which is a cloud service that detects and blocks known weak passwords, and then importantly, and their variants. When you deploy password protection, the service will evaluate each on-premises Active Directory user's password change. And actually, it really doesn't matter whether the user account is entirely in the cloud in Azure AD or entirely on-prem, regardless of what your context is with hybrid identity. Azure AD Password Protection works just fine in a hybrid cloud context. And what happens is, during that password change, the value that's submitted by the user is evaluated against banned passwords lists, and those have two varieties. There's the global banned password list. This is a read-only list from Microsoft. They don't publish that list because they don't want to give attackers any unnecessary intelligence. But I can tell you, just without revealing any NDA-bound stuff, of course, that it's almost guaranteed that all of the world's worst passwords are already in that global list. So you don't have to worry about creating entries in your custom list, which is your administrator-defined list for things like I love you, 1, 2, 3, 4, 5. Those are all going to be covered out of box. Now, the custom list is great because you can put in, for instance, block words that may be associated with your business and your products and your locations. And what's especially cool about this service is that variants are automatically included. So we could create an entry for Contoso, and it would take into account casing, so you don't have to create a separate entry for Contoso with an uppercase leading C or a lowercase. It would capture both. And not only would it block the use of that word, but also variants of that word, including common letter substitutions like you sometimes see, 0 for O, $ for S, and so forth. Now, how do we actually implement Azure AD protection? Where does the so-called rubber meet the road? Well, this is a lucid chart diagram I drew that brings in what you need to know on the AZ801 exam. It's just a high-level workflow, and I'm going to bring in at the same time some salient use cases and advantages of this service. Well, I think you know the main use case. It's to improve the protection that you're offering your on-premises users. So what you do here is in Azure AD, this is where you actually enable and configure your custom banned words lists. And then without any requirement for a site-to-site VPN or express route, we're doing HTTPS TCP 443. We're communicating between Azure AD on one side and one of your member servers on the other. This is going to need to have a MSI service installed called the Azure AD Password Protection Proxy. Now you'll note that by design, Microsoft created Azure AD Password Protection such that your domain controllers do not have anything to do with proxying those requests. This is really important. There's a separation of duties. So that communication between Azure AD and your on-premises environment has to happen not at the domain controller, but on one or more member servers on which you've installed that password protection proxy. Now, there also is an agent that you need to install on your domain controllers. This winds up being a DLL, a dynamic link library, that provides the actual filtering. And then, as you know, password policy is replicated to all domain controllers by means of the sysvol special shared folder. So that's what the physical topology looks like in Azure AD Password Protection. Notice that this is completely transparent to users, so they'll continue to change their local Active Directory passwords the way they normally do. They don't have to learn any new or different workflow. This exam AZ801 objective deals with the protected users group, and this is a domain global built-in group that when you populate it, it applies non-configurable protections to those accounts. Now, what is this in more detail? What are these protections? Well, you might know that there's at least two ways to authenticate. The two main ones in Active Directory domain services are Kerberos, which is the preferred authentication protocol, and NTLM, or New Technology Land Manager, that's been around for 20 plus years, and it's largely just there for backward compatibility. Well, any accounts that you place in this protected users group, which are normally going to be your highest privileged accounts, will not be able to authenticate using NTLM. Any attempt to use NTLM during authentication will fail. Also, there's no credential caching on any machines for these protected users. And also, these protected users cannot be used in any delegation scenarios, whether you're using CredSSP or Kerberos constrained delegation. This is where you configure servers to forward credentials to additional servers when you're chaining servers together in a line. So it's an important point to consider. Yet another protection that's automatically applied to the protected users group is that reauthentication is required every 4 hours. So instead of the default Kerberos ticket granting ticket timeout period, which I believe is at least 8 hours, might actually be 12. The number is not important because that's trivia. We can get that in the Microsoft docs. I want you to take away that you can customize and shorten the reauthentication period for Kerberos. You can bring it down to every 4 hours. And obviously, that means that a compromised account would need to be re-compromised at the end of 4 years. So you're attempting to minimize or reduce the blast radius of a compromised account. Now, you should know, don't add service accounts, non-interactive identities, or computer accounts to the protected users group. This is just for interactive, administrative, privileged accounts only. Now, I want you to contrast a little bit later in this lesson the protected users group with the authentication policies that are also available, because you'll find that protected users group and authentication silos, they're not mutually exclusive. In fact, they work just fine together. But you'll find that authentication policies extend, they broaden and deepen some of the protections that you get out of box with this protected users group. I think Microsoft created this as an entry point to help secure your high privileged accounts, and then they add to that with much greater breadth and depth with authentication policy silos. But I get a bit ahead of myself. Let's proceed. Recall that an RODC is a read-only domain controller. So this is an Active Directory domain controller that's going to host a copy of your Active Directory domain database. It's also going to maintain a copy of your DNS zone. However, the read-only part is critical. The read-only domain controller receives updates from one or more read-write domain controllers, but the idea is in a remote branch office scenario, if a bad actor were to compromise the RODC, you're not going to be able to maliciously edit Active Directory or your DNS zones. Now, I'm going to review this in the demo, but when you configure an RODC, there are two groups that you need to verify membership to. Those two groups are allowed RODC password replication group and denied RODC password replication group. So here, this allows you to control which accounts can have their password hashes on the RODC. Because you might be thinking, wait a minute now, just the fact that the directory database is read-only, that's great, but if a bad actor were to steal an RODC and try to dump the password hashes, what's going on there? Well, these groups allow you to scope identities that are allowed to have their passwords cached, maybe your normal users who work in that branch office, and high-privileged accounts that are explicitly denied from having their password hashes stored in the branch office. Again, it's all in the name of reducing blast radius if the domain controller is compromised, particularly physically compromised. Another security tip for RODCs is to enforce administrator role separation. And this is where you can specifically delegate admins and scope them to the RODC in the branch office. So again, if that account gets compromised, it may be able to do some damage on the RODC. Still, you're not going to touch the DNS zone. You're not going to touch the directory database. But at least you're not compromising an account that's scoped across the domain or forest that would allow for lateral movement, you see. We configure that using the dsmanagement.exe command line tool. Another thing you can do is define a separate, different, strong directory services restore mode password that's local to the RODC. Again, if that password is compromised and you're reusing it across your domain and forest, that could be a really bad day indeed. So make sure that you've got a separate one that exists only on the RODC. Now we'll broaden our security tip scope to read-write domain controllers. What is some guidance that Microsoft gives us in this regard? Well, you want to physically secure your domain controllers. How we can do that using Windows Server features and hardware features? Well, you can make sure that your domain controller motherboard has a trusted platform module and supports UEFI firmware so that you can do secure boot, which provides integrity checking on the boot environment to make sure that any insertion or man-in-the-middle type attack is going to fail. Of course, we want to ensure that our volumes are all encrypted with BitLocker drive encryption, and you're using the TPM as a validator. So if somebody were to dump all the hard drives, like literally steal the hard drives from your domain controller, they're going to have a tough time indeed trying to decrypt those volumes. Hopefully it'll be nearly impossible. if your Active Directory domain services domain controllers are virtualized, you should consider implementing guarded fabric and shielded VMs. This supports a separation of concerns such that, for example, your Hyper-V administrators would not have privileges to the VM guest OS environment. You want to consider using RODCs for smaller branch office sites. We've already talked a bit about that. And lastly, consider using AppLocker and proxy configuration to limit or prevent domain controllers from accessing the internet. And you could also use AppLocker to block the use of web browsers. This is in keeping with the fact that we're not going to use, or we should never be using, our domain controllers for web browsing, for heaven's sake. But if a compromise were to occur where somebody were to get a remote shell into your server, you don't want them to be able to tap out into a botnet or whatever. What is an authentication policy silo in Active Directory domain services? Well, it's a method to contain privileged accounts to particular systems. So for example, think of your highest privilege groups like enterprise admins, domain admins. Your silos allow you to ensure that only members of those groups can authenticate to particular systems, like I just said. And these systems could be server machines, Windows servers, but they also could be client devices. For example, if you're using privileged access workstations, these are specifically hardened client devices that you're using for your privileged tasks. You could absolutely, assuming that those privileged access workstations were members of the domain, you could add those to your silo definition. Now, a silo is a container that includes one or more authentication policy definitions. You can create and deploy individual auth policy definitions. There's different ones. There's ones that govern interactive users, one that governs security accounts like group managed service accounts, and there's one that covers computer accounts. And silos provide a nice way to put a life cycle around one or more authentication policy definitions. Now, as I said already, the authentication policy silo feature works hand in glove with protected users. So the accounts that are policy bound should already be, it's not a requirement, but they should already be members of your protected users group, so they're already not able to use NTLM, they're already not involved in delegation, that kind of stuff. And whereas we saw that the protected users group is non-configurable protection, authentication policy does allow you to customize. For example, you can reduce the Kerberos TGT timeout to 1 hour, so you can do much more control. And also another difference between the authentication policy and the protected users group is that authentication policy and policy silos are great. As I said, there's built-in policy definitions for group managed service accounts as well as computer accounts. Now, let's do a demo and light up this theory with some practical application. In this demonstration, we'll work with password policy and password protection in Windows Server. I'm logged on to a Windows Server 2022 domain controller named DC1. And we're going to start doing a little bit of history here. Let me open up the Group Policy Management console. And in terms of traditional domain-based password policy, we can go, for example, to the built-in default domain policy. And if we edit its definition and then browse down through computer configuration, policies, Windows settings, security settings, password policy, here's the traditional list of policies that really hasn't changed in so many years. And we can override these. We could turn off a policy just by not defining it anymore. Maximum password age, maybe I want to extend that to 90 days in keeping with NIST guidelines. The minimum password age is once a password is changed, how long do they have to hold on to it before they can change it again? Then we've got minimum password length, that should be 8. Minimum password length audit, nope. Password must meet complexity requirements. And you probably already know this, but I like the fact that these group policy entries have an explain tab. And what this specifically is doing, let's take a look at it together here. That when the policy is enabled, passwords must meet the following minimum requirements. So We're screening against the user's account name or parts of the user's full name, at least 6-character length, and then from 3 of the following 4 categories: uppercase, lowercase, base 10 digits, non-alphanumerics. Unfortunately, it's just English uppercase and English lowercase. I wonder if that changes if you change the language of Windows. Somehow I really doubt it, but anyway. So that's the traditional password policy, and I've already given all the theory and background of that. So of course the comparison to that is fine-grained password policy. So here we configure this in Active Directory Administrative Center. Here we come into the domain, then we come down into System, then we come down to Password Settings Container, and I'm going to right-click and create a new password settings object. And let's maximize the screen. So let's imagine we have a team in our business who does have much more stringent password requirements due to the work that they do. So I'm going to call this password settings object Audit Team Password Requirements. If you use the hover, you get a little tooltip help here. And the precedence field says that password settings with a lower precedence number will overwrite those with a higher number. I'm going to use 2 here just to allow room for future growth. But this is how Active Directory would resolve multiple password settings objects that might apply to a single user or group. I would do everything possible to ensure having to combine these. But you'll see that the controls are essentially the same as what we see in group policy. It's cut down a little bit. So maybe we've got a minimum password length of 12, and we are going to remember, say, the last 12 passwords. The minimum password age, let's say they have to hold on to a password for at least 30 days, and they're going to change every 45. And notice that there's some account lockout settings here that you can layer in. So it gives you not everything from group policy, but some things, all right? So we've got the name, the precedence, the policy parameters, and then down here we do directly applies to. So here we'll add, and notice that it's scoping for groups and users in our directory, and I created a domain global group called Audit Team. So from now on, the idea is that if you're a member of this Audit Team group, you're going to be subject to a different set of password requirements from the rest of the domain. So that's all there is to fine-grained password policy in Windows Server. Now, lastly, let's take a look at Azure AD password protection. So let's go out to the Azure portal here, and we'll browse into Azure Active Directory. Unfortunately, the Azure AD password protection features embedded a little bit deeply. It's kind of hard to find. So let's come down into the settings, down to security. And then in the security blade, we'll go to authentication methods under manage. And then lastly, we have password protection under manage. Okay, so the way we set this up here, again, there's some password lockout options here where we set a threshold. And then the idea with an account lockout is if a user or a bad actor mistypes or does the wrong password for that threshold, then the account is locked for a duration. Here it's 60 seconds. And the thinking here is not to punish legitimate users, but to hopefully get them back in business reasonably within a reasonable amount of time. But for bad actors who may need to do thousands or tens of thousands or hundreds of thousands of attempts, if you're enforcing a lockout duration, it should make that process painful and slow enough to where the bad actor gives up and moves on to another target. Okay, so to do your custom banned password list, we simply move this slider from no, which is the default position, to yes, and then you can add in your entries here. As the tooltip says, the list can contain up to 1,000 words, case insensitive, and common character substitutions like O for 0, etc. are automatically considered. So in my fictional Contoso company, let's say that we have a product called Widget and a line of business app called, imaginatively enough, Lob App. So I've included those in the list, and I've also included the city and state where my fictional business is located. So we're enforcing these rules to make sure that users don't include obvious password stems. Because if an attacker knows that we're in Nashville and knows that our company's Contoso and knows that our product is called Widget, hopefully it makes sense that those are very ripe terms for a brute force or dictionary attack. Now lastly, this is particularly important for us hybrid cloud administrators. Password protection for Windows Server Active Directory. We absolutely want that on. And then we can do either audit or enforced. I'm actually going to do enforcement. So this is how you set up the Azure side of the equation. We then, as I already mentioned, have to install the agents on our domain controllers and at least one member server. I've downloaded both of those here on my desktop. I've got the DC agent, and then this is the proxy agent. We're going to install the proxy agent on another server. But let's install the password protection DC agent on this machine because this is our domain controller after all. It's just as simple as you saw, click, click, next. The only limitation here, as you can see, is that we do have to restart the system before the service can come online fully. While that's cooking, let's head on over to Mem1, where we are right now. And again, I have the MSI. This is the proxy setup installer. And it's the same process that we saw before. Now this one, interestingly enough, didn't require a restart. One other thing we're going to have to do on this machine, let me zoom in a little bit, is we're going to have to register the service with Azure Active Directory. So as you can see, I'm in VS Code. The blue might be a little shocking. Let me go to my controls here and go to something like PowerShell ISE. I'm colorblind, so what most people might consider a shocking color combination is just fine by me. Now I've installed the Azure PowerShell modules on the system. You can do the same thing with install module name AZ. That'll download and install the modules from the PowerShell gallery. You do connect AZ account to sign in, and then I'm going to not set my context, but I'm going to get my context to make sure that I'm connected to the correct subscription, Active Direct, Azure AD tenant, etc., which I am. Good. So let me import the module Azure AD Password Protection. This module is installed when you install the proxy agent, and then we can enumerate the commands in the module. There's not too many. Let me raise my terminal a little bit. Looks like we've got some gets. Looks like we've got some registers. That's actually what we want to do next. And then we can test proxy and DC agent health, which is pretty convenient. Those are some good commands to know about for sure. Optionally, you want to make sure to update your help so you can get online help directly in the console. But what I want to do here is get service. Let me take a look here at the service itself. It's called Azure AD Password Protection Proxy. There's also a DC agent service that's going to be running. There's also going to be a DC service that's running on your domain controllers. No surprise there, I'm sure. But ultimately, to do the actual registration, as you can see here, it's Azure AD, it's register Azure AD Password Protection Proxy. And if you check the help for this command, there are a number of different auth options. I'm just using the interactive option, where the parameter is account UPN, and then it's my user sign-in name or my user principal name, using the original name for my tenant, not my custom domain. So let me right-click, run this selection, and that's going to open up interactive flow, as you can see here. So let me come in with my account. So this allows the proxy to handshake with Azure Active Directory. And now that member server, this proxy, is going to communicate with the DC agent that's running on the domain controller. And then during password changes, we can start to consume those services. So speaking of which, let's check the status of the DC. Let's do a test Azure AD Password Protection. Let me do test Azure AD Password Protection DC Agent Health. And then let's do some parameters here. Verify password, verify forest registration, verify Azure connectivity. Forget that. All right, so now we've got the proxy installed. We know that the DC agent is installed. We're just about ready to go. There are some other picky requirements. I'm not covering everything in great depth intentionally because we are concerned with the certification, and the cert is about the high level step-by-step. You're going to want to make sure that you're using DFSR replication and not old school replication on your domain controllers. Just consult the docs as usual. So here we are on Client 1. This is a Windows 10 domain member workstation. And I'm in the middle of a password change operation with this fictional Pat user. So to change the password, obviously Pat needs to put in the old password. And then let's try a new password. I'm typing slowly and carefully here. Let me verify by hitting the little I. Let me verify. I'm using one of those online password generator tools. And then when we submit that, well, here it said they did not match. That's not helpful. Let me try that again. Hopefully, no, they're not matching yet. Let's click Next. So in conclusion, I'm submitting that if we now choose a password that's not in the global or custom banned passwords lists and is also consistent with any on-premises password policies that we may have involved, then the password change will be allowed to proceed. In this demonstration, we'll look at read-only domain controller hardening and authentication silos. I'm on my DC1 domain controller. Let me bring up Server Manager, and let's do this installation centrally here. So what I'll do is I go to All Servers. I have Mem1 already set up here. So if I browse to All Servers, you can see that I'm managing Mem1 as well. So I'm going to right-click, Add Roles and Features. We're going to make this member server a read-only domain controller, and I want to show you some of those protections that we can lay in. I'm going to make sure to select Mem1, yep, sure enough, and we're going to do an Active Directory Domain Services install, which you probably have done many, many times. We'll do an install here, and then during the promotion, we'll establish the RODC, and like I said, it'll allow us to highlight the relevant AZ801 exam skills. All right, promote this server to a domain controller. Let's get this party started. We're adding the domain controller to an existing domain, and then the credentials. Let me just verify that I'm using appropriate credentials. Hopefully I'll type the password correctly. Okay, next. All right, here we go here. We're going to do DC. Here we go here. Mistake. Here we go here. We're going to do DNS. We're going to do read-only domain controller. And let me type a custom DSRM password specifically for this RODC. Now, here we go. Delegated administrator account. Select. I'm going to make my Pat user a delegated administrator. And then for our accounts that are allowed to replicate passwords to the RODC, we want our non-administrative users. I'm going to add domain users, but I would probably in the real world want to scope that much more granularly. And then accounts that are explicitly denied, we've got administrators, server operators, backup administrators. I'm going to also add domain admins in there as well, and I also have a audit group, the audit team group, that I specifically don't want to cache any passwords there. Good, so that really sums up what we need to know for the exam here. We're not going to do install for media, and that's the rest of it. So I'm going to call this demo done at this point. I actually don't want to convert that member server to be an RODC at this time, and I'll probably, after this video, want to remove that role. Note to self, note to self. Okay, so the last part of this demo is on authentication silos, and we configure that stuff in Administrative Center. So let me open up Administrative Center. And let's head on under Authentication. we have authentication policies and authentication policy silos. So let's go into our policies and do a new authentication policy. Now, what is it that we want to accomplish here? Let's say that you have to be an enterprise admin in order to access our Client 1 privileged access workstation. So I'm going to call this Enterprise Admin Client 1. And notice that you can audit or enforce those policy restrictions. I'm going to do enforce. And notice also it says assigned silos. We haven't assigned this policy to a silo next, but we're going to. And then as we see here, there's various options here for user sign-on, service sign-on, and computer account access. In this policy, I'm just going to cut down the ticket granting ticket lifetime to 60 minutes. And we could do more here if we want to, but let's just start with that. So we'll come down to OK, and that creates our authentication policy. If we come back out of there and go into silos, we now can create an authentication policy silo, which I'll give basically the same name, and again, audit or enforce. And under permitted accounts, this is where we can include the accounts that will be in scope. So in this case, I can choose service accounts, computers, or users, and I want to specifically scope to Client 1. And at this point, I have just one member in my enterprise admins group. That's Tim. So let me resolve the Tim account. And then for authentication policy, you could either separate this out here, user, managed service account, or computer. I'm going to use a single policy for all principals that belong to this silo. And I'm going to select the enterprise admin client silo and click OK. Now, we're going to want to make sure to link Client 1 to the silo. So let me go back to Domain, Computers. Let's look at the properties of Client 1. And if I scroll down to the bottom, I can assign an individual authentication policy to the account or a silo. I'm going to do it at the silo level here, as you can see. Let me click OK. And now if we return to the silo, and go into its properties, we can see that Client 1 has been assigned that silo. However, the user account isn't yet. Well, that's easily fixed. Here we're looking at the properties of my Tim account. And if we look at the authentication policy silo option, we can include the Tim account in that silo, click OK. We're getting there bit by bit. If we come back into our silo definition, we now have my enterprise admin user, my privileged access workstation, and we're consuming the enterprise admin client silo. So far, so good. I want to make one more tweak to the policy itself. So let's go to the specific authentication policy. And again, now we can see, and then if we scroll down under user sign-on, we can create a condition here. Let's go to Edit for sign-in condition, and we'll add a condition. And the condition here is that the user authentication silo needs to equal the name of the silo, which in my case is Enterprise Admins Client 1. So let's click that. And let's add one more condition to that Enterprise Admin Client 1 policy. Let's come down under Computer, and let's add a condition specifically for the computer. So add condition, and we're going to say where the user authentication silo equals enterprise admin client 1. Okay, well, it looks like we finished our configuration from an authentication silo point of view. However, there's one more thing we need to do from group policy. So let's open up the group policy management console, and we need to enforce Kerberos armoring. And we need to do that both for our domain controllers as well as for our users. So for the domain controllers policy, let's edit that. And what we're going to want to do is go into Policies, Administrative Templates, System, KDC. And for our domain controllers, we need to turn on this KDC support for claims, compound authentication, and Kerberos armoring. So let's enable that policy for that. Make sure that that link is enabled. And then for default domain policy, we're also going to want to go in there, and it's almost the same path. In fact, it might be the same path. It's going to be Policies, Administrative Template, System, but this time it's Kerberos. And we're going to need to do the same thing. Kerberos client support for claims, compound authentication, and Kerberos armoring. Great. So now we need to make sure that we refresh group policy. So I'm going to do an invoke GPO update. So now we need to enforce a group policy refresh, and then we can test. I'm going to do an invoke GP update locally, and now I'm going to do an invoke command on client 1, doing the same thing. Add a force on that. So lastly, let's check this out. Let's test by opening up a remote desktop connection as a user who's outside the scope of the silo. So let me try pat@contoso.com. Let me enter the credentials here. And this is the expected response here. So the silo is preventing sign-in here. It says the computer you're signing into is protected by an authentication firewall. The specified account is not allowed to authenticate on this computer. So that's certainly expected behavior. Now, if we try the same thing again, this time with, let's show options. Let me do a tim@contoso.com. Let's connect. Put in the password here. Type that in carefully. That does allow us to get to the desktop. So there is the authentication silo in action, behaving as expected. Welcome to Lesson 3, Secure Azure AD Identities. In this lesson, we start with learning ways to restrict access to our Active Directory Domain Services domain controllers. Next, we configure local and domain account security by using Microsoft proven practices. We then administer AD built-in administrative groups and configure delegation using both CredSSP and Kerberos. Finally, we cover how Microsoft Defender for Identity can protect your local Active Directory environment. Let's get started. Now, of all the computer accounts in your domain, hopefully it makes sense that domain controllers, from an identity standpoint anyway, represent a key vulnerability. So what are some ways that we can ensure that only authorized high-privileged accounts can access your domain controllers? Well, one way, the most common way historically, is to use group policy objects. Specifically, there are a number of user rights that you can configure. Access this computer from the network would be one. Log on locally is another one. There's deny logon through remote desktop services. There's some other ones. But this, like I said, represents a convenient way to lock down your domain controller access. And as you know, group policy is periodically refreshed, so it will be current based on how you configure the GPOs. Another option, again configurable through group policy, is restricted groups, where we can enforce membership in high privilege groups on those machines. Yet another way we can restrict domain controller access using group policy is with Windows Defender Firewall with Advanced Security Network Access Groups, or NAGs. I'll show you more about this in the demonstration. Basically, this is where you can isolate your domain controllers such that they only can be accessed with particular programs, ports, and protocols based on Active Directory group membership. Lastly, there's authentication policies and authentication policy silos. We cover these in great depth later in the course, but for this point, let me just say that authentication policies and silos allow you again to restrict access on particular machines to access from particular users and groups. Well, the AZ801 exam is concerned with privileged account management, but not with groups and user accounts you create so much as the well-known built-in ones. So a common technique is to rename or disable the well-known accounts. You know, administrator and guest. So the administrator account particularly is a well-known security ID or SID value. So this means that bad actors know what that SID is. So renaming the built-in administrator account is only of limited benefit from a security perspective because of that reason, that the well-known SID is known. And that SID is not going to change if you change the administrator account from administrator to foo, let's say. For this reason, some shops will actually disable, not only rename, but disable the well-known administrator and guest accounts such that they are more difficult to leverage. First, they would have to be identified, of course. That's fairly trivial. And then they would have to be enabled, which hopefully is not a trivial operation. Another option is to implement Local Administrator Password Solution, or LAPS. This is an add-on to Windows Server, and what it does is it randomizes your local administrator passwords. So when you think about your fleet of member servers in your data centers, and also, frankly, think of all of your Windows 10, Windows 11 client devices, they all have a local identity database that includes those well-known accounts. And if you do need to maintain those administrator accounts on those member servers and those workstations, you know, one idea is to rename them. Another, when you implement LAPS, this means that the local administrator password, instead of being static, which is how I came up as a systems administrator, using the same local administrator password across the domain, it certainly makes management easier, but it makes securing the infrastructure much more difficult, is where Active Directory will randomize and then regenerate that local administrator password. And there's a UI tool that you can use on your domain controller when you need to sign in. Using the local administrator, you can just look up what the auto-generated password is. Some other ideas from Microsoft include implementing the Protected Users Global Group. This is a built-in domain global group that when you put high privilege accounts into that group, it immediately prevents those accounts from doing things like participating in Kerberos delegation or Cred SSP delegation. Long story short, protected users is an easy way to apply a bunch of built-in protections to those identities that are in that global group. I mentioned a couple minutes ago authentication silos. There's some overlap in functionality between the protected users group and authentication silos. You can also do things like restrict the Kerberos ticket granting ticket, or TGT, lifetime, so you can force reauthentication. And that value is hard-coded in the protected users group, but you can be much more intentional in those timeout values when you use authentication policies and silos. The admin SD holder is, I define it as a template container in Active Directory domains that refreshes permissions on protected accounts every 60 minutes. Now, when I say protected accounts, that's different from the protected users global group. Protected users is empty by default, and then you as a domain administrator would populate it with high privilege accounts that you want to apply those protections to. Admin SD holder is intended to make sure that if a protected account has its access control list, its user rights modified by a lower privilege account, particularly if there's some sort of breach, lateral movement, etc., that within that 60-minute period by default, admin SD holder would restore the original user rights and access control entries on those accounts. So you might wonder now, Well, what are those protected accounts? You could check the Microsoft Docs, look up their articles on admin SD holder, and it lists those protected accounts. They're basically the highest privilege group accounts, like enterprise admins, schema admins, domain admins, the domain administrator account, the ones that are the most powerful groups and user accounts in your Active Directory domain and forest. Speaking of built-in Active Directory administrative groups, let's go a little bit further with that with this next skill called Manage AD Built-in Administrative Groups. And what I've done here to illustrate the point, and again, we're talking about the most highly privileged built-in groups. I want to make sure you understand their scope and default behavior in an Active Directory domain services domain and forest. This is a diagram I made in Lucidchart as usual. So we've got on the left-hand side, on your domain controllers, particularly the first domain controller in your forest root domain is going to have the enterprise admins group. And this is obviously a group that you want to very carefully control access to. The only member of that group by default is the administrator account, the initial domain. The initial administrator of the forest root domain gets, again, the most highly privileged user account in the entire forest. And that enterprise admin group gets populated or nested into the administrator's domain local group that's available on all of your domain controllers by default. And that association means that anybody who's in enterprise admin has full administrative privileges on every domain controller, which I'm sure you understand that's definitely what you want if you need to extend the schema or do real high privilege operations that go across your domain controllers in your domain and across your entire forest for that matter. That's where you get that linkage. Now, the domain admins global group is automatically populated into the local administrators group on both member servers and member workstations. This provides an easy way to give a user administrative privileges, local administrative privileges on domain member servers and workstations. They just can, out of box, get those permissions. I'll show you that in the demo just to make sure we're clear on that nesting relationship, but that's how these built-in AD administrative groups are implemented at base in order to give you out-of-box management for your domain controllers, member servers, and member workstations. In this first demo, we're going to tour the various built-in high-privilege groups, and I'll show you some different ways that we can handle delegation and least privilege authorization. We're starting in the middle of things here. I'm on a Windows Server 2022 domain controller named DC1. And I've got a custom MMC console up here with Active Directory users and computers and group policy management, and also the local computer management console on a domain member server named Mem1. And I want to start with touring Active Directory users and computers with you, starting with the users container that has our various built-in groups. Kind of weird, that's my technical term of the day, by the way, weird. That we've got the built-in container that has just our domain local security groups, and then our users container, which contains, by default, our users that we create the built-in administrator account, which I've already renamed. We've got some built-in universal, global, and domain local groups in here. But the most important one here, as you can see, is enterprise admins. This is a universal group. The member, by default, it's just the original domain administrator from the forest root domain, okay? Then we've got our domain admins global group, and the members there, again, totally up to you, but that one has some additional stuff baked into it. And by stuff, if we come over to a member server and we look at the local users and groups on that machine and go into groups and take a look at the local administrators group, as I had mentioned before, Active Directory, upon domain join, will populate the local administrators group of your member servers and domain workstations with the domain admins global group to give you that far-reaching administrative access. Okay, so back to our domain here. Let's go back to users. What else did I want to point out here? Well, actually, if we go to built-in, we can look at the domain local administrators. And as I had mentioned before, this is auto-populated with enterprise admins and domain admins. And all domain controllers in your domain will each have the same administrators group, as you can see here. Okay, good. One more thing, but wait, there's more. There's always more, isn't there? I want to come back to users one more time, and here is that protected users group. And as it says, this is a global group. Members of this group are afforded additional protections against authentication issues. So we've got a reduced Kerberos lifetime. We can't do delegation. Another important aspect of the protected users group is that the users in here can no longer do down-level NTLM authentication. It would be Kerberos only. And that's a read-only set of protections, and notice that the membership list is empty by default. So you're responsible for populating the protected users group if you do want to implement it. Now, about delegating administration, normally I would do that at the OU or organizational unit level. So if here in the HQ staff OU, if we had support folks who needed to just take care of resetting passwords and this kind of stuff, we can open up the delegation of control wizard by right-clicking the OU and going into delegate control, and we can step through here. First, we would choose who are we delegating control to. Let me go and search for my audit team global group. Let's say we wanted to give them the delegated permissions. Next, here we have common tasks, or we could get right down to the Active Directory schema, but the common tasks are normally pretty useful here. Reset user passwords is a pretty common one. Next, and that's really all there is to it. There's a delegwiz.exe command line that you can use, and there's probably that capability wrapped into PowerShell as well, but just wanted to drive by that for. Okay, so now let's shift our focus to group policy management, and let's expand our domain and see what we've got going on here. I've got in my, let's see here, Windows Clients has a GPO in it. As far as the user rights and restricting access to domain controllers and that kind of stuff, might make sense that we take a look. The settings are the same, of course, in any group policy object. But let's take a look at the default domain controllers policy, which is going to apply to your domain controllers by default. And we'll go under computer configuration. And everything we need is in the path computer configuration, policies, Windows settings, security settings. We've got our account policies, including password policies. We have our local policies where you can do audit policy. And then lastly, we have user rights assignment and security options. Let me make sure to sort these policies in alphabetical order. User rights is where you can customize some of those high privilege actions like I mentioned. Access this computer from a network. Log on locally is an important one, because if anybody is denied log on locally explicitly in your domain, that would be an easy way to prevent access. Matter of fact, you might have noticed that if you're not an administrator or a delegated administrator, you cannot log on interactively on a domain controller. Look here, the allow log on locally policy is already pre-populated. And basically this is it, administrators, and then there's some common sub-administrative built-in groups that have been in Windows since the very beginning. And you can modify that to suit your taste. And then we have under security options. This is where you can, through policy, disable the local administrator and group accounts, as you can see using these policies. And we also have an important rename administrator and rename guest account that will allow you to do that. And you could do these same things, of course, in an OU or domain scoped policy that would affect your domain member servers and domain member workstations as well. I had mentioned in passing the Windows Defender Firewall with advanced security, the concept of network access groups, and that takes a couple different forms. One would be, for instance, if we could do inbound rules for those domain controllers, where we say that it's a custom rule that affects, if we wanted to be really global and intentional, we could say all programs, all protocols, all ports. Which local IP addresses, which remote IP addresses does this rule apply to? And then to get into the user and group level, we can allow the connection if it's secure, customize how we're doing that. This is going to involve things like integrity checking with Kerberos or digital certificates, authentication, and we can also layer in IPsec data encryption. But then here we go, the users, authorized users. Only allow connections from these users. So this is the concept of the network access group. So you might create a global group that consists of only those folks who should be allowed to access these domain controllers and make sure that they're indicated on this list. And as I said, the benefit that Windows Defender Firewall with advanced security has are those connection policies where you can layer in authentication and encryption with IPsec. Lastly, in this demo, let's take a look at the Local Administrator Password Solution, or LAPS. And what you'll want to do is download the LAPS MSI, and you're going to need to install this not only on your domain controllers, but also any machines that will be managed by LAPS. In other words, the local administrator passwords being managed. There's two aspects to this solution. Let me go to Change and show you. On your domain controllers, I would suggest that you load up everything, which gives you PowerShell, a graphical user interface, your GPO templates with policy options, and the GPO client-side extension. On your domain members, that is your member servers, your domain workstations, you also need to install the LAPS client here, but all you need is the GPO extension on those, all right? So once you've done that, yes, I want to cancel because I've already deployed that MSI in my environment. You complete the configuration back in group policy. I'm still looking at the default domain controller policy, so let's go back to my management console. And I created a GPO specifically targeted to my Windows client's organizational unit that has my Windows 10 workstations in it. I've called it LAPS. And if we head on in there, let me show you where the specific policy exists. Well, it won't be there unless you install the client-side extension, but as long as you've installed that CSE, it shows up under Computer Configuration Policies, Administrative Templates, LAPS. And as you can see, I've enabled all four of these. You start with do not allow password expiration time longer than required by policy, because you don't want to interrupt or mess up. You want to make sure that LAPS has the room it needs and that won't get overridden by a password change policy you might have otherwise in your environment. There's also name of administrator account to manage, and this is where you can provide either the built-in administrator identity, or if you renamed it, or if you're using another account, you've disabled the administrator built-in account and you're using a custom local administrator account. You just provide that identity here in your policy. And then for password settings, this is where you can customize when LAPS auto-generates the password. What kind of combination or complexity rules do you want it to use? I find it kind of interesting that instead of saying uppercase and lowercase, the UI says large letters and small letters. That's very strange indeed. Then we have password length and password age, which is the regeneration or rotation interval. Okay? I almost forgot. There's one more configuration that's actually critically important. Oh boy, I can't forget about this. No, it's when you install the LAPS. Remember I said the UI showed us there that you get a PowerShell module? Well, we can't forget about extending the Active Directory schema. Oh, that little detail? Yeah. We need to make sure that lapse is allowed in your AD schema because, this is a pretty high impact operation. You're giving this capability, the ability to reach out and change local admin passwords on who knows how many server and member workstation systems. So in my PowerShell script here, notice that I'm first importing all the commands. The PowerShell module is called admpwd.ps. And if we run a get command, there's just a handful of commands in the module, many of which you just need one. The main one you need here is update admpwd AD schema. This adds the appropriate schema extensions that lapse needs to do its work. Then you run set admpwd computer self-permission on the organizational units that contain the machines that you want lapse to monitor. Once you've done that, you should be good to go. And if you chose to install the lapse UI tool, this provides a great way to look up that local password that's being stored in Active Directory. So I can look up my Client 1 workstation in the directory, and it tells us what the password is, which I can just copy out and use if I want to log on to Client 1 using the built-in local administrator account. And then we see the current expiry of the current password, and then we can override and create a new expiration and then do a set. So it's nice that we have this UI. There's also lapse capability in PowerShell, like I said, but the UI is a pretty convenient tool. There's no question about it. Now, delegation in terms of Active Directory vocabulary means that you're offloading some administrative responsibilities to a lower privileged account, specifically delegated administration. We want to think about least privilege authorization. I mean, we could have an entirely separate discussion on that question of running as a standard user rather than as an administrator on a workstation, and making sure that you're giving your support staff some administrative privileges through delegation, but not just granting them the keys to the kingdom. Now, that skill set is encapsulated in the Microsoft certification portfolio in the Azure Security Engineer credential, for which there's one requirement, the AZ-801 Azure Security Engineer certification exam. And we get into that in that skill set quite a bit. I actually have done a Microsoft Press video course for AZ-801 if you're interested. But coming back to Active Directory domain services, what are some ways that we can do delegated administration? Well, again, historically, the most common way perhaps, in the Active Directory Users and Computers MMC console, there's a delegation wizard where, for instance, at the organizational unit scope, you can grant your support desk the ability to reset passwords and that kind of stuff. But that delegation would not go into, say, creating user accounts or deleting user accounts, that kind of stuff. We want to think about least privilege. And again, least privilege authorization refers to granting permissions for security principals to give them the permissions they need to do their work, their legitimate scope of work, but never to overprivilege those identities. Now, an entirely separate type of delegation, a more programmatic type of delegation, is credential delegation. And the two options here are CredSSP, which I see in my practice most of the time in the scope of PowerShell remoting. When you're issuing PowerShell commands, say from your administrative workstation to multiple servers, and particularly yet when you're working on one remote server and then you need to go from that remote server context to yet another server. It underlines, I should say, the so-called Kerberos second hop problem. I have a slide on that in just a minute. The other way to do credential delegation that's much more general purpose is using the Kerberos protocol itself to do constrained delegation, where you can mark identities. These could be group service accounts or group managed service accounts, and computers. These are most likely servers, and you can allow them to forward credentials from machine to machine. And the constrained part means that you want to not just do a blanket, this computer can forward anybody's credentials, but you want to constrain that delegation. This particular server can forward this particular user's credentials, and that's it. You see what I mean? Again, keeping in mind least privilege. So let's take a look at this second hop problem. Again, I have a diagram. Hopefully it'll make it easier to understand. So here we are on our administrative workstation. And let's say we're going to use PowerShell to do some remote work. So we're going to issue commands. Maybe we'll create a remoting session with server 1. Now we're going to authenticate our credential on server 1. Let's say it's my Tim credential. And that's fine. We're using Kerberos authentication. We're good to go. However, the problem comes in if when we're logged into server 1 remotely, we now want to issue commands to server 2. Under which or whose security context will those remote commands run? Well, let's assume that I want those remote commands to stay with my Tim account. So this means that server 1 is issuing commands to server 2, but not with its own credential, but with somebody else's, mine. By default, that's not going to work. That's called the Kerberos second hop problem. And it's not actually a problem. It's actually by design. Server 1, basically, if you don't mind the personification for a moment, is saying, oh, wait a minute. No, I don't have any rights or privileges to impersonate this user here. I can only stand on my own 2 feet, as it were. You see what I mean? So therefore, the CRED SSP or Kerberos constrained delegation solutions are ways that you can, in fact, configure server 1 to forward a particular user's credential and allow that to work such that I could send remote commands to server 1, and then from server 1, I can send remote commands to server 2, and server 1 would be okay with forwarding my credentials to server 2, and as long as I have those permissions on server 2, my PowerShell scripts and commands will succeed. You see how that works? Well, Microsoft has a habit, you can call it a good habit, neutral habit, or bad habit, that's fine, of renaming and rebranding products. Well, we now have a whole catalog of Microsoft Defender cloud-based products. Defender for Identity was at one time called Advanced Threat Protection or Microsoft Defender Threat Protection. I think it was Windows Defender Threat Protection, but what you need to know now in 2022 is that the product is Microsoft Defender for Identity, or as the Microsoft folks call it, MDI for short. And this is a cloud-based, artificial intelligence-powered security solution that can do a lot of heavy lifting for you and your fellow administrators. It can help you identify, detect, and investigate identity-related problems in your local domains, like compromised identities. That's a big one. Malicious insider user actions, so-called advanced threats. Well, how does it do that? What does it do? Well, what's happening is that you're allowing a communication and trust channel between your local domain controllers and the MDI service. And the AI-powered means that Microsoft has built up machine learning AI models that can look at signal logic, that is, look at behavior of your domain users from moment to moment. And hopefully it makes sense that the longer MDI can scan your local environment, the more targeted and focused its predictions can be. That MDI learns what normal behavior is for your identities. So if it starts to see anomalous behavior, it can immediately trigger alerts on that. You see what I'm saying? The main components of Microsoft Defender for Identity are twofold. One, you need an instance of the service, and there's a separate web portal, atp.azure.com, for that service. And it's not free, you'll need a license. That license can either be a standalone license, or if you have the EMS E5 license, that'll work as well. But that will give you access to the cloud service. And then you'll deploy the MDI sensor on your domain controllers. And because MDI works with HTTPS and TCP port 443, there's no dependency on a VPN, a virtual private network, or an express route circuit. You can go directly over the internet. I have a couple screenshots here. I was working just today and preparing this lesson, and I saw this in my email box. Remote code execution attempt was detected in my local domain. Wow. Now notice it tells me right away who made the attempt. That's Tim Warner. It's a local Active Directory identity. And where the attempt was made, it's on my DC1 domain controller. From where was it originated? That's client 1. That's, again, a known domain workstation. And the remote code execution was PowerShell. And notice the options. You can download Excel file with the details. You can take a look by signing into the MDI portal, and I did that. I signed into the portal, and again, notice it's showing us graphically what it saw, and in this case, it's a known identity, a domain user account on a known domain workstation, issuing remote code on DC1. And what was the evidence? Well, Tim Warner not previously observed logging on to Client 1 during the last 30 days, so this is considered anomalous behavior by MDI. And then what I think is really cool, you see a full command-by-command audit trail of different PowerShell commands, Windows Remote Management powered PowerShell commands, get command, blah, blah, blah. Now, that provides a nice story that we can use in our security investigations. Now, the reason I'm not panicked at all is that I actually did work with some remote PowerShell on Client 1. I was remotely configuring my domain controller using PowerShell. So this is expected behavior. And so the last thing I'll say before we do our second demo is that you can use the Defender for Identity portal to begin to create exemptions so that you will find a better separation over time between so-called signal and noise. Because this is really noise. It's expected behavior that I don't necessarily want to be nudged on. But if another user who shouldn't be issuing remote code is doing so, I definitely do want to know about that, you see. In this second demonstration, we're going to do two things. I'm going to show you credential delegation for PowerShell remoting with CredSSP, and then we'll take a brief look at Microsoft Defender for Identity. So the idea here is that I'm doing some PowerShell remoting where I'm on a Windows 10 system named Client 1, and I'm now on line 5 in VS Code. I'm going to establish a PowerShell remoting session on mem1. First of all, let me close my existing session and clear the screen. That'll be kind of helpful. But let me try this again. Right-click, run selection. So now I'm on mem1, and now from within that context, I'm going to attempt to invoke a command on DC1 and just run a trivial get Windows feature command. And what we'll expect to see is it to bomb out with this red text, and it's mentioning Kerberos. So this is that second hop problem I told you about before, all right? Now, we could use Kerberos constrained delegation, but I find for PowerShell remoting CredSSP provides a convenient workaround. So what I'm going to do here is, first of all, on line 10, we can see that built into PowerShell are 3 CredSSP commands, disable, enable, and get. And I'm going to set up my workstation as a CredSSP client, as you can see on line 13. Enable WSMan CredSSP role of client, and the delegate computer is, what I'm going to do is start by setting up my workstation as a client. Enable WSMan CredSSP role client. The delegate computer is mem1, and I'm going to force that. Actually, let me put in the full DNS name of that machine. So that's going to establish my client side of the equation. On the server side of the equation, we have a matching enable WSMan CredSSP. Here on line 16, I'm invoking the command on mem1, where I'm passing in enable role server force, okay? So that's what I need to do from a PowerShell standpoint. What I also have done, and what you'll have to do, is allow delegating fresh credentials in group policy. So here I am in my default domain policy, and I've come under Computer Configuration, Policies, Administrative Templates, System, Credentials Delegation, and I'm allowing delegated fresh credentials. I enabled the policy, and then add server to the list. It's going to be WSMan / and then the name of the delegate computer. We're just concerned with the first entry here, mem1.contoso.com. Now I've done that and I've propagated group policy, so we should be good with that. So now let's finish by running this PowerShell. We come back with good confirmation on the client configuration. Now let's do the same thing for mem1.contoso.com. We're going to invoke this command and configure that machine as a server. Now, you can always echo back the machine's CredSSP configuration by doing get WSMan CredSSP, and it tells you in human output, human readable output, This machine is configured too. So in this machine, my client is configured to allow delegating fresh credentials to either of those targets that came in from group policy, DC1 and also MEM1. And then it says the computer is not set up to receive credentials. I can tell you that if we run this command on MEM1, we'll see just the opposite. So now to test this out, we can do the enter PS session again. So to finish this up, notice on line 18, I just ran this command, enter PS session, where I'm providing the fully qualified name of the server. I need credential and authentication cred SSP here. And notice down below, I authenticated and now I'm hooked into MEM1. And now to test that cred SSP is going to allow MEM1 to forward my credentials. We can try an invoke command against DC1, where in this case I'm going to just pass a simple script block of get uptime. Press enter, and then we get the results back. So that's working just fine. Now, in terms of disabling, if you decide that cred SSP is not what you want to do anymore, you'll just want to run disable wsman cred SSP on both the client and server sides, which you can see in my code here on lines 20 and 22.
Welcome to Lesson 4, Manage Windows Server Security with Azure. This lesson has two objectives. First, we learn how to monitor servers by using Azure Sentinel. Then, we identify server issues by using Azure Security Center, now called Microsoft Defender for Cloud. Besides the fact Microsoft renamed both of these products since they were first introduced, you'll be able to differentiate the two services and understand Microsoft's intent with each. Ready to begin? Let's get to it.
Well, I want you first of all to note the product name change. Now, Microsoft Learning will eventually update the AZ801 objectives to reflect the current name of this product, but don't think that this training course is outdated because I'm referencing Azure Sentinel. With Azure, name changes and product and feature name changes are just a way of life. So I want you just to understand the history, that the product Sentinel used to be called Azure Sentinel, and then probably to reflect the fact that Sentinel can monitor non-Azure and even non-cloud resources, Microsoft changed the name. So what is Microsoft Sentinel? It's a cloud-native SIEM/SOAR solution. Now what is SIEM or SIEM? That stands for Security Information and Event Management. And SOAR stands for Security Orchestration, Automation, Response. The pillars of Microsoft Sentinel are data collection, where you can send your security-related events, log data, etc. into Sentinel, not only from your Azure resources, but if you're multi-cloud, you can onboard resources from, say, Amazon Web Services. Of course, you have your local points of presence if you're maintaining an on-premises IT infrastructure. As well as in Sentinel, there are connectors for enterprise firewalls and routers and these sorts of things. So the idea with Sentinel is that this is a service intended for the full-time InfoSec team at your organization, and they can use this to plan and monitor security for your entire environment. It's really quite universal. Speaking of which, the detection engine here is twofold. On one hand, we have the Microsoft Threat Intelligence backend, all of these machine learning models that Microsoft has developed. When you think of all the signal logic that the Microsoft Cloud Platform sees each day, they're able to train up these artificial intelligence models that can make very accurate predictions based on real-time data. For instance, do you have any virtual machines that may currently be undergoing port scans or brute force attempts? Maybe anomalous detection or anomalous actions are detected in some of your data products. See, so you can get a good heads up on detection, not only automated detection and alerting, but you can do what's called threat hunting using a query language that Microsoft developed internally and now is given to their customers called Kusto, K-U-S-T-O. It's a query language that resembles Splunk quite a bit if you're familiar with Splunk Monitor. Now, Investigate pillar refers to the Jupyter notebooks that are built into Microsoft Sentinel. These are specialized web pages where you and your team can collaborate. You can combine markdown formatted text with live code. So you can actually do your investigations and track everything and assign tasks all within a single platform. And lastly, we have automated response. Here we have the concept of the playbook. This is an Azure Logic App. If you're familiar with Logic Apps, these are business workflows that allow you to stitch together different application programming interfaces or APIs without you having necessarily to understand the REST API definitions. It's a cool service, and there's actually a consumer version of Azure Logic Apps. You might have heard of it. It's called Power Automate, part of the Power Apps platform. Now let's take a look graphically at Azure Sentinel architecture. The first thing I want you to see, okay, let me bring out my drawing tools here. Starting at the top of the diagram, before we create our Azure Sentinel instance, we have to have a log analytics workspace. And this can be looked at as a massively scalable log ingestion engine. And in the real world, I always recommend that clients have separate log analytics workspaces for your infrastructure monitoring and your Sentinel monitoring. So assuming that you've created a separate workspace for Sentinel, Sentinel, as I said, requires a workspace to do its work, you're then ready to begin ingesting data from data sources. And just to give you a quick glimmer of some of the possibilities, you can see here, as I had already mentioned, we can have our Windows Server Azure VMs reporting into Azure Sentinel. In other clouds, for instance, we may have Windows Server running on Amazon EC2 instances in AWS, and we may be doing security monitoring with AWS CloudTrail. That's fine. We can bring that into Sentinel. And then in our on-premises environment, we can either onboard physical or virtual servers directly into Sentinel, or if we're using Azure Arc for servers, we can bring Arc-enabled servers in. What makes this happen principally is the log analytics agent. And this is a Windows service that uses TCP 443 by default. You know what that means. That means there's not going to be a requirement for either a site-to-site VPN or an express route circuit, nor will there be a lot of firewall ports that you and your fellow administrators need to open. So it really is quite universal. The idea is once you've got your data reporting in other words, your servers reporting into Sentinel, then you can begin to use the Sentinel control plane to do your actual reporting, alerting, investigations, and so forth. Let's go over deploying an Azure Sentinel instance from a top-line point of view. As I said, you need to have a log analytics workspace available. Assuming you have one of those, you can then deploy your Sentinel resource. You can deploy Sentinel in the Azure portal, or you can use a Azure Resource Manager template, a bicep template, however you want to do it. Then, as I mentioned, you'll want to spend time onboarding your servers and installing data connectors. You then can define watch lists as a way to round up. I mean, it can be a little bit too easy, just in my candid opinion, to get alert and notification fatigue from Azure Sentinel, especially if you're really going all in and you're monitoring your entire infrastructure. So watch lists make it a bit easier for you to create groups of events and groups of resources, groups of environments that you're looking for, just to make parsing that alert stream a little bit easier, okay? And then, as I'd mentioned, we've got this notion of proactive threat hunting, where you can use the Kusto query language to write queries. For example, maybe there's a problem with a Windows update, and you can write a Kusto query that rounds up any servers that have that particular update installed. And you then can wire up playbook automations to take automated actions to maybe uninstall the update, reboot the server, whatever it is you need to do. And again, playbook is simply a synonym that Azure uses both in Sentinel and in Microsoft Defender for Cloud for Logic App. Lastly, although this slide says Azure Sentinel, remember that as of 2022, Microsoft has renamed the service. And who knows, by the time you're watching this lesson, maybe the service will have been renamed again. But I want you to think in your mind, if you do happen to see references on your AZ801 exam to Azure Sentinel, I want you to substitute Microsoft Sentinel in your mind. In this first demo, I'm going to show you how to deploy Microsoft Sentinel and onboard your Windows servers in particular. I'm here in the Azure portal, and what I'm going to start with actually is going to my log analytics workspace. Because as I said, you'll want to have separate workspaces for your infrastructure monitoring. That's my TIM workspace, and my Sentinel monitoring, which is this second workspace over here. And as I said, a workspace presents a data warehouse, essentially, where you can ingest log data and telemetry in a hybrid cloud, multi-cloud environment and report out it in one spot. So you've got your workspace. I've created MS Sentinel workspace. Then you can create your instance of Microsoft Sentinel, which I've already created. But the way this works is if we click Create, you'll notice that the very first thing we have to do, actually the only thing we have to do, is to associate Sentinel either with an existing workspace, or we're given the opportunity to create a new workspace at this point. And it looks like as of early 2022, Microsoft Sentinel has a 31-day free trial, which represents a good learning opportunity for you for sure. All right, so I've already got my Sentinel deployed, so let's go into that Sentinel workspace. And it's a totally different interface from using just regular old log analytics. That's obvious because Sentinel has a very different purpose. We can see on our overview page just a roll-up of events, alerts, and incidents. The incident is particularly useful because this is where Sentinel attempts to correlate events or individual discrete actions that may trigger alerts. You may have a series of alerts and events, but if you just saw them in a singleton list, it might not be obvious that they're related to a single incident, you see. I'm getting a little bit ahead of myself. Here, let's come down in the Sentinel workspace, and we can go under Configuration Data Connectors. And this is where you can access not only Microsoft-provided connectors, but them from all sorts of other environments. For example, we might want to bring in Microsoft Defender for Cloud and monitor it from within Sentinel. That makes sense, doesn't it? In fact, you see a lot of built-in connectors for the Microsoft Defender platform. So we can select Microsoft Defender for Cloud, and when you bring in a connector, each one brings with it some related content. A workbook, if you're familiar with this came about in Azure Monitor, is a pre-created collection of visualizations. And these can be useful because you and your team may not know necessarily what metric and log data is highest impact given a new connector. So you can use these artifacts as a good starting point. So workbooks are interactive visualizations. Queries are threat hunting KQL queries that you can modify. And then we have some rules for creating alerting and that kind of stuff. We'll want to onboard the connector. And the instructions here are going to be completely up to the vendor of the data connector. Hopefully it makes sense that it's a lot easier to onboard a Microsoft connector than it would be a third party in terms of authentication and authorization, identity federation, and that kind of stuff. So let me open the connector page here. And what do we need to do? Looks like we just need to connect our subscription. And it looks like we've got that action. Create incidents automatically from all alerts generated. Okay, I'll enable that as well. And there you have it. Let's go back to the connectors page. What's something else we might want to bring in? How about Azure Active Directory? If we are using Azure services, in other words, we're monitoring resources in Azure, hopefully it makes sense that we want to onboard this information as well, particularly sign-in, risky users. These last three are coming from Azure AD Identity Protection. Again, we'll open the connector page, and because it's a Microsoft service, we can simply select what we want to capture and then apply the changes. Let's come back to Microsoft Sentinel again. There are ways to tap into the security log on Windows Virtual Machine. You know, it just goes on from here. And like I said, just to demonstrate, you can onboard other clouds, like we have a connector here by Amazon that collects AWS CloudTrail data. And just to demonstrate this is going to have more configuration. We're going to need to create a trust relationship between your AWS account and your Sentinel instance. But it's not too difficult to do. That should be a one-time operation, and those connectors are then going to populate, as I mentioned, in other aspects of your Sentinel environment. You have your analytics rule definitions. There's the watch lists that I was telling you about a moment ago. We have, if we scroll up to hunting, this is your KQL script library, where you can run queries, and you can even have those queries run on a loop and generate alerts when they, for instance, return a row. The notebooks is the Jupyter Notebook infrastructure, which is a way for you and your team to just track and document your investigations. It's a great platform. Of course, Microsoft doesn't own Jupyter. This is an open source project, but I'm happy that it's natively embedded here. Jupyter is actually available in a few other Microsoft Cloud Platform services as well. Threat intelligence, this is where we get into the Microsoft AI backend. And then I want to close this particular demo showing you how you can onboard your Windows Server machines. Because after all, we're concerned with the Windows Server hybrid administrator role. And frankly, as a systems administrator, you're not the intended audience necessarily for Microsoft Sentinel. Now, Microsoft Defender for Cloud, absolutely. But Sentinel is really for dedicated InfoSec professionals. Okay? So, how do we onboard those machines? Well, let me come down under Settings at the very bottom, and then we'll go to Workspace Settings. And this is a classic log analytics interface. If you've used log analytics for infrastructure monitoring, then this should look very familiar indeed. And what we can do here is come under Agents Configuration, and this allows you for your Windows machines and Linux, but remember, we're focused principally on Windows here, to specifically bring in certain event logs. So you might want to make sure to collect, in this case, if you're interested in security, there's a whole bunch of different options here. Maybe you're doing IPsec rules, etc. You just want to bring in these event logs and decide the verbosity that you want them to report. Same thing with the performance monitor counters. You can bring those in. If the monitored machine is running IIS, you can bring in those log files. So this just gives you a bit more insight or control into the events that are coming off your Windows servers and into your Sentinel workspace. Now, as far as specifically onboarding those Windows machines, doing so in Azure is really simple, actually. Let me jump out of Agents Management for a second. If I come down under Workspace Data Sources, see this virtual machines? It looks like I have 3 machines reporting into this workspace. Now, the thing that I want you to remember about the Log Analytics workspace is that the VMs you see here are going to be in Azure, right? They're going to be Windows and Linux, but the main thing is that there's not a region limitation. You know how in virtual machines there's oftentimes a hard restriction, for example, that your virtual machines and your virtual network needs to be in the same region, this sort of thing. That's not at all the case with the Log Analytics workspace. So we can onboard Azure VMs that aren't just in the same region as the workspace, but any region or subscription that's part of your Azure AD tenant, you see? Because you may have multiple Azure subscriptions that are trusting the same tenant. As long as the workspace, the Log Analytics or Sentinel workspace, is in that tenant as well, you're good to go. Now, I think my eyes just freaked out on me. That's my technical term of the day, by the way, freak out. I thought that when I first came in here, it said this workspace, and now I'm looking and it's showing my 3 Windows VMs as reporting to another workspace. What in the world's going on here? Well, in this interface, in the GUI interface, a Windows virtual machine can report to only a single workspace. What happens is the Log Analytics agent is installed. In other words, let me show you. If I come in to look at one of these VMs, if this machine hadn't yet been onboarded, we could click Connect. And that would automate the deployment of the Microsoft Monitoring Agent. It's also called the Log Analytics Agent. It's an MSI that would onboard that Azure VM to begin reporting into this workspace. Now, this interface would lead you to believe that you can only report to one workspace at a time. So I can disconnect my DC1 from my infrastructure workspace. Oh, looks like the VM has to be running in order to do that. And then reconnect it to this one. But I do want you to know it's possible to multi-home Windows machines, not Linux, but you can multi-home Windows machines. You need to do that in the guest OS of the machine by modifying your log analytics properties. Just do a Google search or a search in the Azure documentation for Azure Log Analytics Agent multi-homing, and you'll find specific instructions. Okay? So this makes it really easy to onboard your Azure VMs. As far as your off-cloud VMs, this is going to take us back up to Settings, Agents Management. And what you want to do here is download the agent, number one. It comes down as a 32 or 64-bit MMA setup executable. And you also need the workspace ID, which I'm going to copy to my clipboard and put into VS Code. And then I'm going to come back and grab one of my two keys. Now, of course, the plain text value of these is critical. I'm going to delete this workspace after I finish my lesson, so I'm not concerned with you having these values. But of course, these are sensitive because anybody who knows your workspace ID and one of your API keys can join the workspace. And I mean, it's going to involve that machine sending its data into the workspace, but still, it's something to keep in mind. And for security reasons, notice that you can regenerate either of those keys if you want to. All right. Now, why do I want to do that? Well, I want to onboard an external machine. I happen to have an on-premises machine, a couple of them as a matter of fact. One thing I could do, as I just said, is run that agent executable and simply provide the workspace ID. Let me try that here, actually. Let me go to my downloads and let me run this installer just to show you what it looks like. I'm not sure if I have the agent installed on this machine I'm teaching on, so we'll see what happens. If it blows up and gives us an error, it's already installed, I guess we'll find it. We'll find out. Okay, next. We have our license terms, right? Looks like it's already been installed, so it's offering to upgrade the existing agent. But basically, you get a screen here where you specify, do you want to join a log analytics workspace in Azure, or do you want to join a System Center Operations Manager management group? See, it's the same agent that's used for both of those platforms. And then in order to complete that configuration, you'd provide the workspace ID and one of those two API keys. Okay. Now, what about Azure Arc-enabled servers? I mean, I just showed you, you can manually or automatically deploy the log analytics agent to your off-cloud machines as long as you have a way to inject the workspace ID and the key. If you've onboarded Windows Server machines into Azure Arc, it's even easier yet. For example, I have an on-premises Windows Server 2022 box here called Local DC1, and I can use the Azure Extension Framework to automate the onboarding of this guy into my Sentinel workspace. I can go down under Extensions, and we can deploy a new extension. And there's not as many here for Azure Arc servers as there are for normal Azure servers, but we want Log Analytics Agent Azure Arc. We'll click Create. And then again, like I said, we have our workspace ID and our workspace key. Let me just mosey on between the two screens and paste those values in. Let's bring in the full API key here. Paste that in. Validate, and then create. So that's one way to onboard Azure Arc-enabled servers. And remember that Azure Arc for Servers is a way to make it easier to manage those off-cloud machines in the context of Azure Resource Manager. Lastly, just because I can't help myself, the Microsoft preferred way for you to deploy or onboard those Azure Arc servers into your Sentinel or Log Analytics workspace is to use one of the built-in policy definitions. So if I come into Azure Policy and do a search, let's just do a search for policies, and I'm going to do a search for Log Analytics. We're going to see there's a few of these that mention Azure Arc. Linux machines should have Log Analytics Agent installed on Azure Arc. Well, there's a similar policy for Windows machines as well. Okay? Wait for it, another product name change. What used to be Azure Security Center and what eventually became Azure Defender is now currently known as Microsoft Defender for Cloud. So if in the off chance you take or sit for AZ801 and you see references to Azure Security Center, I want you to mentally map that over to Microsoft Defender for Cloud, okay? And what Microsoft Defender for Cloud is, it's a security posture management threat protection platform for hybrid cloud environments. So once again, a lot of the same hybrid cloud awareness that we saw in Microsoft Sentinel, that is where you can monitor not only Azure, but other clouds, bring in your on-prem environment. You can do the same thing here with Microsoft Defender for Cloud. The elements of Defender for Cloud are the secure score. And this is an arbitrary value between 0 and 100, where you and your team can spot your Azure, or really hybrid cloud environment's overall security posture. And what you'll get are recommendations from Defender that will raise your secure score. So it provides a more user-friendly way to ensure that your trend is going correctly in the right direction. You're improving your overall security rather than reducing it. We also have security alerts that can be awfully useful. And again, this is tied in with Microsoft's threat intelligence, so you don't necessarily have to create automations to watch for certain kinds of activities. Defender for Cloud will do so. And it's pretty robust depending upon where you're enabling it. If you enable Microsoft Defender for servers, for example, you get a free license for the Microsoft 365 anti-malware client so that you can tap into the software level of your Windows virtual machines and physical servers and be notified via alerts and recommendations, maybe that a server is running a library that has a known vulnerability. See, so Defender can go into those Windows servers and give you targeted recommendations and alerts to improve your security posture. What I'm seeing as a trend in Microsoft Azure over the last year or so is more and more integration, cross-service with Azure policy. Specifically, the way that you can onboard the Microsoft best practices for Microsoft Defender for Cloud is to assign the Azure Security Benchmark Initiative. An initiative in Azure policy nomenclature is essentially a container that organizes one or more individual policy files. And those policy files might look at compliance regarding things like, do these servers have Azure disk encryption? If they're Azure servers, are the disks encrypted with ADE? Are these servers onboarded into log analytics? All of this kind of stuff, you can report on that with Azure policy. Very common and appropriate question at this point would be, what's the difference then between Microsoft Defender on one hand and Microsoft Sentinel on the other? Do they have overlapping functionality? Well, yeah, they kind of do. As you can see, these 5 pillars, collect, remediate, detect, investigate, and respond, are shared. But what you're going to find in practice is that Microsoft Defender for Cloud is actually a subset of these capabilities. That is, in Defender for Cloud, you've got data collection, remediation, and detection. But you don't have the full lifecycle management that you do with Sentinel. In particular, the investigation piece, the Jupyter notebooks, the workbook interface. Yes, you can do an automated response in both Defender and Sentinel, but in Sentinel it's much more robust because you have that threat hunting KQL query engine on which you can base both alerts and playbooks. Alrighty then, in this second demo I want to show you how we can implement Microsoft Defender for Cloud. And as we're going through this demo, I want you to think about what we learned with Microsoft Sentinel and the interrelation there. So I'm going to browse over to Microsoft Defender for Cloud. And just as a reminder, Microsoft 365 is the umbrella term for a whole number of Microsoft-owned cloud technologies. Even Office 365 is now called Microsoft 365. I have a hard time with that. I still want to call Word Online and Excel and PowerPoint Online Office 365. But at any rate, Microsoft didn't ask me. Here we are in Microsoft Defender for Cloud, and the first thing you'll want to do here is come over to Getting Started and make sure that you're working with the proper stock keeping unit in the product. For example, we've got Upgrade. Let's scroll down and we can look at each of our subscriptions here. So let me choose my training subscription here. And that brings us to the Defender plan page, as you can see. And by default, Defender will run with enhanced security off. This is the free tier that gives you your secure score recommendation and continuous assessment and security recommendations. but literally everything else is not available until you've onboarded these plans. And these are done a la carte. That is to say, there's a separate Microsoft Defender for Cloud product based on your workload type. For example, this first one is what we're interested in principally for AZ801, Microsoft Defender for Servers. And you'll notice that it's normally a flat cost per machine or per resource per instance per month. And it looks like I've got them turned on here. And the list of these Microsoft Defender plans seems to be growing by the day. The idea is that you can do some cost optimization by disabling the plan for services that for whatever reason you don't want to include. Now, I mentioned in passing that Defender for Servers gives you license rights to install the Defender anti-malware client on those machines. Normally, that would be a separate license that you would do in the Microsoft 365 ecosystem. So that gives good vulnerability scanning on your machines. All right, so this is where you set up your plan, and that unlocks the ability to remediate recommendations that otherwise you might not be able to remediate. Speaking of recommendations, let's go down to recommendations in the interface, and we can see this secure score. And this is probably a value that is going to change from day to day depending upon what you and your team are doing with your deployments, your configuration management, and what controls you're implementing here. Now, how the secure score is created is via Azure policy, like I alluded to earlier. As a matter of fact, before we do recommendations, let me come down under Management Environment Settings. And here we can just see from a global perspective the various management levels we have in Azure. Your tenant root, which is the very top of the hierarchy. Then we have our subscriptions. I have my sponsorship subscription that I've had onboarded into Defender for a long time. Let's go into it. And it brings us to a screen that's the Defender plan screen for this particular subscription. And we've got the ability to turn services on and off, like I mentioned, but we also have some other particularly useful options. Auto provisioning is useful because this is going to allow you to automate the deployment of the dependencies Defender for Cloud needs. And you know, the dependency here is actually quite critical. That log analytics agent, we already learned that you need one of those on your Windows servers in order to onboard into a Sentinel log analytics workspace. Well, because Defender for Cloud also relies on log analytics, you're going to need the log analytics agent on those machines. And notice that we can automate that provisioning for our native Azure VMs as well as Azure Arc for Servers machines. I had mentioned about the vulnerability assessment solution. We can automate the deployment of that. Azure Policy allows you to tap into Windows and perform desired state configuration. That, again, guest configuration agent, we can automate that. So go on, so there it is, so on and so forth. And then lastly, if we go to Security Policy, this is where you can opt in to enable that Azure Security Benchmark initiative that provides, you know, a wide range of recommendations based on Microsoft best practices. And those recommendations, that is, would be scoped to your environment. So let's come back to recommendations and let's just take a look for a moment. Like I said, we have our secure score. We can download a CSV report of all this stuff. And they're broken into controls. Note that each one has a potential secure score impact. Enable MFA looks like the most important one in my environment. MFA should be enabled on accounts with owner permissions on the subscription. Well, I would hope I have that, but I guess not. Now, because Defender for Cloud ties in with log analytics, and because log analytics has a whole bunch of what Microsoft calls management solutions, for instance, the ability to do update management in the cloud, notice that you can bring system update related recommendations in here as well. Let me select this, and MFA should be enabled on accounts with owner permissions, just to show you what it looks like. Here we can see the underlying Azure policy that audits or that implements this control. We can see a description of the control, what remediation steps Microsoft recommends. In this case, it looks like it's a manual remediation, but sometimes you'll find that a recommendation has a fix where Azure can implement the change for you itself. And it's grayed out here, but notice that you can often trigger a logic app that fixes a particular problem as well. Lastly, we can see specifically what are unhealthy healthy, and exempt resources are. And in this case, it's showing me 2 accounts that need MFA because they have owner on my subscription. So that's actually a good point for me to take a look at after I stop recording. The more you know, right? The more you know. So let me see if I can find one that Azure can remediate on its own. I believe this machines should have a vulnerability assessment solution as a recommendation for that has a fix. Let's see. So here we've got affected resources. Actually, it looks like I don't have any unhealthy resources, but I'm here to tell you from experience, these buttons light up once you select specific resources that are affected. And in this case, fix would instruct Azure to deploy the Microsoft 365 vulnerability assessment solution to those Windows machines. But it looks like I'm good to go, that I have that machine onboarded into Microsoft Threat and Vulnerability Management. Nice, good to know. Let me see, anything else in here I want to point out? Well, here's the security alerts, like I said, that can give you proactive notification of various anomalous or potentially dangerous behavior. Let me zoom out a little bit. Suspicious authentication. Well, let's take a look at that. I'm going to have to zoom out a bit more. The resolution isn't really great. It says, although none of them succeeded, some of these attempts used accounts that are recognized by the host. Well, that's kind of scary. Let's view the full details for this security alert. So it looks like I have some unknown IP, an attacker's source IP, that's attempting a dictionary attack against one of my virtual machines. And here we can see some of the accounts that were attempted against my timw.info Azure Active Directory domain. And we can take action. In this case, we have specific instructions on how we can mitigate the threat and prevent future attacks. So here I want to stop and compare that there is some basic security lifecycle management here in terms of being able to track an alert through its lifecycle, but nowhere near as robust as what we have in Sentinel. So long story short, Defender for Cloud is meant for not just dedicated InfoSec people, but potentially all of your IT professionals who work in Azure can pitch in and take action on remediating some of these recommendations that are surfaced. Whereas Sentinel is meant to be a full-scale dedicated SIEM SOAR platform, as previously discussed.
Welcome to Lesson 5, Secure Windows Server Networking. In this lesson, we learn how to use the built-in Windows operating system host firewall tools. We start by managing Windows Defender Firewall. Then, we implement IPsec-based domain isolation. Finally, we conclude by implementing IPsec connection security rules using group policy. Without further ado, let's get to work.
What is Windows Defender Firewall? Well, it's been in the product, that is the Windows operating system, for a long, long time, and Microsoft historically has a penchant for renaming products, but we've got Windows Firewall nowadays in 2022. It is a host-based software firewall that enhances the security of both Windows Server, including the version that we're covering on this exam, Windows Server 2022, as well as Windows Client, and this would pick up Windows 10 and Windows 11, of course. A firewall is either hardware or software that protects your host or protects your environment by screening particularly inbound traffic. Traffic that originates from the host, generally speaking, is let through by most firewalls because the idea is the outbound requests, that is, the initial outbound requests, are generally trusted and initiated by the user or a trusted process running on that machine. By contrast, incoming requests really demand a lot of scrutiny. At any rate, Windows Defender Firewall works in both directions. We can configure inbound and outbound network traffic rules. These take 3 main types. We can create allow and block rules that govern executable code. Those are program rules. In other words, we might create an inbound rule that allows only certain IP ranges to access a process on a server. Port rules work at Open Systems Interconnection, or OSI Layer 4, where we're talking about source and destination IP addresses, source and destination port numbers, and protocols. And then custom rule allows you to do a whole bunch of different things. That is, you can reference programs, ports, you can access an enormous library of built-in rules that Microsoft gives us to work with. Now, what's been part of Windows Defender Firewall for many years is the concept of location profiles. There are 3 of them: domain, private, and public. And the idea, these are all bound to each of your server or client machine's network interface cards, both wired and wireless. And you can scope different collections of inbound and outbound rules depending upon where the machine is. Let's say you have your administrative workstation as a laptop, and it's a domain-joined machine. When you're connected to the domain, either locally or maybe through a VPN, you would want to use the domain profile that has your organizational specific Windows Defender Firewall rules. When you bring that laptop home, you're generally in a more trusted, relaxed environment. You can have a separate set of firewall rules associated with that profile. And lastly, if you're taking a flight and you're in an airport in a public Wi-Fi hotspot area, of course, you'd want to use the most restrictive firewall settings there. This is what the public Windows Defender Firewall location profile is. So it's nice that we have that flexibility to shift the context of the firewall dynamically. Although we can manage singleton Windows servers using the Windows Defender Firewall control panel or the Windows Defender Firewall with Advanced Security Microsoft Management Console, of course, from a domain perspective, we want to use something like group policy to set one set of rules and then apply them to n number of hosts. The exam AZ801 objective domain mentions this, domain isolation, and it's not very descriptive. I had to do a little bit of sleuthing to find out exactly what Microsoft is talking about. They're talking about the business use case where you need to secure network traffic at a packet level, in other words, on the wire, data encryption between Windows hosts. You can divide your virtual local area network on premises into these domains where you've got certain traffic flows between certain hosts being locked down and encrypted. You can enforce mutual authentication, and then you can also overlay unencrypted TCP/IP traffic. You see what I mean? In a hybrid cloud context, we can use domain isolation as long as you have either a site-to-site VPN into your Azure Virtual Network or an express route circuit. And then there it gets more complicated because your Azure virtual machines are going to have Windows Defender Firewall in them, and then there's the network security group, there's the Azure Firewall option, so it gets more complex for sure. Now, how do we secure that network traffic at the packet level? We use IPsec, or Internet Protocol Security. This is a standard that Microsoft has contributed to, but it's not a Microsoft proprietary standard. And it's a way to do both encryption and authentication for each individual IP packet. You've got 2 modes of operation. Tunnel mode is what you use in a VPN tunnel, where you're doing point-to-point encryption. What we're concerned with here for exam AZ801 is transport mode, where in your local area network, you can define these domain isolation. They're actually called connection security rules. And your Windows Server machines will obey those rules. And this can go a long way to help you and your organization maintain whatever compliance regulations you have with regard to certain types of traffic need that extra packet level encryption, you see. Now, of course, this is going to guard against somebody putting a network packet analyzer on your corporate LAN and sniffing Ethernet frames. Because IPsec encrypts the payload of those packets, it should be very, very difficult, if near impossible, for a data thief to be able to get to the unencrypted payloads of those frames unless they're able to successfully execute, say, a man-in-the-middle attack. That can be pretty complex. As you'll see in the demo, there are a number of different options that you can use to implement what are called security associations between hosts that are using IPsec. The 2 protocols that IPsec uses have those 2 different separate functions, and you can use one without the other, or you can combine them both. Authentication header, or AH, the name kind of gives it away. This is the part of the IPsec standard that involves authentication and checksumming. Checksumming would make sure that every data frame that goes from source to destination is checked to make sure that it's whole and complete and it has not been captured by a man-in-the-middle attacker and forged, etc., etc. We can do a number of different ways to do mutual authentication, including using the Active Directory Kerberos v5 protocol, or we could use, say, digital certificates, your server certificates that you might have distributed to your Windows Server machines using Active Directory certificate services, right? The other protocol is ESP, encapsulating security payload. ESP doesn't care at all about authentication or integrity. It's concerned entirely with data privacy. So it's responsible for, exactly as you can see here, encapsulating the plain text payload of each frame and encrypting it. And the specific cipher lengths and that kind of stuff that you use are going to depend upon your organizational and security requirements, of course. And you can configure the security association settings when you create your connection security rules. In this first demo, I'm going to walk you through Windows Defender Firewall. We'll look at the control panel and the advanced MMC console. And then we'll create a group policy object that implements a Windows Defender Firewall rule. So I'm on a Windows Server 2022 box. I'm going to right-click the Start button and go to Run and just type Control. I'm pretty old school. I still like the old control panel. I've been using it since Windows 3.1 after all. And if we find Windows Defender Firewall in the list, this will kick up the old school control panel where we can turn Windows Defender on or off. It looks like mine is actually off. Whoops. I'm going to turn it on, at least for my domain settings, because this machine that we're on right now is actually a domain controller for a domain that I've called contoso.int. And this shows you those three profiles, domain, private, and public. You might know that when a network interface card gets initialized for the first time on a Windows machine, you get that pop-up that says, do you want to share resources in the network? That's just an overlay that, depending upon whether you choose yes or no, Firewall will select either the private or the public location. Domain happens automatically. It's not something that you specifically set if the machine is part of an Active Directory domain, either a server, a member server, a domain controller, or a domain-joined client. If you're wondering how to change the location profile, again, you don't do that for domain because that happens automatically, but between private and public, and to change it, I mean, I can't imagine a Windows Server machine ever using the public profile, but you can go, for instance, into the Settings app, and if we go to Network and Internet, and then select your server's or client machine's Ethernet option here, we can go to Advanced Sharing Options. And this kicks us to the old, I guess we could have stayed in the control panel, the Network and Sharing Center, and we can adjust network discovery depending upon what we're doing here, private, guest, or public, and then domain, that's the current profile. All right? Now, as far as the advanced console, let me go back in the control panel to Windows Defender Firewall, and we can go to Advanced Settings here. And this opens up the MMC console, Windows Defender Firewall with Advanced Security. And on the root node here, we can see which profile is active. And it looks like it hasn't either picked up my changes from before. Let me go back to Control Panel. Looks like I forgot to set my domain back to on. So let me click OK here. And that should update the advanced console here. Let me see if I can force a refresh. Yep, right click, refresh. And now it says here, there's our domain profile. And if we go to Firewall Properties, this allows you to set the state of each profile, as well as the defaults for inbound and outbound. And the normal default is to block inbound and allow outbound. But you can customize that to your heart's content. You can also adjust the network connections that are associated with a profile by using this Customize button right here. I just have an Ethernet adapter. And then if we see here, we've got an IPsec settings, And this is one place where you can get into the weeds in terms of how you're configuring IPsec. Fortunately, exam AZ801 doesn't get that deep. We just need to know how to implement these rules, particularly in group policy. Speaking of which, you're not going to want to use this advanced security console on each individual machine. You're going to want to use group policy. So let's go over, I've already got the group policy management MMC up here. And I'm going to, let's see, I'll go to domains. I'm going to create a domain scoped GPO. I know that's kind of broad, but I'm going to put it at the domain for now just to embrace future servers. I'll call this allow ping GPO. Let's click OK. Let me right click, make sure that the link is enabled. Let's go to edit. And we can find the same advanced security policies under the path computer configuration, policies, Windows settings, security settings, Windows Defender Firewall with advanced security, and then we have our inbound, outbound, and connection security rules. Okay? And if we select each element here, it's really the same UI that we see in the local machines firewall with advanced security console. Inbound, outbound, and then connection security rules are for IPsec encryption. Now, we're going to do IPsec in the next demo. So let me select inbound rules. And here, it just has nothing. But if we go to the local machine and we go to inbound rules, we can see a library of built-in rules that we can make use of. Now, I honestly don't know how easy or tough it would be to export these rules and that kind of stuff. It looks like there's no capacity or interface to do that in the group policy editor. So we're just going to right-click in the inbound rules details pane, and we're going to create a new rule. And as I mentioned, there's program, port, there's a number of predefined rules, or we could create a custom rule. And notice that the steps change to be much more robust. I'm going to go here. Well, first let me show you under predefined that most of the Microsoft network products, the on-premises ones, are here. Things like Windows Remote Management, RPC, branch cache, this sort of stuff. And Microsoft has those built-in rules to make it easier to allow those other native Windows Server roles and features to function. But I'm going to suggest custom here. We'll click next. I'm going to blend really all of the preceding, that is the program and the port types are blended. You can use them together when you create a custom rule. I'm going to apply this rule to all programs in this policy. Now for protocol and port, I'm going to open this up and there's some presumed knowledge here, I guess. If we want to allow ping to hit these servers, we want ping to work and not be rejected, we have to know, I guess, that we're talking about the Internet Control Message Protocol. And that comes in V4 and V6 flavors. I'm just going to do V4 here. And I actually want to get even more granular in the name of least privilege and least service security will allow only the echo request message type. So let's go to customize here for ICMP settings. And I'm going to say that we're just going to allow echo request. We want to be careful because, of course, ICMP can be abused. But on the other hand, I know from my professional experience, ping can be a useful quick check to test the reachability of hosts. So it's something that you may actually want to do. Let's click next. Now, which local IP addresses does this apply to? And notice that it's any, but you might want to heavily constrain that, you see. Maybe I want to constrain it only to particular addresses, or maybe a range. So I can select which local addresses, this is local and remote for ping from, ping to. Let's click add, and we can specify IPv4, IPv6 in a number of different ways. I'm going to reference a subnet range, 10.0.0/24. And then I'm going to do the same thing for remote. So as long as we're on the 10.0.0/24 subnet, this rule will apply to it. Let's click next. Now this allows us to layer in a connection security policy. By default, it would be allow the connection, but there's also, if we want to layer in IPsec, allow the connection if it's secure, and that would layer in authentication and/or encryption. I'll just do allow for now. Let's click next. Lastly, we specify which profile or profiles. Well, I'm in an Active Directory domain services domain, So I'll apply this rule only at the domain scope. I'll call this allow ping 1024 subnet, and then click finish. Right, so at the next group policy refresh, that rule will then be inherited by all servers. I can force a refresh on this local machine. Let me go into Start, right-click Windows PowerShell. We'll run a console as administrator, and I'm going to do an invoke GP update using the force switch parameter. And we now should find, maybe after a little pause, that if we go to our local Windows Defender Firewall with Advanced Security Console, and I filter the inbound rules list, let's filter it by profile and show only domain profile, we can see the allow ping 1024 subnet rule has been ingested into this local server's Windows Server Firewall rules list. Okay, here's the second demo. In the second demo, I'm going to teach you how to create connection security policies using group policy. If you're thinking, Tim, aren't you going to cover group policy? We do that in the AZ800 skill set. Here in 801, it's just assumed knowledge, I'm afraid. Now, what we can see at my domain scope, I renamed my GPO that I created in the previous demo. I just simply right-click and rename. I'm calling it allow ping and IPsec GPO. And we can see I've changed the security filtering. I'm going to remove authenticated users and apply this only to 2 machines. Let me repeat that last bit. And then under security filtering, notice that I have authenticated users, but I want to make really clear that the 2 Windows servers that I want to scope this policy to implement the IPsec policy, let's edit the allow ping IPsec GPO. And we're going to go to the same place as before in group policy, computer configuration, policies, Windows settings, security settings, Windows Defender Firewall with Advanced Security, and then we go to connection security rules. Let's right-click and create a new rule. Now I've got 2 servers that I want to scope. I want to ensure that when these 2 servers communicate with each other, their traffic is always encrypted and they perform mutual authentication. So we can see, first of all, is we need to choose what kind of connection security rule we want. And there's a number of these that cover different contexts. If you're doing IPsec tunnel mode, basically a VPN tunnel or just a computer channel, we could go that route. We could also do server-to-server authentications between specified computers. I just want to go custom because I want to incorporate every possible option here. That's probably the best way for us to go. So let's go custom. And in this case, what computers are going to comprise endpoints 1 and endpoints 2? Well, I have 2 IP addresses in mind. Let me select these IP addresses. The first one is this machine that I'm teaching from, DC1. Which is 10.0.0.4. And I'm also going to assume bidirectional traffic flow. I have a MEM1 server that's 10.0.0.5. And I'm going to do the same thing for endpoint 2. I'm going to add 10.0.0.4 and 10.0.0.5. So regardless of which machine is initiating or receiving the connection, it will only be these IP addresses that are scoped for IPsec. Because it's not trivial to decrypt IPsec encrypted packets if you do need to do, say, a Wireshark packet analysis. And number 2, there's going to be computational overhead on the part of the hosts that need to do the IPsec traffic. So you want to think about this carefully and make sure it's something that you need or that you want in your environment. So let's click Next here. And this allows us to select our combination of authentication header and or encapsulating security payload. And notice, furthermore, we could just say encrypt and do not authenticate. And then if we're going to add authentication, we can do request, require for inbound and request for outbound, or what I'm going to select, the most strict option, require authentication. Now, why is authentication important? Well, it's critical because we want these 2 servers to have confidence, as it were, that they are who they claim to be or what they claim to be. And another feature of authentication header is that packet checksumming to make sure that the packets haven't been in any way, shape, or form modified in transit. Let's select Next here. This allows us to choose how you're going to do the authentication. If you don't have a PKI or public key infrastructure, you'll want to use Kerberos v5. And notice that you can authenticate users and computers or just the computer itself. If we go to Advanced, this gives you even more control because you can specify a fallback if you want to, you see. And you can mark, say, the second option is optional. So I could, for instance, come in here to first authentication method. And this is actually where we need to go if you're going to use a CA, a certification authority. And we could use the down-level protocol NTLM v2 as well. So bottom line is we could choose, for instance, Kerberos v5 computer for our first method. And then for our fallback method, we could choose NTLM2. Now notice that there is another option I almost forgot to mention. Let me go back to our first authentication method. It says not recommended because it's too difficult to maintain. A PSK, or a pre-shared key, you're going to have to make sure that you configure this pre-shared key on both or all machines that are involved when you establish the connection. It's just not very scalable at all. So I'm going to add in NTLM as my fallback, and we'll click OK. We'll click Next. This allows us to scope the IPsec to particular ports and protocols. I'm going to have it be global, although again, you want to be careful about that. We might, for instance, only need to encrypt. Maybe there's API client-server work happening in either direction, in which case we could say TCP port 443, although that could be problematic with web services when you think about ephemeral ports. I'm just going to go back to any all for now. That's going to be something that you'd have to really look at from a needs and requirements standpoint and then a monitoring standpoint to see what kind of effect on performance and troubleshooting this degree of control gives you. Lastly, we have the profiles, and again, I'm just going to scope this rule to the domain scope. I'm going to call this IPsec DC1 mem1 and click Finish. All right, same rule applies as before. We could force a group policy update here. Again, I'll go back to my PowerShell terminal and do an invoke GP update force. Have to get my syntax right though, of course, so let me up arrow, add dash force. And what we'll find if we go to the Windows Defender Firewall with Advanced Security Console, we'll eventually be able to see our connection security rules show up once group policy is refreshed. And we'll also be able to monitor those connection security rules as well as get into the specifics of any security associations that are happening between these two servers. See, it looks like we've inherited the connection security rule, and my mem machine isn't yet up right now, but once it is, we'll then be able to see the active connection security rules, and we'll also be able to analyze the specifics of the security association once it's happened.
Welcome to Lesson 6, Secure Windows Server Storage. In this lesson, we're concerned with Windows Server startup integrity and data privacy. We begin this lesson by managing BitLocker drive encryption for Windows Server 2022. Next, we manage and recover encrypted volumes. After that, we turn our attention from our local data centers to Azure with Azure Disk Encryption for virtual machines running on Azure. Lastly, we manage disk encryption keys for those VMs by implementing Azure Key Vault. We have lots of fun stuff to do. Let's begin.
What is BitLocker drive encryption? Well, it's a technology that's pretty mature. It's been in Windows Server and Windows Client for quite a long time. We're dealing with a technology that supports at-rest full-volume data protection. This means that we're going to protect not only our Windows Server OS or operating system drives, but also fixed drives as well as removable drives. Some benefits of BitLocker drive encryption include, of course, data privacy, and that privacy travels with the disk. So in a worst-case scenario, if somebody were to steal one of your servers, let's just assume a bare metal server with physical storage, or if they just were to steal the storage and try to mount that disk on another computer, unless they have a recovery password or the actual BitLocker drive encryption key, they're not going to be able to see the plain text of that volume. It's as simple as that. Another benefit of BitLocker drive encryption is that it works in conjunction with the Trusted Platform Module, or TPM chip, that I hope you have on your server motherboards. This is going to provide startup integrity. Again, if something changes with the hardware configuration on that system, maybe again that the drive has been removed and mounted in another chassis or USB'd to a computer, that would be a violation of startup integrity, and BitLocker would immediately initiate recovery mode. And again, unless you have the recovery password or the decryption key, you're not going to get to the plain text of those disks. Lastly, the Windows BitLocker drive encryption feature is available not only for our local Windows Server machines, but also in Azure. In fact, we're going to learn about Azure Disk Encryption in the second part of this lesson. Although we don't deal with Linux in this AZ801 certification, full volume encryption is available in Azure with Azure Disk Encryption for Linux VMs. However, the dmcrypt library and not Microsoft Windows BitLocker drive encryption is used in that case. It's not necessary to discuss in the context of AZ801, but just to provide you a little extra education, the network unlock feature is going to allow your administrators and support people to do remote servicing on Windows servers. For instance, we can make sure that when we reboot a server, it's not going to hang asking for a PIN. We can deliver a startup key over the network to those machines. There's quite a bit of setup for network unlock. I would encourage you to check the Microsoft docs to learn more about that. And lastly, there's a very old tool. I think it came about, the latest version is 2015, and here we are in 2022, but it's called Microsoft BitLocker Administration and Monitoring, or MBAM. And this is just an overlay. It's an add-on service where you can do things like self-service, where users can request their recovery key from a web portal, and it just gives you more centralized administration. You do have to have a volume licensing agreement with Microsoft to be able to install MBAM in your environment, but we're just dealing with the native BitLocker feature for the purposes of AZ801. Some more stuff you need to know about the mechanics of BitLocker drive encryption. We have to understand the key protectors. When we encrypt, we use a long cryptographic key. Trusted Platform Module is an integrated circuit on your server's motherboard if your motherboard is recent enough to support it. Again, I hope it is, because TPM unlocks a lot of good, pun intended, unlocks a lot of important security, particularly around the boot environment. So TPM means that we can store our BitLocker decryption key on the motherboard. And this would allow the server to start up normally as long as the protected disk volumes can get to the TPM. This is not so much for data encryption purposes, but for integrity purposes. We can use a PIN. This is sometimes the only option when you're protecting a server that doesn't have a TPM module. The problem with the PIN is unless you're doing network unlock, you're going to have to interactively enter the PIN every time you start the server. You also can use a startup key, say a USB dongle that has to be in place for the drive to initialize. For our native BitLocker management tools, we have nice integration with Active Directory users and computers, or ADUC. I'll show you this in the demo. Of course, we've got PowerShell support. An example PowerShell command would be get BitLocker volume. So we see that in PowerShell, the standard verb, and then we have a fixed noun prefix. All of the BitLocker drive encryption native commandlets use the BitLocker keyword as the part of their noun. And then we have the BDE manage compiled executable. You know, I find in practice that BDE manage is more robust than PowerShell, actually. You can do a lot with manage BDE, but of course the downside is that it's an exe, it's Windows only, and it doesn't have PowerShell's universal syntax. We could do manage BDE status, for example, to see the current status of the local machine's drives with regard to BitLocker drive encryption. Here, the main exam alert with reference to AZ801 is storing your BitLocker recovery password and/or key in Active Directory. You do this by delivering the configuration via Group Policy Object, or GPO. And what will happen is that the recovery password and/or the key itself will be a part of the computer account object in Active Directory. Now, of course, a concern here potentially is depending upon how many machines you're using this with, perhaps not only with your infrastructure servers, but you also can do this with Windows 11, Windows 10 clients, etc. You're adding to your Active Directory domain controller replication by adding that extra data in there, particularly when you're using longer keys. However, the convenience there is that administrators can easily recover a drive by looking it up. There's the ADUC add-on called the BitLocker Recovery Password Viewer. You have to make sure that you install that. It's one of the remote server administration tools for BitLocker. Here's an example run of PowerShell using install Windows feature. And this adds some extensions to Active Directory users and computers that, again, make it easier to recover the password. If, for instance, a user has lost their recovery password, hopefully your users aren't responsible for saving the recovery passwords anyway for their drives. That's really our job, isn't it, as a hybrid cloud administrator? But anyway, it's nice, and I'll show you how that works in the demo. In this demo, I'm going to teach you how to install BitLocker and configure the service using group policy, and we'll force recovery, and we'll just work through the entire workflow together. Now, in terms of installing the BitLocker feature, we could use good old Server Manager if we want to, but both AZ800 and 801 they want to make sure to ensure, if that makes sense, that you know how to use Windows Admin Center. So I have Windows Admin Center running on this machine. This is a domain member server called localmem1.contosolocal.int. So it's an on-premises local machine. And I'm going to install a feature. I'm going to type feature in the tools list and we'll select roles and features. And let me collapse roles because BitLocker drive encryption is considered to be a feature and not a role. And you might have noticed that the network unlock is a separate feature that you install. If we do BitLocker drive encryption and click install, it's going to assume you want all of the sub-features. If you want to pick and choose, you'll probably want to use Server Manager instead. So you see here we get the BDE, the BitLocker drive encryption, as well as all of the administration tools, the PowerShell, and also the BitLocker Recovery Password Viewer. Don't think we'll need to reboot. We'll see. Let's click yes. And we can follow the progress up here in the notifications area. Yep, looks like we need to restart. Okay, we're back from the reboot, so I now have BitLocker drive encryption enabled. However, my disks are not encrypted. I just have all of the tools available. Now what I want to do here is create my BitLocker policy before I go ahead and encrypt the drives. So I've connected using the Group Policy Management MMC console, and you can see that in my Contoso local int domain, I created a new group policy object called BitLocker policy. And the path to the BitLocker policy settings is computer configuration, policies, administrative templates, Windows components, BitLocker drive encryption. Now we have these root level policies, and then you can create separate sub-policies based on your drive configuration. Again, we have a differentiation between operating system drives, fixed data drives, and removable data drives. Now, two important options here, probably the most important, are number one, if we go to the drive type, in particular the operating system drives is what I'm mostly concerned with, we've got the require additional authentication at startup option. So let's open this policy up. And we're going to set it to enabled. And if the servers that are scoped for the GPO have a TPM, you'll want to deselect this Allow BitLocker without a compatible TPM option. And notice that you can choose how aggressive you are. Configure TPM. You want to allow, require, or do not allow. And then you can combine the TPM, which again doesn't provide the encryption, although the encryption key is stored on the TPM chip. It's mainly for boot integrity. Another thing I almost forgot to mention An advantage of having a TPM on your motherboard is that you can do secure boot, which is where the server will only start if your startup and operating system files have been digitally signed and validated as not having been tampered with, you see. Startup pin, again, this is potentially a problem with servers because you don't want to have to manually enter a pin every time you boot the machine. Here's where we have combining a TPM with a startup key. You can just configure this to what your business need is. Now, on my server that I'm teaching from, I don't actually have a TPM available. So in order to do this, I'm going to have to do BitLocker without a compatible TPM. And that's going to allow me to set a PIN to unlock the OS disk, or I could still use a USB flash drive, a startup key. I'm going to choose a password or a PIN in this case. So let me OK out of that. Just to show you some of the other options here for your drives, allow network unlock. You would need that if you were going to do that feature. If you're using UEFI firmware and a TPM chip, again, you can integrate with secure boot. I think those are the main ones. If you're going to do pins, you can do enhanced pins, which instead of just, say, a 4-digit number, you can configure a minimum length and do alphanumeric pins. I'm actually going to turn that one on. So as it says here, you can do uppercase and lowercase letters, symbols, basically a password. You can also choose how BitLocker protected operating system drives can be recovered. And in terms of the recovery exam objective on our AZ801 exam, it's important for you to understand that one way to go is to allow what's called a data recovery agent. That would be your domain administrators and anybody else that you delegate can recover a BitLocker drive on their behalf. That requires quite a bit of setup behind the scenes. But the main point for the purposes of the exam, you need to remember that this policy allows you to save BitLocker recovery information in Active Directory domain services for OS drives. And then if you're going to escrow that information in ADDS, do you want to store just the recovery password, or do you actually want the encryption key and the password, you see? So I definitely want to make sure that that's enabled. And let me go back to BitLocker drive encryption. And there's this top-level store BitLocker recovery information in ADDS. Looks like that is a down-level option for older versions of Windows Server. But we can enable that and require BitLocker backup, and it's the same option here, recovery passwords and key packages and so on. I think that's good to get us started here. You can adjust the drive encryption method and the cipher strength depending upon your client. That may have implications with hybrid cloud when you're delivering BitLocker policy to your Azure VMs. Remember, you need a 256-bit key support for your Azure VMs if you're going to use old school BitLocker as opposed to ADE. I would suggest you go with Azure Disk Encryption for your Azure virtual machines instead. So I think we're good. Let me come back to the Group Policy Management console and let's make sure that the link is enabled. It is. So I want to put this into effect. So let me open up an administrative PowerShell console. Let me quickly adjust the font size so you can see. And invoke GP update. Force, refresh our policy. And then it's time to encrypt our drive. So I'm going to open up good old-fashioned control panel by typing control at my PowerShell console. I'm really not on board with the settings app. I'm a curmudgeon, what can I say? So we've got in our old school control panel here BitLocker drive encryption. So let's head on into there. Now I just have my operating system drive, as you can see. But we also could do fixed data drives as well as removable data drives. Specifically, the product for removable drives is called BitLocker to go. I'm going to turn on BitLocker for my C drive. And it says this device can't use a TPM. Your administrator must not have picked up the policy. So tell you what I'm going to do. I'm going to restart. Let me close out of Active Directory users and computers here. And let me restart. Okay, we've come back from our reboot, so I'm pretty sure that our group policy has been ingested, so I don't need to worry about the TPM requirement. I can verify the TPM, by the way. See this link in the lower left corner? You can open up the TPM Microsoft Management Console, and that allows you to verify that you've got it. I'm going to turn on BitLocker. And notice that we can choose either a startup key or we can enter a password. I'm going to enter a password, and because I'm supporting an enhanced PIN, I can do more or less a strong password or a passphrase. So let me click Next. We can print the recovery key, we can save to a file, we can save to a USB flash drive. I'm going to save to a file. And let me see if I can get across the network. Nope, because normally BitLocker will bark at you if you try to keep the file right. Can't be saved to the C drive, so I'm going to have to be a little creative here in terms of where I'm saving the recovery key. Okay, I was able to make a network connection here, so I'm going to save the recovery key to the E drive of my Office desktop workstation. So let me click Save here. Okay, so we've backed up the recovery key. Obviously, that's a really important step. Even though I'm escrowing the recovery password to Active Directory, I still want to be really careful and do due diligence and make sure I have that file saved somewhere. So in terms of how much of the drive to encrypt, you can either just do used disk space or encrypt entire drive. It depends on whether it's a new drive or whatever. Mine is relatively new, so I'm going to choose the default option. I'm going to use the new encryption mode. And I'll leave Run BitLocker System Check on, and it says BitLocker will restart your computer before encrypting. To show you what the recovery key file looks like, by the way, this is it. And this string right here on line 13 is the actual key. So in the event that you need to recover a BitLocker drive, the way to do that, or one way to do that, would be to type the recovery key. And yes, you have to hand type it, so it can be a little tiresome, but hopefully you just need to type it once, okay? I'm going to click Continue here, and we're going to restart, and when we come back from this process, I'll have a protected C drive. And specifically, at restart, because I'm not using a TPM chip that would allow normal startup as long as the TPM chip is functional and disk can read from the TPM, I'm using the unlock key option or the PIN option. So notice I can't get anywhere in the drive initialization process unless I unlock the drive. So let me carefully type my password, and then it allows startup normally. And I like that the Microsoft engineers made BitLocker such that it can run asynchronously in the background. Now I would expect I'm getting a little bit of a CPU hit. Just for grins, why don't we bring up Task Manager on the server? This is a quiet server, understand that, but if we take a look at our CPU, I'm not seeing anything particularly shocking at all with CPU utilization as BitLocker is working. If I open the notification area, it says that encryption of C by BitLocker drive encryption is taking place. It looks like I'm well on the way on the system. We can go back to the BitLocker drive encryption control panel at any time, where we can back up the recovery key, we can change or remove our password, or we could turn off. Now again, that shield lets us know that these are administrative actions, obviously, protected by user access control. Okay, let me show you in Active Directory Users and Computers, dsa.msc is the shortcut, how you can view the BitLocker recovery information for a domain-joined system here. So let me find where my server is. There it is, local mem1. Let's look at the properties of that server. And we can see BitLocker recovery, and we've got the recovery password right here. Now, as long as we turn on advanced features in Active Directory Users and Computers, there's another way to do BitLocker recovery, and that is from the Action menu. You can do Find BitLocker Recovery Password, where you can just type the first 8 characters of the password ID and click Search. Let me see on my other monitor if I can bring up my BitLocker recovery file. Here it is. Let me move it to another monitor. And let me just do the first 8 characters here. 091982. And then we'll click search. Although that's the recovery key, I think this is looking for the identifier. Sorry about that. 2381931B. I think that'll work better. Yeah, there we go. So this is just a convenience, again, something you may want to delegate to your service desk. Very last thing I want to show here is how to recover, how to actually do a recovery. Let me open up an elevated PowerShell console again. And if we do manage BDE force recovery, this will put the machine in recovery mode as if something bad happened. So it's a nice way to do a fire drill to make sure that you can recover, for instance, a server's OS drive in the event of a theft and you need to recover, or in the event of whatever, a hardware configuration change. Doesn't have to be something nefarious. Looks like our disk is getting very close to being fully encrypted here. Figures the last 1% is normally the slowest. You know how it is. Okay, good. So encryption is complete. Let me issue that manage BDE force recovery. Got to do syntax, right? Manage BDE force recovery C. All right, so let's try it. It says only a recovery password or recovery key can unlock. Let's do a restart computer. Okay, so here we are in the recovery screen. Enter the recovery key for this drive. Use the number keys or function keys. Use F10 for 0. Here's how to find your key. Okay, ask your help desk, right? Okay, so 0919882. Notice that the dashes go in automatically. Okay, once you've entered the recovery key, enter. We just simply continue the boot as usual. We're now out of recovery mode. So we see it's just a normal boot. So now I can sign in. With my administrator credential. As I mentioned, BitLocker Drive Encryption is available for your Windows Azure VMs. The feature is called Azure Disk Encryption, or ADE. This is simply BitLocker volume encryption for the OS and data disks, or you could just do the OS disk. It's up to you. Now, if you know anything about encryption technologies in Azure, there's a related encryption technology that I'll show you in the demo called storage service encryption. And that is different from Azure Disk Encryption. Storage service encryption is just the assurance that when your disks are at rest, that is, your Azure VM VHD or virtual hard disks are at rest in the Azure data center, that they are encrypted, and then they're automatically decrypted at use, all right? And the option that Microsoft gives you for storage service encryption is to let Microsoft manage that encryption key, or you as a customer can do it yourself. But if you were to export a VHD from Azure, in other words, to download it to, say, your local environment, your local computer, that disk would be unencrypted. The storage service is an at-rest encryption that happens automatically and dynamically only in the Azure data centers. Now, if you apply Azure Disk Encryption and you were to export the disk, you're not going to be able to mount the disk unless you have the recovery password. You see what I mean? So ADE and BitLocker travel with the disk. Now, where do you store the encryption key? We mentioned that when you're using BitLocker locally, you can use a TPM chip or a startup key. Well, in Azure, you're going to use Azure Key Vault, which makes sense. This is the default Azure secret store. The limitation here is that your Azure Key Vault has to be in the same subscription and region as the VMs that will be using it. I also want to encourage you as a hybrid cloud administrator to be careful with group policy. Check the Microsoft docs on this. There's a great article on Azure Disk Encryption. If you have, say, a site-to-site VPN or an express route circuit, and you've joined these Azure VMs to your local Active Directory domain, you're probably servicing those Azure VMs with group policy, including delivering BitLocker options. You need to allow a 256-bit recovery key for your Azure VMs, and you should understand that add-ons like MBAM are not supported in Azure. And you also want to make sure that your group policy doesn't enforce the TPM protector. This is because in Azure, you don't get access to that level of hardware. Instead, your Azure VMs use the external key, and that's managed by Microsoft. In this demonstration, we're going to apply BitLocker drive encryption, but in a Microsoft Azure context. Here we're looking at my Azure Key Vault. This is a prerequisite to do Azure disk encryption. Besides having a key vault, you'll also want to set what Microsoft calls an advanced access policy. If we come down under Settings, Access Policies, we need to make sure to enable access to Azure disk encryption for volume encryption. That's particularly important in this case. Now let's head on over to virtual machines and let's encrypt a disk, shall we? Now I want us to pay particular attention. I've got a few machines running and one that's stopped. I stopped Mem1 intentionally because I wanted to differentiate what I mentioned a moment ago about the difference between Azure disk encryption, that is BitLocker whole volume encryption, and what Microsoft calls storage service encryption, the at-rest data encryption. Here's what we do. In the portal, we can come down under Settings, Disks, and then of course we have in our virtual machine one and only one OS disk, and then 0 or more data disks, depending upon your needs and what the VM size is. Notice here for Mem1, the OS disk under encryption says SSE with PMK. That stands for Storage Service Encryption with Provider Managed Key. That's the default configuration. So if we go to the disk and come down to Encryption, this is where you can change your at-rest data encryption to use a customer managed key instead of a platform managed key. What you need to do here is have not only a key vault, but a disk encryption set. That's yet another resource, and I'm not going to worry about showing you how to create it and all that because it's beyond our scope. But basically, a disk encryption set provides a vehicle for you to store your SSE at-rest keys, your customer-managed keys, in Azure Key Vault. So I've already got a disk encryption set here, so I'll select it and click Save. This is often used with businesses who have compliance requirements to where you need to document that your Azure virtual machine storage is managed with customer managed keys rather than vendor managed keys. Okay, now that we've done that, let's come back to the disks blade and let me show you Azure disk encryption. Now, whereas the SSE is something that you need to do with the disk that's unlocked. In other words, you need to stop and deallocate the virtual machine so that Azure can have full access and be able to apply the encryption to the at-rest VHD. You can see, by the way, that my encryption type is updated to SSE with CMK. That's Customer Managed Key. If I go back to virtual machines, to do BitLocker, the virtual machine has to be running. So I'm going to encrypt my DC1 virtual machine here. I'm going to come down again to Disks. And on the Disks blade, if we go to Additional Settings up here on the toolbar, we have Encryption Settings. Azure Disk Encryption provides volume encryption for the OS and data disks. I'm going to open this, and I just have the one OS disk on this machine, but notice that the drop-down allows you to encrypt the OS and data disks as well. As I mentioned, Azure Disk Encryption works with Key Vault, so you have to have one of those up, and you also have to have permissions, either Azure AD permissions or access policy permissions to the Key Vault in order to complete this operation. And then I'm going to create a new key that I'll call DC1 ADE key. I'll leave the encryption and cipher and that kind of stuff alone. This is an example of one of the 3 types of secret that you can store in Key Vault. Key are encryption keys. Certificates are X.509 digital certificates like TLS certificates and that kind of stuff. And the third kind of secret is called a secret, and that's just secure string data. I'll click Create. Another thing that Azure Key Vault does is support versioning. Azure will compute a hash to identify every artifact you have in the Key Vault. And you can see under version, we can update if we need to update the encryption key, and then make sure here in our disk settings that we're using the version that we want. I just have the hash for the current version that I just created. That's just fine. And I'll click Save, and Azure will go ahead and encrypt the disk. Now this is going to require the virtual machine to restart, just like we saw in the previous demo when we worked with on-premises machines. You following me so far? Cool. So let's come back out to disks. If you were wondering about the export process, for example, I referred to that, the fact that if you export a ADE encrypted volume, then it's going to be encrypted at the export. If you're just doing storage service encryption with no ADE, it's not, because SSE is at-rest data encryption. The way you would download an Azure virtual machine disk is you'd want to make sure that the machine is stopped and deallocated like mem1 is here. We can come over to disks, select the disk in question, and then we can do a disk export. And what happens here is that Azure creates what's called a stored access signature, a SAS token. And that's a time-limited URL. Notice it's 36 seconds by default, in which within that period of time you can download that disk to your system. So it's just a time-windowed read access to the disk. And then from there it would be a question of getting access to the recovery password or recovery key, which you can do in Azure Key Vault if it's an ADE encrypted volume. You might want to check the Azure docs if you're interested in that more. For example, you might want to take a generalized Azure OS VHD, export it, bring it on-prem, maybe service it, and then re-upload it as an image, whatever. These are just ideas that are coming to my mind.
Welcome to Lesson 7, Implement a Windows Server Failover Cluster. This is the first of several lessons that focus on Windows Server 2022 high availability. Exam AZ801 is a study in themes. Windows Server Failover Clustering is one of those themes that you really have to understand in order to ensure your exam and certification success. We begin this lesson by planning and creating a Windows Server Failover Cluster. We then learn how to stretch our failover cluster across physical and Azure-based sites. We also manage failover clustering storage, modify quorum options, and configure network adapters for failover clustering. We have so much ground to cover in this lesson. Let's begin.
As I mentioned in the introduction, failover clustering specifically and high availability in general form an important through line or theme for exam AZ801. What is a failover cluster? Well, generally speaking, a failover cluster is a group of independent computers that work together as a group to provide high availability to clustered roles. Now, Windows Server failover clustering is cool because number one, it's going to minimize your cost outlay because the clustering feature is built into Windows Server. And number two, if you're running certain types of workloads, namely Hyper-V virtual machines, server message block file shares, SQL Server database, there's some other ones, but these in my experience are by far the most popular workloads. If you're running any of those, you'll get first-class support because of how tightly integrated it all is. It is all Microsoft stuff after all. Now, key to understanding how any failover cluster behaves is shared storage. Hopefully it makes sense that all of your computers, your independent computers, they're going to have their own storage. But in order to provide high availability for our workloads, those nodes, have to have equal access to central shared storage. And that shared storage happens in one of two ways. There's the Storage Area Network, or SAN, that you can address using iSCSI or the Fiber Channel Protocol. Those are high-speed, enterprise-class ways to address storage for sure. However, what the exam is going to focus on is using native Windows Server technologies like storage spaces direct and cluster shared volumes. Now, you'll learn all about both S2D and CSVs as we go on through this. Actually, I have a few lessons on failover clustering. So if you're new to it now, hang with me. Bottom line is, although that in the industry, I find, especially here in Nashville, we have a lot of big enterprise businesses that are based in Windows. They'll generally have dedicated hardware, SAN hardware. But the benefit of using storage spaces direct is that your Windows Server nodes can access their own storage and participate in a failover cluster. And as you'll learn, I'm getting ahead of myself, I do that sometimes. Cluster shared volumes are really useful because they just make it easier to share that storage even more and to ease that cutover process when you do have to take down an active node and move one or more clustered roles to another node. Here I've drawn a schematic diagram here. Let me bring my drawing tools out here. And we can see at the center of our topology, we have that shared storage infrastructure. For now, it doesn't matter if it's SAN or storage spaces direct. It doesn't matter. Just consider it that it's taken, that it's a given. And then we have our nodes. These are going to be essentially identically configured Windows Server machines. They could be VMs or physical servers, depending upon your situation. A little bit later, we need to address the concept of quorum, and that is, depending upon whether you have an even or odd number of nodes, you can run into a problem. Quorum is the idea of, do you have majority such that if, let's say, node 3 goes down unexpectedly and we need to fail over any workloads that are hosted or active on node 3 to another node, will the node survive? You see what I mean? And it's a voting process that takes place among the nodes. And if you have an odd number of nodes, as you can see, the loss of one node, you still have a majority. Now, if you lose 2 nodes, you're in all likelihood not going to have enough votes to survive, and then the whole cluster is going to fail. You see what I mean? If you have an even number of nodes, that introduces other problems as well. So there you'll want to bring in what's called a witness. We'll get into some more of that terminology momentarily. But I want you to see here in my failover cluster, I have 3 Windows Server boxes. They don't have to be running the same version of Windows. We're going to assume Windows Server 2022 here, and that's what I have in my lab and what I'll be doing in the upcoming demo. These machines all have some persistent connection to that shared storage. I'd mentioned the concept of quorum that determines the active state of the entire cluster. The cluster itself will have what's called a client access point. This is going to be an IP address and a DNS name that you can use to connect to and administer the cluster as a whole. Obviously, each node is going to have its own TCP/IP configuration. And then lastly, depending upon the workload, you may need client access points for your clustered roles. VMs are an exception because Hyper-V VMs, you'll still connect to those directly. But if you're doing other workload types, like scale-out file server or SQL server, you'll want to create a DNS entry and a separate IP address that routes directly to that workload. And that routing process is some of the magic, quote unquote, behind failover clustering. So the entire service or the entire cluster is advertised under one DNS name to your users. So your users and applications and connection strings all point here. And then the cluster determines which node hosts or is active for that particular role. Isn't that great? So this means, to state it one more time, if I need to take node 2 down for maintenance, I can proactively move this VM maybe over to node 3, and then once node 2 is empty, I can safely take it offline. But we're providing that high availability for the VM, aren't we? This is the value proposition of failover clustering: redundancy and high availability for your key business workloads. Let's go over the cluster creation process from a high level of abstraction, then we'll get more into the weeds in the demo. I cannot overemphasize the planning here. Cluster creation is not something you just want to stumble blindly into, especially if you're going to need to procure hardware. That's another whole discussion that goes far outside the bounds of the exam. I'm just going to summarize saying, make sure that you're planning out both your cluster architecture, that is, how many nodes you're going to have, will you need a witness, what kind of witness, what kind of redundancies can you put in place on those nodes in terms of all of the subsystems. Think of redundant network interface, redundant storage, etc., etc. So there's planning the cluster deployment, and then there's also, just as important, planning your role architecture. What workload or workloads do you plan to run on the cluster and do your necessary due diligence and validations? Once you've done that and you're ready to actually start what my good friend Greg Shields calls the clicky-clicky process, we will install the appropriate server features on the nodes. There's a validator built into the failover clustering feature that can give us detailed advice on where our cluster situation either fails validation, where you have to make a correction before you can create the cluster, or you just have warnings and you get a provisional pass, or best case scenario, you've got a perfect setup and it's all green lights, checkered flags, go ahead. We can create the cluster using so many different ways. You know, nowadays we can use Server Manager, we can use Windows Admin Center. I'm going to use PowerShell in our demo. And frankly, I find in the real world that working with failover clusters is most flexible and powerful when I'm doing it programmatically with PowerShell. Just a little word of advice. Once your cluster is up, you'll want to make sure your storage is sorted out. Are you going to use cluster shared volumes? What kind of storage are you using, first of all? If you're going to use storage spaces direct, we can then bring in cluster shared volumes, etc. And then lastly, once you have your deployed cluster validated, you can begin to deploy clustered roles. And then from there, it's just going to be performance tuning, troubleshooting, optimization, and enjoyment. Yeah, if you enjoy that kind of thing. You know you're a real IT geek like me if you do. I think Microsoft added this skill into the blueprint to give them an excuse to throw in Azure, because in this part of the course, we're really focusing so much on Windows Server specifically, and implied, at least in my experience, is that we're on-prem. But certainly the idea of stretching a cluster across sites, and then including Azure in that site topology, makes potentially a lot of sense. Let me walk you through this drawing that I created for you here. So let's assume that Site A is our traditional local data center architecture. And we've got a 3-node failover cluster, and things are fine, but we want to expand the footprint of this single cluster. That is, we want to have another instance of it, so for not only high availability or higher availability, but also for disaster recovery, that kind of stuff. How can you stretch a single cluster across locations? Now, Site B could be another physical data center environment, but it just as well could be Azure. However, if this is an Azure virtual network and these cluster nodes and shared storage is all based in Azure Software Defined Networking or SDN, that's fine. However, you're going to need either a site-to-site VPN or an express route circuit in order to give you that OSI layer 3 connectivity from Site A to Site B. So understand that, all right? Now, for our level of abstraction, let's go back to it doesn't really matter where Site B is. We've got high speed, low latency connectivity between the sites. Now, if you don't have high speed, low latency connectivity, all is not lost. You can use the storage replica feature in Windows Server to do both synchronous and asynchronous replication. There's lots of different topologies here. We could have a primary and a secondary failover topology. This stretch cluster that the exam objective is mentioning is where we have a single cluster. So notice that we've got an extension here. Nodes 1, 2, and 3 are over in Site A. Nodes 4, 5, and 6 are over in Site B. Same cluster, same arrangement. In other words, a workload on node 2 could definitely be handed off to a node on node 5 over here in Site B. What I want you to notice, though, is that the storage is replicated and different. That is, you've got local shared storage in site A, local shared storage in site B. And I mean local in a general sense, because in Azure, what is local? You know? And like I said, the key here that makes the stretch cluster work is configuring storage replica, where you get a replication channel between your two shared storage arrays, and also that allows the cluster intelligently to be aware of not just the nodes that are in site A, but also site B, and they can be aware of each other's health state and heartbeat state and that kind of stuff. Really don't need to go into any more depth than that. It's more or less a conceptual idea. We cover storage replica in greater depth elsewhere in this course. What are some relevant points to ponder in configuring storage for failover clustering? Okay, well, this is really an appetizer more than anything else, because as we proceed here in the next few lessons, we're going to get much deeper and broader in looking at the various subsystems within failover clustering. So let's take a look here. Instead of creating a storage spaces direct or S2D architectural diagram, a theoretical diagram, I thought I would go more practical and show you the Failover Cluster Manager MMC interface and walk you through it. This is a working cluster I have called vmcluster.contoso.com. And the idea that with storage spaces direct is that it's a cluster implementation of storage spaces. Now, you may already be aware of storage spaces. Storage spaces is a logical volume manager, or LVM, feature that's built both into Windows Server and Windows Client, so you can use storage spaces in either environment. It's a replacement, in part, of the old dynamic disks model that we had in Windows NT for many, many years. The idea here is that you can take just about any kind of storage, direct attached storage, internally mounted storage, whatever, and you can add those physical disks to what's called a storage pool, okay? And that pool, if we're talking just about storage spaces running on a single server, means that you then can carve out your volumes from that pool, and you can layer in things like mirroring and striping with parity, the different redundant array of independent disks or RAID levels. It's not technically RAID, it's a type of RAID. So all of this, the value proposition, is that it's built right into Windows, so you don't have to purchase separate hardware, separate solution in order to be able to manage disks in a much more flexible way. So whereas storage spaces works on single servers and single client machines, storage spaces direct, or S2D, is where you're aligning or attaching the storage spaces feature in each node and carrying it into the cluster, okay? So notice here we've got under storage pools, I have a storage pool here called Cluster Pool 1. And notice that the storage pool has an owner node, just like a clustered role would. We can see our free space, used space, and capacity, and we can see down below the physical disks that are currently attached to that storage pool. Now, we can always add replacement disks to the pool or add additional disks to the pool over time. You're not stuck with what you have. You can create multiple pools. There's lots of flexibility in how that works. But I just want you to see that you start with your physical disks, and it doesn't show here which node is which physical disk, but these are disks that have been collected across the nodes in my cluster that are contributing to the storage pool here. Okay, with me so far? So let's proceed. Now let's take a look at the disks element in Failover Cluster Manager. Because like I said, from your pool, you begin to create virtual disks. All right? And so I've got a virtual disk here called VM disk, as you can see. And if you right-click there in the disks interface, an important option for you to be aware of is add to cluster shared volumes and remove from cluster shared volumes. So the workflow is your physical disk goes into a pool. You then create a virtual disk and volume. You know, you give there's a partition style. It's normally GPT. You're going to lay down in your volume a file system, NTFS, or more commonly, resilient file system, or REFS. And then once you have that virtual disk, you can then use it to host roles, as you can see up here. But I really want you to double click, so to speak, into this concept of shared volumes or cluster shared volumes. This is a great convenience for your Windows Server nodes because it eliminates the contention that you would normally have if you were using a SAN, a storage area network, where you have a discrete LUN or logical unit number that you would need to unplug essentially from the active node and then plug into the secondary node. So there's a switchover process when you're using SAN storage that you don't have with cluster shared volumes, okay? So virtual disk, add to cluster shared volumes, and if you're wondering what the heck happens when you create that association, that is, when you make VM disk part of cluster shared volumes, what does that actually look like? Well, this is what I'm showing you right here. Up above, this is File Explorer from one of my nodes. Down below, it's a File Explorer from a second node. And notice that in cluster shared volumes, under your C cluster storage directory, and notice that I'm remotely connected to C$ on my remote node here, but it's the same path. Under cluster storage, you're going to have a subfolder that represents that mounted shared volume. VM disk, remember, is the name of the virtual disk I showed you in the previous slide. And so then, as you do things like create highly available virtual machines, those files literally show up on every node in the cluster. Isn't that great? So in this case, I'm advertising or storing a Hyper-V VM called Nest VM. And the benefit here is, although we've got in failover clustering an active-passive topology by default, that means one node is active and owns the role, and it would have active access to that cluster shared volume instance. This is the coordinator node. Any other nodes in the cluster are passive. They have all the files. They could easily take control of that storage because, forgot to mention this, when you're doing cluster shared volumes, all of the changes on the coordinator node get replicated to the passive nodes, which are technically called data servers nodes, so that if we need to do a failover and the coordinator becomes a data server, and now this guy down here becomes a coordinator, we don't have that switchover that I mentioned with SAN storage because we already have a local copy of all those files. I think I'm over-explaining, but that in a nutshell is how cluster shared volumes work, CSVs, and what their main value proposition is with Windows Server failover clustering and storage spaces direct. Let's take a look at modifying quorum options, or just understanding what that means, what options are available to us. Our cluster quorum options are as follows. Node majority, no witness. In this cluster option, each node has a single vote. Now, this is going to work depending upon whether you're even or odd, as I said before. You want to make sure that you don't wind up with a tie situation. There's node majority with witness. This is where you can bring in artificially an additional vote to break a tie. That witness can be a file share that's local in your environment. It could be what's called a cloud witness. This points to a file share in an Azure storage account, or it could be a cluster disk. Lastly, there's no majority. I wouldn't recommend you use this. This is where you just have a disk witness only, but this provides a single point of failure for your cluster. There's no voting as such. Really, you're going to go either with node majority with or without a witness, depending upon your configuration, whether you have an even or odd number of nodes. Now, it used to be in earlier versions of Windows Server, I'm thinking of Windows Server 2012 and earlier, that you needed to work with an additional piece of software on your cluster node networks cards. It was a packet filter driver, but that's no longer the case with current versions of Windows Server. Certainly 2019 and 2022, we don't have to worry about that. There's no extra stuff. So really, when we're configuring networking for our Windows Server failover cluster, it's more about isolation, high availability, and performance. What am I talking about? Well, remember that key to any highly available IT situation or scenario, you're looking at redundancy. So your cluster nodes ideally should have more than one network interface. This allows you to do a couple things. Number one, you could do NIC teaming where you're combining bandwidth. Number two, you're using separate NICs or separate NIC teams to separate types of traffic. Data plane, management plane kind of thing. Now, if you can spare the network interfaces, if you have hardware that supports it, you could theoretically separate storage, management, and network access traffic. This will actually make troubleshooting easier, generally speaking, especially if you're comfortable with Wireshark and protocol analysis tools. The benefit of configuring multiple NICs, multiple teamed NICs, as I said, isolation, traffic isolation, enhanced performance, particularly with NIC teaming, and high availability. If one of the NICs in a server's NIC array goes offline, the server is still delivering traffic and receiving traffic. Another option is RDMA and SMB Direct. This is particularly relevant for Windows Server 2022. RDMA refers to the ability of a network interface to communicate with another network interface and its attached storage at very high speed with very low latency. So if your network interfaces support RDMA, you want to think carefully about enabling it, making sure that it's enabled, and then taking advantage of Server Message Block Direct. That SMB Direct and SMB Multi-Channel are two peas in a pod. That's the first analogy that popped into my head. They will both detect RDMA state as well as enact on it. Remote direct memory access is what RDMA means. Okay, we don't need to go into the weeds on that. Just know those acronyms and know in general it deals with increasing the efficiency and performance of your network interfaces. Now you can do SMB Direct and RDMA on any Windows Server 2022 box. It doesn't have to be a cluster node. Lastly, there's quality of service, or QoS, which you can implement in the software and Windows for your network interface. You can do this at the switch or router level. This deals with reserving bandwidth to make sure that higher priority traffic and higher priority workloads, higher priority nodes get that access. And also QoS can be useful to prevent a noisy neighbor problem and to throttle hosts from consuming too many network resources. Time for our demo. Okay, here we go. In this demonstration, I'm going to walk you through the basics of Windows Server failover clustering. Now, I have two member servers here, FS1 Contoso.com and FS2 Contoso.com. As you can see in the BG info output up above, this is FS1. So let me bring up, I've got a Microsoft Management Console here. I created a custom console that has all of the snap-ins that I could ever hope for or need. Let me start by showing you how I've configured storage on these machines. So I've got disk management here for the local machine as well as the other node. They're both set up identically. That's a pro tip, generally speaking. I've had the best luck with Windows Server failover clusters when I have what will become the storage spaces direct shared storage, if I have the disks pretty much set up identically. So I've got two 127 gig disks here, physical disks. And notice that I've put them online and I've initialized them. But this is important. You can't have any volumes or anything on those disks. It's unallocated space. And if I take a look at FS2, it's the same situation over here. I've got two 127 gig unallocated disks that are online and initialized, but that's it. All right? Now, I plan eventually to deploy highly available virtual machines, so I've got Hyper-V running here, and we can see I've got a machine called DB1. Looks like it's off. I don't know why. I'll start that. This is just a Windows Server 2019 or 2022 server core box. As you can see, I know the preview down below is tiny, but it's running server core. So it's got a relatively small footprint. And we want to make this highly available. Right now, if FS2 goes down, DB1's going to go down as well. And that's not optimal in any way, shape, or form. Notice that this is an Active Directory domain, so I have a Contoso.com zone. that will eventually have some additional resource records in it as we get going here. So I've scripted everything out. Let me bring up Visual Studio Code, clear the screen in my terminal, and let me walk you through what I've got going on. I've done some of this work in advance. First, I created a variable called server list. This code, by and large, comes from the Microsoft docs, by the way. They've got some really great stuff. Although it's pretty old, it hasn't been updated in a while. It's pretty good stuff. Anyway, check it out. So a server list, I'm bringing in an array here with just has references to FS1, FS2. Those are just strings. They're not objects. And of course, you don't have to do it this way. This is just some clever PowerShell. To bring in all of the relevant features, I'm just creating another variable called feature list. We're going to bring in Hyper-V, failover clustering, obviously, data center bridging, that's going to support storage replica, and then we've got FS file server that would support scale out file server, and then we've got Hyper-V PowerShell, and then the remote server administration tools for PowerShell for failover clustering. And then I'm doing an invoke command to install all of those Windows features in one go on my 2 nodes, and if I need to restart, or if those nodes need to restart, they will. That's fine. Next, as I mentioned, once you've got the failover clustering feature installed, you're going to want to validate the cluster. So as you can see, I'm running test cluster against my server list array. And there are a number of built-in tests. The key ones I have here include storage spaces direct, inventory, network, and system config. The testing and validation is a fairly long-running process. The output will be an HTML file, which I'll show you right here. I am validated. Both nodes are showing as validated. And you actually have to pass validation with no errors. I do have one warning. As you can see, my storage spaces direct is fine, but it looks like I have a warning for network and warnings in system config. And if we go down to network, we can take a look here. Our warning is in validate network communication. And then if we read the yellow text, I'm not going to read it all to you, but it's basically saying that you only have one network interface on each host. So it's a reminder for high availability. We want to do some redundancy there. And then let's check out our system configuration warning here. Looks like it's this validate all drivers signed. Again, this isn't a breaking change. This is just a real world best practice that you, in my opinion, want to make sure that your device drivers are all digitally signed to make them immune or hopefully immune to compromise. I know we could get into another discussion of what happens if somebody's code signing cert gets ripped off, but yeah, signed drivers, that also unlocks some other things that show up on the AZ801 exam actually that you'll learn about elsewhere in the course. Things like, well, there's BitLocker, but then there's that Windows Defender, Application Guard, and Credential Guard, things that you can go that work hand in glove and can actually enforce signed drivers. I'm getting a bit ahead of myself as usual. So there's the report, good to go. So we can come back to our script file, and now I'm actually going to start to run code because I haven't created the cluster yet. Now, new cluster, you give the cluster a host name. The node is, I'm going to pass in the server list array. I'm going to do a no storage flag here because I'm going to configure storage spaces direct in a later step. And I'm going to provide a static IPv4 address to the cluster. This is going to create an access point. We're going to see in DNS a new name show up for VM cluster that will have this address. So you, of course, want to make sure that that address is available. All right, so let's submit this. This, again, is going to be a long-running process. But while it's working, I can walk you through the rest of the code. Specifically, just to be safe, I'm going to bring a witness on board and make sure when I configure quorum, I'll do node majority with cloud witness. I'm doing set cluster quorum cloud witness. And in this case, I'm using a storage account in my Azure subscription. So if you're going to do what's called a cloud witness, you'll of course want to have a general purpose storage account created in your subscription. And then you provide, besides the account name, you'll also need an access key. That's one of the ways to authorize access in a general purpose storage account is an access key. It's not the best way, really. Active AD authentication is the best, but for something like this where you're not dealing with humans so much, it's process-based access, This is what the set cluster quorum command is expecting at any rate. And to illustrate that process quickly, because after all, we are talking about hybrid administration, let's go into the Azure portal here. We'll go to Storage Accounts. I've got my TIM Storage 001 account, and then if we scroll down in the settings to access keys, there's actually two. Key 1 and Key 2. It doesn't matter which one you use, you copy out. Obviously, these are sensitive. That's why the plain text is obfuscated in the portal and why you have the rotate key option, because it's recommended strongly that you regenerate your keys periodically. So that's how I got that information. Let's come back. It looks like our cluster creation already succeeded. That was pretty fast. Good. So now let's bring in our cluster quorum. We'll do node majority with Cloud Witness. Fine. And then lastly, this command does a lot of heavy lifting. Enable cluster storage spaces direct. I would suggest in the real world you want to be a bit careful with this because it makes a lot of assumptions. The long story short, what it's going to do is go through, iterate through your nodes, collect all available storage, and slam it into your shared storage in your cluster. I'm using kind of dramatic language here, but it's kind of an easy button for configuring storage spaces direct and a shared storage infrastructure for your cluster. We do enable cluster storage spaces direct, sim session, and then the short name of the cluster. Let me clear the screen. And let's just see, before I forget, if our DNS zone is updated yet. Sure enough, we can see we now have a host name for VM cluster for 10.1.10.222 in our Active Directory integrated zone. Good deal. So let me right-click this, run selection. And again, that's going to be a fairly long-running process. While that's cooking, I need to confirm. Are you sure you want to do this? I'm going to do A for yes to all. Let me see if I can get a browser tab going here. I just want to, before I forget, remind you that another place to manage your failover cluster more centrally, particularly if you're on Mac OS, if you're not on Windows and don't have easy access to Windows, that Windows Admin Center actually gives quite a bit of love to failover clustering. As you can see in WAC, we can open up this top navigation and come down to Cluster Manager. And this allows you, let me refresh the view, allows you to do a fair amount of configuration in the failover cluster here. Whoops, I forgot to add a connection to the cluster. So let's click Add. It's called VM Cluster. And I'm going to specify my credentials that I know will allow me to connect and manage that cluster. I'm going to connect with account. All right, and we're also going to add in both nodes in my WAC servers list, so that's fine. We'll click Add. All right, good deal. Now, WAC, again, has an advantage because we're not tied to a Win32 app like the Failover Cluster Manager, which is the main way I'm accustomed, frankly, because I'm a fuddy-duddy. This is how I'm accustomed to working with the cluster. So let me right-click, Connect to Cluster. I'm going to do VM Cluster, and let's make a connection to the cluster here. And here we can see an interface that looks very similar to what we saw a moment ago in the slides. So we've got our roles, and there's actually going to be a role created for your storage subsystem. That's the SDDC group. We've got our nodes, FS2 and FS1. Storage is eventually going to populate because of that commandlet that we ran back here, which it looks like it completed. So we've got our cluster pool 1, and if we give that a click, the pool name is actually S2D on VM cluster. Looks like it's healthy. And if we take a look, we've got all 4 of those disks, 2 from the one node, 2 from the other. I wish it told us exactly which one was which here. I'm a little bit disappointed in the interface here. But anyway, what we can do now is create a new virtual disk in that pool. So let's just do that. We'll create one for our VM workload. And if you're thinking, whoa, Tim, hang on, hold on. I'm just trying to go at a pretty high level here because we've got more lessons coming up where we'll go deeper. So I'm going to create a virtual disk called VM disk on the S2D on VM cluster that was given to us courtesy of that PowerShell command. We'll step through a wizard. I'm going to call this VM disk. Click Next. I'm going to make this 60 gigs. We've got 229 to work with. Now, another thing you can do here is change things like you could do tiered storage if you have some physical disks that are solid state. All of mine are the HDD type, so I don't have tiered storage. But you can change the resiliency. Right now, this disk will be set up as a two-way mirror, but you can change that to just pure striping or striping with parity. Those are all features that are part of storage spaces that you also get carried over into storage spaces direct. Now notice here, create a volume when this wizard closes. I want to keep that option enabled because just creating the virtual disk is fine, but we can't actually do anything unless we've got a volume. So let's step through this volume wizard. It already defaults to the correct server and disk. I'm going to use all the space. We actually can't change it. I'm not going to do a drive letter here because I want this to be in cluster storage, cluster shared volume storage. I'm going to do REFS. That's actually the only option here. And I'm going to change the volume name to VM volume. Click Next and then Create. All right, well that didn't take long, so let's close. And now if we head on over to disks, we can see our VM disk and we can see our volume down here as well. We can add a drive letter to that now, but I want to actually add this disk to cluster shared volumes. That's going to be very important for us to do. And again, the disk has an owner node as well. So note that you can move these disks and shift them to another node as an owner. That would be a planned failover event. So that's important at the disk level, but not important at the volume level. Why? Because now every node in the cluster has a new folder called cluster storage. And then we have a mount, a cluster shared volume for that virtual disk. And there's nothing on it yet. But once we start deploying roles, they will indeed be stored on those CSVs and be replicated and synchronized on all nodes in your cluster. Isn't that great? So the very last thing here is on roles. I'm not going to do it now in the interest of time, and we've got time to continue as we go on here. But when you right-click Roles, Configure Role, in order to do a highly available virtual machine, I would simply choose among the roles that Microsoft supports for cluster high availability. In this case, it would be a virtual machine, and we're off and running. Nicely done. Great. I look forward to seeing you in the next module.
Welcome to Lesson 8, Configure a Windows Server Failover Cluster. This lesson picks up immediately where the previous lesson left off. Recall that we're currently investigating Windows Server Failover clustering as a high availability solution. We begin by configuring cluster workload options and examining cluster sets. Next, we configure the Windows Server scale-out file server and learn how cluster witnesses work, particularly the Azure Cloud Witness. After that, we configure a floating IP address for SQL Server clusters running in Azure Virtual Networks as VMs. Lastly, we finish up by implementing a cluster VM load balancing solution. As always, there's lots to do, so let's get right to it.
In the previous lesson, we set up a failover cluster. So you know some of the basic mechanics of why a failover cluster, namely high availability, and how in terms of installing and configuring the server roles. But there's another set of roles in a Windows Server failover cluster, and these are the roles that can run in a highly available way. There are a number of them, including the Distributed File System DFS namespace, File Server, which we'll double-click on momentarily when we learn about Scale-Out File Server. There's a generic catch-all, 3 of them actually, for generic application, script, and service. These provide templates, for lack of a better term, for applications that aren't explicitly defined as clustered roles. SQL Server actually would be a good example of where we would use generic application. When you're doing Hyper-V replica in a failover cluster, you'll need a Hyper-V replica broker installed. Of course, Hyper-V virtual machines are one of the 3 or so most popular clustered roles. You can do DHCP server high availability by running the service in a cluster, as well as, and I can't believe I'm saying this in 2022, the Wins server. You may not even know what the Wins server is or NetBIOS name resolution, but if you're old like me, you'll chuckle. But then again, some businesses may still have a dependency on NetBIOS. Actually, yeah, we'll leave it at that. Failover cluster configuration. I think this exam AZ801 objective is essentially a cornucopia of just some specific features of a failover cluster. Things like a client access point. What is this? So this is an IP address and an associated DNS hostname that represents your clustered role. Now, the exception to this is the virtual machines. When you do a highly available virtual machine, you'll continue to connect to the VM on the VM's own IP and hostname. But for example, if you're going to do a highly available SQL Server database, you're going to advertise that clustered database under a specific virtual IP. That's what the client access point allows you to do. And because of the integration that exists between Windows Server Failover Cluster and Windows Server DNS, you'll find that the DNS registration of your client access points happens automatically. Failover clustering has quite a bit of convenience built into it in terms of cluster-aware updating, or CAU. This automates the otherwise arduous task of manually downing one role at a time. And in a cluster, you'll have to move any roles that are hosted on a node to another node to clear it up, and then you could restart it if you were doing, say, a patch cycle. Cluster-aware updating automates that notion of automatically moving roles to another host and then bringing those roles back to the original server once it's finished updating. So this concept of role movement we can look at as failover. And we can conduct these failover processes manually, or they can happen automatically. You'll see in the demo specifically how that works, but that really is the linchpin of failover clustering. And by linchpin, I mean it's the most important component. I mean, the whole reason why we're using a failover cluster is to ensure that the failure of one or more nodes still keeps that service, whatever it is, alive and available. What is a cluster set? Well, a cluster set is to failover clustering what, say, a virtual machine scale set is to Azure virtual machines. Are you familiar with the VMSS? The concept of the virtual machine scale set is where you can horizontally scale out your, say, your web front end. If you have, say, 2 identically configured web servers, depending upon server load, you can auto-scale out to additional instances. That's reminiscent in ways of the cluster set. Another analog between the cluster set idea and Azure is that in Azure we have what are called availability sets, where you can tell Azure to keep your replica VMs separate on different what are called fault domains. Basically, that means server racks, such that if there's a rack failure in the Azure data center, your service is still available because Microsoft is ensuring that you have your other replicas spread across multiple fault domains. Well, we can do similar scaling operations with cluster sets. Now, a big difference is that the cluster set does not auto-scale, but it does give you quite a bit of flexibility in scale in general. Let me go into more detail to explain what I mean. Let me bring out my drawing tools. A cluster set consists of 2 or more separate failover clusters that will logically go together. Microsoft calls the relationship between these clusters in a cluster set loosely coupled. So we've got one management cluster that is the source of authority for the entire cluster set. And then we've onboarded additional separate clusters that could be in the same data center or in different data centers. Again, that's part of the benefit here. And you can nominate them and mark those as member clusters. Now, what does that give you at the end of the day? Well, it gives you centralized control over the entire cluster set. Number two, it allows you essentially to scale to infinity. That's a Microsoft marketing term that they use when they describe cluster sets, to where you can deploy a cluster in each remote site, but manage them singly. And even more to the point, you've got resiliency on your workloads. In other words, you could have a virtual machine here in the management cluster running on node 3, and depending upon not only the availability of your management cluster, but also things like just CPU and memory pressure that are happening on that node or on other nodes simultaneously in that cluster, you could actually live migrate that VM to another node in a member cluster. So in other words, when you create a cluster set is somewhat similar to a stretched cluster, but remember, a stretched cluster involves storage replication. Here, in a cluster set, each shared storage array is pertinent only to its own cluster, but there is an awareness across the entire fabric, across the entire cluster set. And some of the magic that makes this take place is the scale-out file server role. Now, we'll learn more about SOFS in just a minute, but what I need you to know for the exam about cluster sets is that you use a separate set of PowerShell to configure the cluster set. You've got one management cluster and n number of members that are all logically in the same cluster set. And all clusters in the set share the same scale-out file server namespace. The management cluster is the master node, and then you've got your worker nodes that are running in each member cluster. And the benefit of this scale-out file service namespace referral process is that you have that single pane of glass. You've got the fluidity to migrate your workloads from nodes not only within a single cluster, but to any cluster in the entire environment. All right? Lastly, there is the concept of the fault domain and availability set here with cluster sets. If you work predominantly with Azure, you might be surprised to hear that this feature that's native to Windows Server itself shares some similarities to what happens natively with Azure virtual machines. Here, in the cluster set, you logically define your fault domains, which normally would be defined at the data center or site level. And this allows the management cluster to detect outages of an entire cluster. You see what I mean? And that would involve a failover of all active roles that are in that particular cluster. You can also, these are options, they're not required, definitely highly recommended. You can also spread your workload across multiple clusters to create an availability set. And again, you define the availability sets and which nodes and which roles are associated with the availability sets. And let's say that you've got 3 web server machines, 3 replicas. You could make sure that those replicas are running on separate member clusters. And this is going to give your web front end much greater availability because you could lose one or more fault domains and still have your service running. So it's a directly analogous feature to availability sets in Azure as previously described. Now, I've teased the concept of scale-out file server quite a bit. Let's formally define it, and I'll make sure to include it in my upcoming demo. Scale-out file server is a way to make file shares highly available. Now, we saw in the previous lesson that cluster shared volumes, or CSVs, are a great way to make shared storage available to all cluster nodes immediately because each node has a copy of the cluster shared volume. We have a similar idea here where your file shares are being hosted by all cluster nodes. Now, this can have more benefits than just higher availability for those file shares. You can also benefit from parallel bandwidth and combined bandwidth when you're serving data out of those file shares. Another built-in feature of scale-out file server is automatic client rebalancing. And what that means is that the failover cluster service is looking at utilization on each node in the SOFS cluster and is rebalancing client connections to the least utilized node. This is going to give the users and processes that are connecting to your file shares a better experience, a faster, more efficient experience, and that's a win-win scenario, isn't it? Now, there's two varieties of scale-out file server. Now, you need to be aware of these both for exam AZ801 as well as for your industry success. One option is file server for general use. You would use this option when you're doing a scale-out file server role for traditional file shares, both SMB and NFS. And this option unlocks all of the related file server capabilities built into Windows Server, the File Server Resource Manager, data deduplication, DFS replication. And if you're thinking, wait a minute, isn't that a bit of a redundancy? Well, perhaps. I mean, SOFS or scale-out file server is definitely a way to make your file shares highly available, but remember, they're going to be highly available within a single cluster. DFS can work across geolocations. Then you might think, well, Tim, you just said that the cluster set. Yes, yes, yes. If you're thinking to that level of analysis, good for you. You're definitely ready for the exam in that regard. I think, again, it boils down to a couple things. Different approaches for different teams. And also, when we're looking at high availability, it's not an either or many times, it's a both and in layering high availability techniques and technologies. The second type of scale-out file server is scale-out file server for application data. And this is where you're simply going to host either Hyper-V virtual hard disks or SQL Server databases. So it's pretty straightforward. General use is for highly available file shares. Application data also uses highly available file shares, but not in the same sense. In other words, when you're doing the application data option, you're actually not able to use DFS replication and File Server Resource Manager and all that. Instead, that one is optimized specifically for highly available virtual machine storage and highly available SQL Server databases. Now, you might be thinking, look, in the previous lesson, you mentioned running Hyper-V virtual machines on cluster shared volumes alone. What's the deal? Well, that's true. Again, it's a situation where you might go one way or the other. You can absolutely host highly available VMs on standard clustered shared volumes or using scale-out file server. I mentioned the notion of the client access point. So if we created a highly available file share called SOFS1, that client access point would be registered in DNS with that name and would have an associated IP address that you're reserving for it. And then your connections to that share would take place using universal naming convention syntax as //SOFS1. You'll see that in the demo. We should know what the witness options are for Windows Server failover clustering. First of all, what is the purpose of a witness? We have to think of quorum. Quorum in a failover cluster determines the voting elements that determine whether the cluster should continue in an online state or fail. Simple as that. And a witness is nothing more than a resource that represents a tie-breaking vote. So you're concerned about the issue of whether you're left with an even or odd number of votes. If you're left with even, you're stuck. You see what I mean? So witnesses can often be very helpful and beneficial in certain cluster situations depending upon the number of nodes you have. Now, the types of witnesses you can use in a failover cluster, there's the disk witness that's going to be a particular logical unit number, or LUN, a specific storage connection in your cluster. Another option is file share witness, where you're pointing to an SMB file share. Microsoft, in their guidance, suggests disk witness for single site clusters. This is because the LUN would be always presumably locally available. And a file share witness would be best for multi-site clusters because that share hopefully, would be accessible from site to site. But honestly, I'm a big fan of the cloud witness. Obviously, I'm an Azure specialist, and this certification is about being a Windows Server hybrid cloud administrator after all, isn't it? The cloud witness is an SMB file share that's hosted by an Azure storage account. And this is used when the cluster has internet connectivity. Or failing that, you may have a site-to-site VPN or an express route circuit into an Azure virtual network, and you've created a private endpoint, let's say, to a file share. Okay, so here we're going to formally shift our attention to Azure for the rest of this lesson, particularly some elements of the Azure load balancer. First of all, what is a load balancer? A load balancer is a hardware or software appliance that provides high availability for identically configured back-end nodes. I use a web front end as an example, but it just as well could be identically configured API servers. It could just as well be a bunch of database servers. But notice that I'm mentioning for non-clustered nodes. This is because a load balancer is one method of high availability, and failover clustering is another method of high availability. When you're doing a traditional load balancer, that load balancer is routing traffic to multiple IP addresses. In other words, if I have 5 back-end servers, each of those servers would have its own IP. In a cluster, as I explained, a highly available role has a single IP address to it. So it's already got load balancing built into it. The Azure Load Balancer, of course, runs in the Azure cloud. It's a general-purpose software-defined networking, or SDN load balance, that works at OSI layer 4. That means, if you're not familiar with the Open Systems Interconnection networking model, that the load balancer is concerned with source and destination IP addresses, source and destination port number, and protocol, typically TCP or UDP. The Azure Load Balancer can run in a couple different configurations. It started its life strictly as a regional load balancer. So you deploy the load balancer in the same Azure region as your workload. The problem with that, though, is that if Microsoft has a regional failure, you're down. So again, thinking in terms of high availability, if you deploy your workload to more than one region, you could put a load balancer in each region and then put a traffic manager, say, that's a DNS load balancer available in Azure, in front of both of the regional load balancers. But nowadays, the Azure Load Balancer standard SKU, stock keeping unit SKU, supports a global deployment where you have a global load balancer that serves as your worldwide endpoint, and it will route traffic to regional load balancers that you've deployed for each region. Also, when you deploy load balancer, you can choose either a public internet routable IP address as its front end or a private IP, and that would involve your placing the load balancer inside the virtual network. Now you might be wondering, I kind of teased it when I started this slide, why are we discussing Azure Load Balancer if we're dealing with failover clustering? I mean, aren't they mutually exclusive? Well, as it happens, there is a special case when you're doing high availability for SQL Server databases. You might be familiar with the always-on availability group. Now, the exam's not going to get into the weeds about always-on, so let me just be brief here. The idea is you can take one or more SQL Server databases and make them highly available if, number one, you're running a version of SQL Server that supports always-on. Number two, you set up a failover cluster, and then you define the availability group. And you do the availability group, you can use Transact SQL or use SQL Server Management Studio. Again, it doesn't really matter what the deep details are, but one of the main benefits of the always-on, it solves the shared storage problem. And it's the similar kind of business proposition to cluster shared volumes and specifically storage spaces direct, where in this case, we've got the databases that will be part of the availability group, local to each server. So see, we have 3 nodes in our failover cluster, and each one has a copy of these 2 databases, DB1 and DB2. And the availability group allows you to failover those databases as a group from one node to another, because we've got 3 nodes in a failover cluster. So the availability group is really 2 separate technologies functioning hand in hand. There's Windows Server failover clustering, and then there's SQL Server always-on availability group. Lastly, those locally stored databases are replicated in a primary-secondary way. It's not active-active. So in this case, SQL 1 is the active node, it's the primary, and SQL 2 and SQL 3 are receiving replication updates and keeping those databases in sync with each other, but they are in fact standby. And that makes sense because that's how Windows Server failover clustering works anyway out of the box. But when you do a failover and you move the active role to another node, then that active node would become the primary, and then what was the primary would be the secondary. And lastly, you would have what's called an availability group listener. That is exactly the same thing as a client access point from the perspective of your failover cluster. Now, given that little bit of education, let's understand the specific requirement here. Here's the deal, and this is a concept that for some reason kind of befuddling to me, tends to show up not just on AZ801, but quite a few of the Azure exams. Okay, well, bear with me here. So here we're looking at a lucid chart diagram I drew for us that shows a hub virtual network running in Azure, and we've deployed 2 internal Azure load balancers. We're not concerned with the web one. I want to draw your attention here to the data subnet, where I have a failover cluster with 3 SQL Server nodes, and they have a replicated database configured for always on. We have our listener. That's going to be a virtual private IP address that's within the subnet range here, the data subnet range. And we've deployed an internal load balancer that will serve traffic to one, which it's actually not all of them. I misdrew this. It would be only to the node that's active for the database. Now, this is the specific exam objective. That front-end private IP address is going to need to be the same as the availability group listener. Why? Well, the way this is going to be set up is your line of business application, when it needs to communicate with SQL Server, it's going to use the front-end private IP address of the load balancer. On premises, you know, the server would make the request directly of the availability group listener. But that's not what's happening in Azure here. So your application is communicating with the private front end. So hopefully you understand why that load balancer front end needs to be the same as the private IP that you're using as the listener. Because that way, if you have to initiate a failover, that listener may be active for this guy right here most of the time, but then in the event of a failover, this guy over here is going to receive the role. So we've got a shifting. This is a concept called direct server return, or what Microsoft calls it is floating IP. And all it is a simple checkbox in the load balancer configuration. And by specifying floating IP in the load balancer, that tells the load balancer to expect that the back-end connection, the MAC address and private IP address of the node may be different. We're coming in on the same IP as the listener, but the specific hardware address of the host is subject to change. So you wind up with the private IP front end of the load balancer floating across the nodes of the cluster. That's all it is. I hope that makes sense. We just have been talking about failover clustering being a load balancing technique. Yeah, what they're talking about, what Microsoft is talking about, is what's called failover cluster VM load balancing. It's a very special case. It's actually a property that you can set in your failover cluster properties that is meant to optimize cluster node utilization. What does that mean in more detail? Well, it's to prevent an unbalanced cluster. You know, you have 3 nodes in your cluster, let's say, and one node has 4 VMs, one has 3, and one has 3. Depending upon how things are shaking out with things like cluster-aware updating and planned failover and maintenance, you might wind up with a single node with far more virtual machines on it than other nodes. That would be an unbalanced cluster, and that's going to reduce the performance of that node as well as the machines, the highly available VMs that are running on that node. So what you've got with failover cluster VM load balancing are built-in heuristics, in other words, metrics for load balancing. In other words, the failover cluster is constantly looking at memory pressure on each node as well as their CPU utilization, and you can specify a level of aggressiveness that you want failover cluster to apply for any highly available VMs on there. You can just run a single PowerShell command, get cluster dot. When you're doing this parentheses notation, that's a convenient way to access properties and methods. So get cluster in parens dot auto balancer level means that we want to set a new value for the auto balancer level property of that given cluster, okay? And a value of 1, which is the default, is where Azure will live migrate a VM off a host if it is consistently over 80% loaded. 2 is 70%. 3 is when the cluster average is above 5. That's pretty darn aggressive indeed. In this demonstration, I'm going to illustrate most of the concepts we covered in this lesson, and even one from the previous lesson, believe it or not. I'm on my fs1.contoso.com node. This is a Windows Server 2022 member server. Let me bring up my trusty admin console that I worked with in the previous lesson, and I want to start by showing that I have a Windows Server 2022 server core box called DB1 running on my FS2 node, and I want that to be highly available. So I'm really picking up exactly where we left off in the previous lesson, and I'm going to start with that. And specifically, I want to compare and contrast the way to host a VM normally with a cluster shared volume versus the scale-out file server approach. So what we'll do, if I go over to storage, we can see, first of all, my storage pool that consists of 4 physical disks, 2 from each node. I've got a 2-node cluster here. Again, we can verify that by going over to nodes. And we created a virtual disk called VM disk, and I added it to cluster shared volumes to make sure that both nodes have that mounted volume available locally. And then lastly, we can go to roles, right-click, configure role, to start the process of configuring high availability. So let's click. I'm actually not going to show this welcome page again. Let's click next. And here are the supported roles I already told you about. I'm going to scroll down and select virtual machine. Then we'll click next. Now notice that the wizard auto-detected a virtual machine that's not highly available, but it's running on one of your cluster nodes. So I'm going to grab that. I'm going to select it and click next. And that's really all there is to it. Next. We can always change specifically where the storage will be for this machine. In fact, let's finish it out and wait for the virtual machine to come up. There we go. So we can see right now that the virtual machine is running and available, and the owner node just happens to be FS2, which is where the VM is actually running on that host. But we can very easily failover. If we needed to take FS2 down for maintenance, for example, we could just simply do a move, and we can do a live migration either to the best possible node as determined by failover cluster, or we can select the node itself. We've got FS1, which is up, of course. And now, okay, it looks like we've got a problem here. Information details. Okay, well, this is going to bring up a little bit of troubleshooting, actually. It's good that these things crop up in a demo, because this is likely stuff that you can see in the real world. Okay, well, before I do that, let me right-click again and come down to Move, and we can go to Virtual Machine Storage, and we can see where the VHD is being stored right now. And it looks like it's not in VM disk on the cluster shared volume yet, so I want to correct that. So what I'm going to do is grab, drag and drop, and bring not only the VHDX file that's the virtual machine's virtual hard drive, but I want to bring all of its configuration and metadata down to make sure that it's in the cluster shared volume VM disk. Yes, that's what I want to do. That really is going to unlock high availability for this machine. So let me click Start. And what we're going to find before too long here, let me verify that that actually happened. Let me right-click, go to Move Virtual Machine Storage. There we go. It looks like it's in the process of replicating. We can check that on this node as well as the other one. Now, the default path for your cluster shared volumes, as I had mentioned in the previous lesson, is C cluster storage. And there we go. So we can see VM disk. And we can do the same thing by doing $fs3 C $ cluster storage. Actually, it's not called FS3, is it? It's called FS2. First of all, what machine am I on? Who's on first, right? FS1, yes. So let me change the path here to FS2 \C $. I was wondering why it wasn't completing the file path here. There, so we've got a highly available virtual machine, and thanks to cluster shared volumes, the switchover during a live migration is going to be very fast indeed. So now let's try that again. Let's right-click, Move, Live Migration, select node. I'm going to switch it over to FS1. Did not complete. Well, again, this is good from a troubleshooting standpoint. We can right-click the role, come down to Information Details, and see what's going on here. Oh, okay. Well, this is pretty easily corrected, actually. It failed to live migrate because a virtual switch used by the VM does not exist on the destination node. That's a common rookie error, it seems to me. So if we go under Hyper-V Manager here, let me right-click and go to Virtual Switch Manager. Looks like I've got a nested external switch. And the DB1 virtual machine, if I look at its settings, is in fact, let's see, nested external switch. Right, so if we go over to FS1, the other node, Virtual Switch Manager, I've got a nested internal switch. Well, I guess it has to match the name as well. It makes sense because the configuration has hard-coded references. So nested external switch, let's put that change into effect. Let's go back to roles, let's go back to our virtual machine, and let's do a move. Live migration, select node FS1, okay. And there we go, live migration. Now, while that's cooking, and it's cooking very fast indeed, in fact, it's already on FS1, I was going to go ahead and try to sneak in a scale-out file server. So let's try that next. We'll right-click roles, go to configure role, and now we'll come down to File Server and then select Next. Here are those two options. Now I'm going to go with File Server for general use. I'm going to do a traditional SMB file share. So let's click Next here. Type the name that the clients will use when accessing this cluster role. Well, this is creating the client access point, but you know, it just occurred to me that I don't have storage ready for this role. I keep getting ahead of myself, and that's good, that's fine. So let's come back to our storage pool. Let's right-click and create a new virtual disk for our scale-out file server highly available role. So let's verify our storage pool and proceed. And this kicks open the traditional Storage Spaces Direct virtual disk wizard. I'm going to call this FOFS disk. Click Next. I've got a lot of space available, 168 gigs. I'm just going to make this really small. I'm going to make it 5 gigs. Actually, I'll make it 10 gigs. And notice that the default configuration is going to be HDD. I don't have solid state. And it's going to use two-way mirror. Now, we can change that configuration. That's actually a good point about using PowerShell, so you can have complete control over configuration. Instead of the problem with using a graphical user interface is that you're kind of stuck in terms of which options are available to you at deployment, whereas when you're using a programmatic deployment method, you can normally access all properties and options. So let's click Next here, and then we'll create that virtual disk. And we're going to want to create a volume which create a volume when this wizard closes, is selected by default. So here we are in the new volume wizard. Verify the disk and server, okay. Okay, verify the size. I am going to use a drive letter here. I'm going to choose, let's see, how about S for SOFS? And then the volume label, I'm going to call this FOFS share. Actually, I'm going to call it SOFS volume. Click Next, and then Create. All right, it's all completed. So let's click Close. And we can verify this by coming and seeing our SOFS disk that has our SOFS volume. We could add to cluster shared volumes, but I'm not going to do that now. I'm going to go to roles, and let's do a configure role. Again, we're going to do file server for general use. The name is going to be SOFS1, and I need to reserve an IP address for this box. I'm going to do 10.1.10, how about 97. Now, of course, you'd want to make sure that that address is available. I can't remember if it's AZ801 or AZ800, but you do have to know about IP address management, or IPAM, and that's a good opportunity for you to reserve an IP address for this client access point. Okay, and then we have our SOFS disk that we created. Let's select that. Notice that it's using the resilient file system. We're ready to configure high availability for this file server. Great. Well, we're not quite finished. That gives us the highly available role for sure, but we don't have any file shares on it yet. So I'm going to right-click and add a file share right now. Now I'm going to just do an SMB quick. Let's click Next. Okay, share location, volume. Okay, everything's looking good so far. The share name is going to be called docs, let's say. And notice that the remote path is going to be / SOFS1/docs. Next. This is where you can do some of those file server resource manager techniques. Here's where we can control the discretionary access control list, and you can always get back and tweak this stuff after the fact. So now we've got ourselves a highly available share, and you can verify that right down here at the bottom. You can look at your resources, you can enumerate the shares, but lastly you can do a call to / SOFS1, and there's our highly available share. And that's going to be available on any host as previously discussed. Okay. Well, we need to keep moving now, so let me minimize. Actually, before I keep moving, there is one more thing. Just as a validation, let me jump into my contoso.com DNS zone. And we can see those client access point addresses and host names. We've got the cluster management point. We also have, if I need to refresh a little bit here, we've got SOFS1. We have our DB1 virtual machine. So just wanted to mention that those are in fact referenced. Okay, so we're going to finish this by taking a look at always on and load balancing. I'm going to go out into the portal, and I'm driving by Windows Admin Center because I teased this in the previous lesson, mentioning that there's an entirely separate interface here for Cluster Manager. And as you can see, I'm connected to my vmcluster.contoso.com. And this is where you can go directly to your highly available virtual machines. And what's kind of cool about this is that it really extends and updates the interface that's available in the old MMC console. You know, I am kind of a fuddy-duddy about having used the old Failover Cluster Manager for a long time, but when you see the metrics and things that can be surfaced from within Windows Admin Center, it's pretty compelling actually. So especially when you start layering in hybrid monitoring. As you can see, we've got Azure Monitor. There's the Azure Update Management solution. So there's some good stuff in Windows Admin Center. Please make sure, not just for your exam success, but for your career, you get on board with Windows Admin Center sooner rather than later. All right, so here in the portal, I actually set up this environment using an Azure Quick Start template. If you do a search for Azure Quick Start templates, I'll show you exactly what I did. This is a community collection of Azure Resource Manager templates. And I don't remember exactly what my search was. SQL Server availability group. Let's see if I can find the template. It was one of these. Well, bottom line is it was a template. It doesn't really matter specifically which one it is. But as you can see, I have 5 virtual machines. I have 2 domain controllers. I have a file server that's serving up an SMB file share that's our file share witness for this cluster. And it's a 2-node SQL Server failover cluster, all right? And actually, those should be running. Let me refresh the view. Yes, I was a little concerned there for a minute. To take a look at the underlying virtual network infrastructure, let's go to Virtual Networks and take a look at it here. Let's see. It would be this guy right here. Let's go to Diagram and take a look from a vector standpoint what this virtual network looks like. Okay, let me see if I can zoom in a little bit here. All right, so we've got a SQL subnet that contains the file server, the witness, and our 2 nodes. We've got another subnet that contains our domain controllers. I've created an Azure Bastion. This is a managed jump appliance that will allow us to make a remote desktop connection to manage any of these machines. And as you can see, I've deployed an internal load balancer that has a private front-end address, and its back-end nodes are going to be those 2 SQL servers. So let me show you the configuration of that load balancer. Specifically, let's go to front-end, and in this case, I'm using 10.0.1.9 as the front-end, and we want to bookmark that because when we create, I've already created it, but when you create your availability group listener in Azure, you'll want to make sure to use that same address as I said before. The back-end pool in this case are those 2 identically configured SQL Server VMs. And then lastly, we have our load balancing rule. Now, SQL Server, we're talking about TCP port 1433. So what we're doing here is that when traffic comes into that private front end on TCP 1433, we're going to be routed to the availability group listener. How does that happen? Well, in 2 ways. Number 1, notice that the floating IP property is set to enabled. That's absolutely critical to make sure that the load balancer can do that. Number 2, that's how we've set up the cluster. So let's finish this demo by inspecting one of our SQL servers. Let's see. How about if I go to SQL Server 0? And like I said, I created a bastion in this virtual network. So I can get an RDP desktop happening very conveniently here. Let me sign on as an administrator. Hopefully I'll remember my password. And Bastion works in an HTML5 browser here, so I can connect right in here. Let's click Connect. Okay, here we are connected to SQL Server 0. Let me clean up some of my browser tabs here. I'm getting a little bit confuzzled. Now, if the desktop looks archaic, this is, I think, Windows Server 2012 R2, but there really hasn't been much of a substantial change since then with this stuff. So what we've got here in a nutshell is that SQL Server 0 is one of our 2 cluster nodes. So here we have our failover cluster manager. And if we go to roles, we can see our always on AG role. This is our highly available SQL Server cluster. Specifically, the name of the client access point is always on AG listener. And if we go to resources, we can take a look at that listener. And again, we have that 10.0.1.9. And we can also validate that. I don't know if I can get to DNS on this server. Nope, the console's not installed. But you can bet we have a DNS name for that always-on listener as well. Okay? So that's the role. What are some other configuration things that we have to keep in mind here? Well, when you're starting the process, you have to make sure that your SQL Server service is aware that you want to do availability groups. So we could look at the MS SQL Server properties here and go to Always On and make sure that Enable Always On Availability Groups is there, and then you provide the name of the failover cluster that you've got set up. Let's see, anything else? I think we're just about done. Lastly, in terms of connecting to the highly available database, let's go to good old SQL Server Management Studio. And when we make a connection, we can specify the availability group listener DNS name or the IP address. I'm going to use the IP address as our connection point. And this should take us, it should route us to the node that's active for the database that is in fact being hosted and synchronized across our nodes. There it is. So we can expand databases. And it looks like I actually have two databases in this group. Notice that they're showing as synchronized. And then depending upon, I'm not sure which node we're actually set up on, whether it's SQL Server 0 or 1. We could always check back here. Yeah, it looks like we've got, for our always-on AG, it's SQL Server 1 as the owner. So that's what we've actually connected to on this IP address. We can see that it's simultaneously primary for one and secondary for another. So actually it looks like there's two databases and two separate availability groups on that host. And we can verify, actually I almost forgot about this, you create the listener itself right here in SQL Server Management Studio. So as I was saying earlier, the listener is represented in both Failover Cluster Manager as well as in SQL Server. But the key point is that it's pointing to the same IP address. So as we can see here, we specify the DNS name of the listener, the port, which in SQL Server land is normally 1433. Whether we're doing static IP or DHCP, of course we want this static. And then there's the IP address yet again.
Welcome to Lesson 9, Manage Failover Clustering. In this lesson, we continue our Windows Server journey. Let's start by implementing cluster-aware updating, and then move on to recovering a failed cluster node from both reparable and non-reparable scenarios. Next, we'll upgrade a cluster node running a previous Windows Server version to Windows Server 2022. Next, we'll recover a server running a down-level version of Windows Server and bring it up to Windows Server 2022. We'll fail over workloads between nodes, install Windows updates on cluster nodes, and then we'll conclude the lesson by using Windows Admin Center to manage those clusters. Ready? Let's get down to it.
First on our trolley ride here through Windows Server failover clustering is the question of how do we patch our servers when they're in a failover cluster arrangement? Well, we have native to Windows Server failover clustering, CAU, or Cluster Aware Updating. This is an automation feature that allows us as administrators to update our cluster nodes with zero downtime. The CAU feature uses a plug-in architecture, and the two providers are the Internet, Microsoft Update, where you'll be pulling bug fixes and security enhancements and feature enhancements directly from the Internet, or more likely, at least in your local data centers, you can use your own Windows Server Update Services, or WSUS farm. So just know for your AZ801 certification success that CAU can work both with WSUS and Microsoft Update itself. As far as configuring the updating runs, these can be done either manually, or you can put your failover cluster in what Microsoft calls self-updating mode. And this is where you schedule the cluster to update. And this would allow you to work within your defined maintenance windows. And Microsoft calls this configuration cluster in a box, because you could potentially deliver a failover cluster to a site, set a run schedule for cluster-aware updating, and not have to worry so much about those cluster nodes remaining up to date with Microsoft updates. Specifically, what is the update process used with CAU? Well, what cluster-aware updating does when it does a run is node by node, it'll start by putting each node into maintenance mode. In other words, pausing that node. Pause means that that node cannot receive any incoming cluster roles in a failover situation. And we also are concerned with draining off existing connections to that machine. That actually happens here, When cluster-aware updating will move any cluster roles that are active on that node that's now paused to another node. So a failover event takes place. Then CAU will install any outstanding updates, restart the server if necessary. Once the server is back online, CAU will pull the node out of maintenance mode, restore the clustered roles back to the original node. There you have it. We could call this a rolling upgrade process for sure. Let's take a look here at the PowerShell support for cluster-aware updating. You know that there's a module called Failover Clusters that has your general purpose failover commands to create, modify, delete clusters. Well, note that Microsoft has engineered the CAU commands into a separate module. So you can see here a run of get command from the cluster-aware updating module. Notice that the noun stem of all of these commands is CAU. There's not an awful lot of commands. They're all pretty standard. But notice you can do everything from validating your cluster with CAU, that's test CAU setup. You can start and stop a run. It's really nice how this works. And there's also a graphical user interface. That's actually what I'll use in the upcoming demo that makes it even easier yet to get CAU set up on your cluster. Now, the answer to the question, how do we bounce back from a cluster node going down unexpectedly, depends upon whether the failure is repairable or not, or reparable, depending upon how you pronounce words. First, let's take a look at a reparable or repairable failure. So a relatively minor issue that brings down the node. It could be a software issue, a misconfiguration, or it could be hardware-based, but something that you easily can perform a swap out and not have the failed node down too long, as opposed to the node going belly up totally and you have to replace it, you see. So the reparable failure step is allow failover to occur. It'll happen naturally. That's the purpose of failover clusters. It's high availability. And those nodes are always communicating via heartbeat messages. And a failed node will no longer be sending those heartbeat messages, and that's a clear indication that another node needs to take over any clustered roles that were active on the failed node. So allow failover to occur and complete. You then would, in all likelihood, power down or whatever troubleshooting or repair you need to do on the problematic node. Bring the node back online. You don't have to re-add it to the cluster because it's already in the cluster. You would just manually move the clustered roles back to the original node. So it's a pretty straightforward process. Now let's take a look at a significant failure in which you're going to replace the node altogether. What you'll want to do here is, step one, allow the failover process to take place. But then what you'll need to do is evict the failed node, which you can do, again, either with PowerShell or the Failover Cluster Manager. So this is going to bounce the failed node out of the cluster. It's no longer considered a node. You'll replace the failed node with new hardware, or if it's a guest VM cluster, a new VM, whatever the case may be. But notice that you'll then have to add the new node to the cluster. That's a single PowerShell command. It's pretty easy to do that. I would also recommend running test cluster just to validate the new node against the workloads that it plans to support in the cluster. And then lastly, transfer the roles to the new node if you want it to be active for any. Here we have a technique called Cluster OS Rolling Upgrade. So the use case here is, as long as your cluster nodes are running at least Windows Server 2012 R2, you can perform a manually orchestrated rolling upgrade of each node without stopping the cluster. And you know what the secret sauce to this is? It's very similar to the old idea of the Active Directory domain and forest functional levels. You remember those? Those were a much bigger deal years ago than they are now. But in Windows Server failover clustering, there's also the concept of the functional level. I'll get more into that in a moment. But you should know now that the Cluster OS rolling upgrade, the only workloads that, or clustered roles, should I say, that Microsoft formally supports for this are Hyper-V and Scale-Out File Server, which should come as no surprise given those are the really major, most popular clustered roles. Should also know that ClusterOS rolling upgrade is reversible until you commit at the final step. And that final step where you commit is where you run update cluster functional level to raise the level of the cluster to the new version, which in the case of Windows Server 2022 would be the highest as of this recording in 2022. Now, the cluster functional level, as I said, is analogous to functional level in Active Directory domain services. Remember that with AD, the functional level allows your domain controllers not to use capabilities that are not available in down-level versions of Windows. So you would use the functional level principally when you're in a mixed mode, where you have Windows Server domain controllers running multiple versions of Windows Server. Well, same thing. As you're upgrading or doing an in-place upgrade node to node up to Windows Server 2022, you're going to want to maintain the lowest common denominator, that is the lowest cluster functional level. And you can verify that with get cluster functional level. The numbers, the legal numbers that are accepted by the commandlet are 8 for Windows Server 2012 R2, 9 for Windows Server 2016, 10 for 2019, and 11 for 2022. Here's the high-level step-by-step. First, Microsoft recommends that you back up your cluster just in the event of something going horribly wrong and you need to restore in a disaster recovery context. That also involves backing up your cluster database and your workload data. Next, you'll want to verify that if you have cluster-aware updating running, that it's not going to do anything, it's not going to interrupt the rolling upgrade. You may want to pause CAU, or at the least, make sure that the process is completed. Next, you'll want to, one by one now, for each, this next series of steps is really going to be kind of like a for each loop. One at a time, node by node, you'll pause each node, which drains the roles off of it. You'll evict the node out of the cluster. Once it's out of the cluster, then you'll do your in-place upgrade. And Microsoft recommends, well, I said in-place. Microsoft actually recommends doing a clean OS install of Windows Server 2022. And that makes a lot of sense, actually, the more I think about it. So in other words, the node becomes current with Windows Server. You then add the node back into the cluster. Then you reinstall cluster roles. And that's the process that you would do iteratively. And throughout that process, until the last node is upgraded, you'll want to keep the existing cluster functional level. And once the final node is upgraded, then and only then, you can update the overall cluster functional level. And that will unlock all capabilities of Windows Server 2022 with regard to failover clustering. Well, here I thought I would just show a couple representative screenshots. You'll see this again in the demo, but this gives me a chance to maybe speak a bit more depth about what's going on. So what you're seeing here, let me bring my drawing tools out, is an extract from the Failover Cluster Manager GUI tool, and I've got my scale out file server clustered role. And when we right-click that, we've got move. So this is going to be the specific command. Notice that it doesn't say failover, it's move. And you can choose either best possible node or you can manually select a node. Now this is when you're doing a manual failover, okay? When the cluster is doing a failover automatically because the active server for that role is no longer reachable, then the failover will look for the best possible node on its own. You might be wondering, well, how in the world does the cluster determine what the best possible node is? Well, this is something you configure in the properties of your clustered role, okay? There's actually 2 pages. One is failover, and the main thing here I want you to see is the failback option, such that whether you want to automate having the role go back to its preferred owner or most preferred owner, which is set on the General tab. And here's a screenshot of that General tab. And this is where you can create a hierarchy where in the case of a best possible node failover, it'll start with the topmost entry, and if that one's not available, it'll move to the next. That's what's called preferred owners in Windows Server failover clustering. Now, when we're talking about a highly available Hyper-V virtual machine, there it's a bit different. Again, let me bring out my drawing tools. So here I've right-clicked on my Nest VM virtual machine, and it starts off the same, move, but then we get different options. And for the longest time initially when I was newer to this, I thought, why in the world are there two separate migrations, live and quick, and why in the world wouldn't you do a live? And frankly, even in 2022, I kind of feel that way still. Basically, the differentiator between live and quick is whether the VM is paused, all right? Live migration keeps the VM and its memory state active as the workload, as the VM and its configuration are moving to another node. Quick migration pauses the VM state. Again, why you would choose that rather than live, I don't have a great explanation, to be totally honest with you. But there you have it. You'll notice that when you choose either quick or live, you then have the best possible node or select node. So you can do the preferred owners for your virtual machines as well as any other clustered node. Remember also that if we're using cluster shared volumes or CSVs, the virtual machine and or your scale-out file server file shares are mounted on every node in the cluster, which makes that movement much more efficient, as I've discussed previously. Well, you might think, well, Tim, hold on a second. Didn't you just discuss cluster-aware updating? What's the situation? Yeah, that's true. The cluster-aware updating is great for updates that are delivered by Microsoft itself. But you may very well want to do driver upgrades, other software, whether it's related directly to the OS or not. How do you do that? What's the preferred technique? Well, no surprises. It's really the same as what we've seen as a theme throughout this lesson. I just figured I'd show you some PowerShell here. So let's start at the top. Suspend cluster node, that's going to pause the node. Then the second pipeline that you see there, where we're going from get cluster node to get cluster group to move cluster group, well, that's a way to gather up all of the clustered roles on, in this case, node A. That's what the cluster group is. And then move them all to the preferred new owner. Next, and this is the real money of this topic, then once the clustered roles are off that node, it's still part of the cluster, remember, it's just paused and has its roles shifted to another node. You would then do your maintenance, install your updates, restart, etc. And then you can unpause the cluster node with PowerShell with resume cluster node. And then lastly, this is an example of just moving cluster group or cluster roles one at a time. You could do a move cluster group, name of the clustered role, and then the original node as the node ID. Well, WAC has been a sub-theme at the least throughout this training course. And the trend that I see with WAC is that in most capabilities, it's going to surface just some of what you can do using the native Microsoft Management Console. I would say that cluster management in WAC, though, goes beyond the Failover Cluster Manager or PowerShell in many ways. Again, let me bring out my drawing tools. And the reason why I say that, you can see here that Cluster Manager is actually a separate top-level part of Windows Admin Center. So it has a fundamentally more prominent role in this web-based administration tool. Number two, remember that these extensions are eminently updatable. So Microsoft can deliver new functionality and fixes in a much more agile way than it can with the MMC consoles. And number three, if you look over on the left, you can manage quite a bit about your cluster. You can manage your highly available VMs, your cluster nodes. You can manage your storage space is direct-based storage, that is. You can configure storage replica to handle stretch cluster scenarios. There's networking, and there's even more down there, including integration with Azure and Azure Monitor and Log Analytics. So again, I just want to repeat, beyond just your exam requirements, I would suggest that you install WAC in your environment, load in a few of your servers, and just see what you can do from a monitoring standpoint, but also a configuration standpoint in here. There's no denying it's convenient being able to manage your hybrid cloud infrastructure using a web browser like this. All right, in this demonstration, I'm going to show you some Windows Server failover configuration tasks. Let's see, where do I want to begin? Why don't we begin with Failover Cluster Manager. And you can see here that I have a 2-node cluster, FS1, which is the Windows Server 2022 data center box I'm teaching from, and FS2, only 2 nodes, unfortunately. But I just want to point out some of the controls here. Let me right-click FS1, and here we can see some commands that I'd mentioned several times in the theory part of this lesson, where you can pause and resume. And there we have the drain roles or do not drain roles. And then in the case of a paused node, when we resume, notice that we can fail rolls back or do not fail rolls back. So those are important to know about. As far as eviction, you can see down here, you right-click the node, go to More Actions, and you can evict a node that way. Of course, PowerShell is always a possibility. I'm just in the MMC console now, so we'll go with that. As far as reviewing failover and failover configuration, we've got a couple clustered roles here. One, we've got a virtual machine. Let's take a look at the properties here. And this is where, again, you've got your nodes that you can set as preferred owners. And we can select and move up or down if we have a preference. All right, and that same operation works for your other cluster roles, like scale out file server, as you can see. And then as far as doing a manual failover, we can see the current owner node for the role. So let me right-click, move, and we can choose either best possible, like I said before, or we can manually select. I only have one to choose from. Fortunately, it is up, so let's click OK. And we should find that that happens pretty quickly. Yeah, that was very quick indeed. I'm using storage spaces direct with cluster shared volumes, which makes it even easier. You'll recall that when you're using CSVs, you have a local mount point for those volumes. I have one called VM disk, and it contains all of the artifacts for the VM. Actually, maybe I'm not using the cluster shared volume for the scale out file server. One way that we can verify that actually is to select the service, come down at the bottom, and take a look at our storage. Yeah, cluster virtual disk, SOVs. Okay. Yeah, I'm not using cluster shared volumes here, just regular old garden variety cluster storage. Okay, that's fine. That still was a fast failover. And then for a virtual machine, it's basically the same. We'll go to Move, Live Migration. I'm going to select node. Again, the current owner node is FS2, so I can only fail it over to FS1. And we've got a live migration happening right now. And the VM is still up and available and doing its work. If we right-click the virtual machine and come down to Move, there's a really nice virtual machine storage where you can manually place those assets that make up your highly available virtual machine. And I do, in fact, have them on my VM disk cluster shared volume, as you can see here. All right, I think that's mainly what I wanted to show here. One more thing, I guess, to finish us out. Actually, two more. There's always something else. One, I want to make sure you're good with cluster aware updating, or CAU. This is available on your failover nodes. It's part of the RSAT tools. It's right in the Start menu. You can get to it from Server Manager. And as you can see, it's got a separate UI, and you start by making a connection to your cluster. So let's connect. That will list our cluster nodes. I've never run an update run on this cluster yet, so there's nothing available as far as last run status or anything like that. So what we can do is preview the updates for the cluster, and depending upon which plugin you're using, I'm going to just use Microsoft Update and not pass any arguments. We can generate a preview list, and so this would be any outstanding Windows updates that are available from whatever source it is, either WSUS locally or what I'm doing out on the internet. It looks like there's just a Microsoft Defender for servers security intelligence update available, not too bad. So we can apply those updates directly to the cluster if we want to do so manually. And you'll notice here that next and update are grayed out. This is a great example of the interface pointing out something I've forgotten to do. As you can see down at the bottom here, in order to use cluster-aware updating, particularly when you're going to do self-updating runs, when you're scheduling those options, you're going to need to have CAU represented itself as a highly available cluster role. Okay? So let's cancel out of this wizard and let's go to Configure Cluster Self-Updating Options and see what happens here. Let's click Next. And here, instead of creating it ourselves, we can just instruct the Self-Updating Options wizard to do it for us. Hopefully, I don't have to pre-stage a computer object in Active Directory because my current credentials are pretty good. And this is where you can specify the frequency of self-updating and the repetition options. Here is just some metadata properties on how you want to configure the run specifically. And if you have a central XML that contains your parameter values, you can just share it and import it here if you want to. We can bring in some recommended updates as well as important updates. Then apply the change. And right now, the wizard is automating the deployment of that CAU clustered role. Great. Okay, so now that that's taken care of, we can either wait for the next self-updating cycle, or we can go ahead and apply any outstanding updates. Notice the remaining options. We can create or modify an updating run profile. This gives you back to those metadata parameters. Generate a report on past runs, and then probably we could have started with this, making sure that your cluster is compatible with cluster-aware updating here. And it looks like all of the tests passed here except one dealing with proxy servers. And so let's go back to apply updates to this cluster, click Next. There is the risk that the machines, the nodes, are going to need to reboot depending upon what it is. And this is kind of interesting that it shows you a preview of the PowerShell that it's going to run under the hood, set CAU cluster role. Now, could you mimic cluster-aware updating, self-updating schedules with a PowerShell script that runs on a schedule? Yeah, absolutely, of course. So I actually don't want to do this. It just occurred. I don't want to reboot the machines. But you see here that we could proceed by clicking Update, and then if the nodes restart, then a failover will happen, etc., etc. I already taught you all that stuff. Okay. So lastly, let's open up Windows Admin Center. So I've signed in to my FS1 gateway instance, and you'll notice here that we have a detected server cluster. So let's select that from the list, and we'll maybe prompted for creds. I should be fine. No, it didn't work with my credentials. I'm a little surprised. So let me hand type my credentials, make sure that I want to use these again in the future. And that'll bring us into our cluster. Now again, like I said, the cluster manager is part of the global navigation in WAC, as you can see up here. So it really has quite a prominent role. So here we can see on the dashboard page some recent alerts, health state of our servers, drives, volumes, virtual machines. I'm not going to read it, but this is nice. It's good to surface this kind of metrics just as a quick sanity check, as it were. We've got our virtual machines node, our highly available VMs. So we can see definitely a lot more in terms of monitoring than we could in the Win32 console for sure. So let's select DB1. And let's see what kind of trouble we can get into here. On the main page, we've got checkpoint control. I've got checkpoints disabled on that VM. We've got the underlying VHD, where it's stored, its utilization statistics. It's good to get that. It's good to get that information for sure. So let's see, we can do an RDP connection directly from here. We can do some power work with the VM. We can do some
cluster failover work here. There's a lot of entry points into Azure. No surprise, I'm sure, right? Replicate using Azure Site Recovery. You see that option? So we could replicate the machine directly into Azure, a Recovery Services vault, and then fail over to the cloud instead of just simply failing over to another local cluster node. And then we've got our settings. Yeah, so there's quite a bit here for sure as far as your VM management. Then we've got servers for our nodes. We've got a summary and an inventory, and again, we can click into each one. And we have similar commands for our hosts. So I'm not going to click every one of these, but you see it comes down through networking, and then we have tools like Azure Monitor, Updates, Performance Monitor, all of this focused on the cluster specifically. Really nice stuff. Last thing I'll say is that whenever you see preview here, know that that's about evaluation and testing, okay? I might have mentioned this already in the past, that Microsoft Worldwide Learning generally avoids covering public preview features on their exams. And normally, preview features are exempt from Microsoft service level agreements as well as support agreements.
Welcome to Lesson 10, Implement Storage Spaces Direct. This is the course's final lesson on Windows Server failover clustering. We start by learning how to base a failover cluster's storage on Storage Spaces Direct. We then learn how to upgrade an S2D node as well as to implement networking and overall configuration for the service. Let's get started.
What is Storage Spaces Direct, or S2D? Well, it's a software-defined storage solution from Microsoft that's an extension of Storage Spaces. Storage Spaces is a logical volume manager, or LVM, that's available in Windows Server and in Windows Client. Storage Spaces Direct is specific to a failover cluster, so we can take together 2 to 16 Windows servers, hopefully they all have identical storage configurations, and pool their direct attached storage resources without the need for dedicated storage area networking or SAN hardware. So that's a big value proposition. Reduced cost, reduced complexity, reduced administrative burden. We can take the server's own storage, enlist it in this shared storage architecture, and use that with failover clustering. Storage Spaces Direct brings with it a whole bunch of features that Storage Spaces has that are inherited by Direct. Things like cache, storage tiers, resiliency, erasure coding. Basically, you have a lot of the RAID or redundant array of independent disks levels, like the mirroring, 2- or 3-way mirroring. We have various parity options. Now, you should note that Storage Spaces Direct is proprietary. It's not using a formal RAID algorithm. It's specific to Storage Spaces Direct. And also we have to note that given that this is a software solution and not hardware-based solution, you're probably not going to get the performance that you'll get when you are using, say, Fibre Channel or iSCSI-based SAN hardware, all right? And you are, to a degree, burdening Windows Server with extra storage stuff. Stuff is our technical term for the day, by the way, that it might not otherwise have to deal with if you were using a hardware storage subsystem, all right? So given that, Storage Spaces Direct can be deployed both to your physical clusters as well as guest VM clusters. In other words, where you have a group of virtual machines that constitute the cluster. You should know that all HDD, and HDD is mechanical rotational storage, that deployments involving only HDD disks are not supported by Microsoft. Instead, you should be dealing with some HDD and some SSD, solid-state disks, or if you really want to be in compliance with Microsoft's best proven practices, they would recommend that you use all solid-state disks in your server nodes. And that way you can have a nice separation of duties between
the storage cache. For instance, you might have NVMe disks that you're using for cache, and the cache that Storage Spaces Direct makes available is maintained by S2D. It's not anything we as administrators need to mess with. And for instance, we could use the rest of our SSD disks for capacity. Now note that the cache does not count in terms of usable space in the Storage Spaces Direct storage pool and for your virtual disks. It's used entirely for read-write data caching to improve performance, throughput. Some more vocabulary with S2D and failover clustering. When your nodes, your server nodes, have combined compute and storage, this is called a hyper-converged failover cluster. If you can afford and have the ability to maintain storage and hardware separately, this is a disaggregated scenario. Now, because S2D is relying upon locally attached disks, we're really focused specifically on the hyper-converged scenario. The PowerShell command that unlocks Storage Spaces Direct, we've seen this elsewhere in the training, so to a degree what we're doing here is a bit of a repetition, but that's okay. The secret sauce command is enable cluster storage spaces direct. And autoconfig is a switch parameter that is turned on by default. You don't actually have to use it. You can override if you don't want to use it for sure. The alias for enable cluster storage spaces direct is enable cluster S2D. You just need to run this once, and this binds storage spaces on all of your cluster nodes to the cluster. And autoconfig will run a detection routine where all of the eligible disk storage on all nodes gets aggregated into a single default storage pool. All right? So I want to look at two scenarios here. First, what is the process when you're adding new servers to a failover cluster that uses storage spaces direct? Because presumably the disk storage on that server will be enlisted into your storage pool or pools. Well, what Microsoft recommends is to treat the new server like you normally would, a new cluster node, a new host. So you'll run cluster validation. Test cluster does have a built-in test routine to test compatibility with Storage Spaces Direct. And then you can add the node to your cluster in PowerShell, that's add cluster node. Some benefits of adding additional servers to your cluster is if you have at least 3 servers, this unlocks three-way mirroring as opposed to 2. This is some sample PowerShell that shows how you can set that three-way mirroring. Physical disk redundancy default, instead of 1, it would be 2. If you've got at least 4 servers, you can unlock dual parity, also called erasure coding. So again, these are more advanced RAID levels, but once again, it's not RAID as such. It's the Storage Spaces Direct analog to a particular RAID level. How about adding disk storage? Well, the caveat here is Microsoft's guidance, their strong guidance, is that your cluster nodes should all have ideally identical storage configurations. This is going to lend to the best balancing of that storage around the cluster, all right? And you can check out, let's say you added 1 or more disks to each cluster node. You can use a PowerShell pipeline like this, get physical disk, select out serial number, can pool, and cannot pool reason as your properties. That'll be a nice way to report on that new storage, whether it's eligible for S2D or not. And if the newly added disks are eligible for S2D, S2D will automatically claim those new drives and you can add them to storage pools. Now, Microsoft in their docs, if you look at their docs on Storage Spaces Direct, they have a bit of PowerShell code that can automate cleaning disks. You may have disks that already have partitions and even data on them, and you want to clean those out to get them ready for S2D because, again, one of the value props of Storage Spaces Direct is that you can take just regular old commodity disks that you have in your environment, attach them to your server nodes, and incorporate those into your storage pools. So if you've used regular old storage spaces on individual servers or individual client devices, it's directly analogous to that. Microsoft's guidance with storage spaces direct networking is you just want as much bandwidth as you can get network-wise, because although each cluster node is offering its own locally attached storage to the cluster, hopefully it makes sense that it's going to be Ethernet connectivity that links the storage among those cluster nodes, particularly when you're doing cluster shared volumes. Microsoft actually says you want at least 10 gigabits worth of Ethernet bandwidth. So we're talking about LAN or local area network bandwidth. Your server network cards preferably support remote direct memory access or RDMA. This gives them, again, as much possible bandwidth to communicate with storage and to do storage-related data transfer as possible. In this demonstration, I'm going to show you some elements of storage spaces direct configuration. Now, on this cluster, I'm on a Windows server, member server called FS2. I just have a two-node cluster, FS1, FS2. They both happen to be running Windows Server 2022. Now, if I bring out my elevated PowerShell, now I've already run enable storage spaces direct on this machine. If I look at the help and examples, there's really nothing to this command, as I've already explained before. It's just a run once kind of deal. Now, the problem with the auto config, in my experience, is that storage spaces direct then gets pretty greedy. And specifically what I mean by that is this server, FS2 and FS1, did have 2 drives each that I had installed when I created the cluster and enabled storage spaces direct. And then I attached 2 new disks to each host. And before I had any chance to do anything with them, they've been claimed by my default cluster pool right here. So here we are in Failover Cluster Manager on pools. We have my cluster pool 1, and this is the one that was created by that commandlet, enable storage spaces direct. The pool comes in with the name of S2D on, and then the name of the cluster. So it got kind of aggressive here. So we can see I've got a total of 8 physical disks. We have to use PowerShell, evidently, if we want more detail on these nodes in terms of which physical disk is on which node. This output is really insufficient, in my humble opinion. It occurred to me that we probably could get much better data from Windows Admin Center. Yes, sure enough, if we switch over to Windows Admin Center Cluster Manager and come down under Storage Drives and go over to Inventory, I've got some unknown going on with serial number. It's probably because these are actually VHDs. I'm not exactly sure. I don't have any SSD disks, so I'm not using a cache right now. All of my physical disks are marked for capacity. But as you can see, we can see which node has which, and actually Windows Admin Center gives us quite a bit of additional information here regarding those disks. I like that a lot. So let's minimize, let's come back here. Now, could we create another storage pool? Sure, we can right click, but we're going to get dead-ended in the Failover Cluster Manager because when I click next here, there's no available physical disks. They've all already been scooped up by my default storage spaces direct storage pool. So yeah, that's one of the things here. Now, whether we could do that with PowerShell or not, I'm not entirely sure, to be totally honest. Definitely it's a subject that goes beyond what we need for certification success, but a little bit annoying that when you enable that auto config, when you set up storage spaces direct, that it's so aggressive at claiming new storage. That's fine. But at any rate, we can always move the cluster pool itself, because you'll notice that the pool is itself a highly available role that has an owner node. And if we need to take the owner node offline, we would then move the cluster pool itself to either the best possible node, or we can hand select a node, which we discussed in the previous lesson, as a matter of fact. And then disks is going to show our virtual disks. The virtual disks are created based on our physical disks that are in turn aggregated in our storage pool. So if we right-click the storage pool and do a new virtual disk. This would allow us to carve out some space that then can host our roles. So we'll select our storage pool, step through the wizard here. I will call this new role. Very descriptive name, right? And I'll make this really small, 20 gigabytes, that's fine. And the media type and resiliency, there's nothing I can really do here because I just have 2 nodes. If I had 3 or 4 or more, I would have much more flexibility here. I also don't have any solid state disks, so the question of storage tiering isn't relevant either. So it's just going to be two-way mirroring for our resiliency. Let's click Create. I want to make sure to create a volume when the wizard closes, because just the virtual disk is kind of worthless. So let's create the volume. Let's click Next. I'm going to use all 20 gigs, of course. We could assign a drive letter or not, depending upon what we want to do with the volume. Give it a name. I'll call it New Role. We'll use REFS. Actually, we have to use Resilient File System. And then we'll create that new virtual disk volume. You see how the general flow works? Again, it's directly analogous back in Server Manager or in Control Panel settings on your Windows 10 or Windows 11 workstation. You have the storage spaces feature. Well, here on Windows Server, once it loads up, we can go to File and Storage, and then we've got our storage pools in here. Now, we've effectively nullified storage spaces itself on this server. It's going to be working in the context of storage spaces direct in our failover cluster, as you can see here. So I don't want to mess with this. I want to be working with it from the failover cluster manager or with PowerShell or with Windows Admin Center. So if we go to disks, let's see here. We've got our new role right here. We can right-click if we want to, add it to cluster shared volumes. That's going to create a mount for that new role virtual disk on all nodes at C cluster storage. And then whatever role we add to the cluster shared volume will be easily failoverable, if that's a term, from node to node. And so you've seen this before. We then can step through the Configure Role wizard to deploy a highly available role, etc., etc.
Welcome to Lesson 11, Manage Backup for Windows Server. This is the first of 2 lessons on Windows Server backup and recovery. We begin this lesson by backing up and restoring servers to an Azure Recovery Services vault. We then install and manage Azure Backup Server. Next, we learn how to use Azure Backup Server to back up and recover on-premises servers, as well as to manage those backups. Lastly, we'll create and configure Recovery Services Vault backup policies. Let's begin.
The Recovery Services Vault is a cloud-hosted backup and replication solution. You're going to learn how to use both sides of the Recovery Vault in this course, but we're just dealing with the backup aspect right now. Recovery Services Vault is hybrid cloud aware, so it's built not only to protect your Azure machines, but also VMs that may be in other clouds, VMs and physical machines in your on-premises data centers. Specifically, the backup scenarios supported in the Recovery Services Vault for Azure workloads include server, file shares, and certain database products like SQL Server and SAP HANA running on Azure VMs. These are the backup templates available for Azure VMs. As I mentioned, though, there are plenty of opportunities for you to reach across other clouds and reach your on-premises data centers as well. For example, we'll learn how to use the Azure Backup Server in this lesson. The Backup Vault is another managed cloud-hosted backup solution. And although Backup Vault isn't on the AZ801 objectives as of this recording in early 2022, I figured I'd mention it for completeness. It simply offers some additional scenarios. There's a template for backing up the blob service of your storage accounts. There's a capacity to back up managed disks. And there's a couple other hosted database and Kubernetes related templates. Another difference between the Recovery Services Vault and the Backup Vault is the backup is strictly backup and restore, whereas I've already mentioned Recovery Services has the backup as one half of its functionality and failover replication as the other. Microsoft Azure Backup Server forms the four-letter acronym MABS, and you're very likely to see that acronym on your AZ801 exam, so I want to make sure you remember it. In fact, I have a few acronyms for you to remember. Specifically, Azure Backup Server is a free specialized edition of the enterprise retail product, System Center Data Protection Manager, or DPM. This is Microsoft's flagship on-premises backup and recovery solution. And what's cool about DPM and MABS is that they can back up and protect not only Windows but Linux servers. And very importantly, if you run Microsoft workloads on premises, MABS is smart enough to pick up SQL Server, Exchange Server, and SharePoint Server farm environments. So if you have need to restore part of a user's Exchange mailbox, or if you need to fetch list items or documents from SharePoint document libraries, or if you're working with transaction log restores in SQL Server, this is a great value proposition of DPM or MABS. Now, we're not going to talk about DPM as such as an enterprise product. There are some features that DPM has that MABS doesn't, but for our purposes, that is hybrid backup, we're going to stick with the free Azure Backup Server, and that's what will be covered on the exam specifically. Now, on each Windows Server host on-prem that we're looking to back up to Azure, we need to make sure to install the Microsoft Azure Recovery Services agent. Now, that's called MARS. So far we have three acronyms: MABS, Microsoft Azure Backup Server, DPM, System Center Data Protection Manager, and Microsoft Azure Recovery Services Agent, or MARS. And the MARS agent can be used outside of either DPM or MABS, but it's not going to give you the orchestration that you probably need in an enterprise environment. If you just have one or two individual servers to back up, then you can use the Windows Server Backup feature and install the MARS agent, handshake into the Recovery Services Vault, and you can back up those servers to Azure that way. This is going to pick up files and folders as well as system state. You're not going to get workload protection with the MARS agent like you do with MABS. All right, in this demonstration, we're going to look at the MARS agent and the MABS backup and restore solution. Yes, all these acronyms. I'm on a machine, as you can see in my BG info output in the upper left, local DC1. It's an on-premises Windows Server 2022 machine. And I'm going to do in my PowerShell session, get Windows feature to look for the backup feature. I'm just going to do star backup because I don't know the specific name of the feature. It looks like I have Windows Server backup on this machine. So this means, for instance, if I open up Server Manager, I can use the Tools menu and open up the Windows Server Backup GUI tool, the Microsoft Management Console. And we can see that we can do local backups on this machine here. However, as it says in the small text under Online Backup, backups to Azure have not been configured for this server. How do you do that? Well, that's going to involve working in Azure. So why don't we switch over to Azure, and it's going to involve a Recovery Services Vault. Now, I'm going to make this point in the next lesson, but you need to be really careful that your Recovery Services Vault is in the same location as the Azure VMs that you're going to back up to it. Okay? That's a hard requirement. In fact, that kind of question tends to show up on these Azure exams quite a bit. So that is going to be a direct one-to-one between the region or location of your RS Vault and your Azure VMs. However, when you're doing hybrid backup like I am, in other words, you're backing up on-premises machines, then it doesn't matter. Okay? Just wanted to make that point. Now, if I come down under Getting Started, here are our two streams, backup and site recovery. Site recovery is the replication and failover engine. Backup is backup and restore. We're going to go to backup, of course. And we're asked, where is our workload? Now in the next lesson, I'm going to go through the Azure workload, but for now, we're concerned with on-premises. And then we select what do we want to back up. Now, depending upon what you choose here, you're going to get different recommendations. For example, if I choose Files and Folders only and click Prepare Infrastructure, then we're going to just be asked to download the Mars agent to a specific server. And as you can see here, we can download that. It's called the Recovery Services agent. It's also called the Mars agent installer. And then we'll also need Vault credentials to register the server to the Vault, as you can see here. So let me click Download. Okay, so that's going to bring that down. And I've already downloaded the Mars agent, so let me go ahead and install it on this local machine. And the reason I'm showing you this is it's going to serve as an on-ramp to Azure Backup Server. I want you to know about both so that you go into AZ801 really confident. So I'm going to accept the default installation and cache locations for the agent. I'm not using a proxy in my environment. I do want to roll updates of my Mars agent into Microsoft Update for convenience. We'll click Next. Looks like we've met our prerequisites, so we can go ahead and install. Once installation completes, we can click Proceed to register the server to our Recovery Services Vault. In order to identify the Vault, as you already know, we need those credentials. So let me browse into my Downloads folder, grab those Vault credentials, click Next. In order to protect our backups, we need to encrypt them, and we can write our own passphrase. Note that it's minimum of 16 characters. And we have to confirm, and then we specify where we want to save that passphrase. I'm going to have the wizard generate it, and then I'm going to browse to put it on, let's see, how about my E drive? Let's click Finish. Yes, it is a location on this machine. I'm going to want to share it somewhere better. Like for instance, it's small text, I understand, but I like how this dialog says in the final sentence, save your passphrase on another computer or even as a secret in Azure Key Vault. Yes, I do want to continue. And now we're registering this server with Microsoft Azure Backup, and we can begin to run backup jobs on a server-by-server basis, remember, using the Mars agent. All right? And again, that passphrase is pretty critical. So I'm going to want to capture that text file and get it off the file system of this server as early as I can. Launch Microsoft Azure Recovery Services agent. Well, that opens up the Microsoft Azure Backup interface, as you can see here, but notice it looks quite a bit different. We can immediately schedule a backup, and we're going to be cloud aware in this case. Let me step through, and we're going to add some items to the backup. This is really trivial, but I'm literally going to grab that Contoso text file. I know in the real world, you would make a more robust choice. If you want to potentially do a bare metal restore, there's the system state, and that could be particularly relevant with Active Directory domain controllers. But I just want something easy here. So let's click Next. Here is our retention period. Schedule a backup every day at such and so a time. Okay, next. Here's our retention policy. This is all being configured on the client side, as you can see. Initial backup transfers a full backup of your data to Azure. Subsequent backups transfer only changes. That's useful to know from a network bandwidth point of view. We're going to just do an online transfer over the network, and then we can finish the job. And in the next indicated time window, that backup is going to take place and go over the internet. Of course, I can back up now to do a backup, retain the backup until. What do you want to back up? Well, I just have the one file. It shouldn't take very long. Taking a snapshot. Now we have to understand one of the nice things about Windows is the volume shadow copy service, which means that we can back up files that are in use and open, And our goal is to get what Microsoft calls, at least in Azure terminology, an application-consistent backup snapshot. In other words, upon restore, the contents of that snapshot should be exactly as the server was at the time the backup was taken. Really nice. Okay, job completed, so let's click Close. We can follow details, etc. Again, I don't want to get too far down the rabbit hole. Notice that when we installed the Mars agent, we have a new shortcut for Microsoft Azure Backup. That's what we were just in. Next, through the magic of video editing, we're on another server in my on-premises environment. This box is called Local Mem1. And I already have the Azure Backup Server software installed. It's quite a beast to install. It's quite tedious, as a matter of fact. But let me show you how I got here. Here I am in the Azure portal again, and let's go to the Recovery Services Vault. And just like we did before, we'll go down to Getting Started Backup. And in the first question of the little interview we do here, we'll specify that our workload is running on premises. And this time, let us be more robust and say that we're going to back up files and folders, Hyper-V, SQL Server, and system state. It's a much more robust choice. If we click Prepare Infrastructure, that is a flag that lets the Recovery Services Vault go down the path of you using either System Center Data Protection Manager or the free Azure Backup Server. So you can choose already using if you've got a license for DPM and maybe your business is already using it. Otherwise, you can download MABs. Now, it comes down as a series of bin files. It's a few gigabytes, maybe 4 or 5 gigabytes. And it has quite a few prereqs. You'll want to check the Microsoft Azure Backup Server docs to read the prerequisites. We don't have to get into the weeds, but you're going to need a full SQL server with SQL reporting services. There's going to be some .NET framework things going on. It's a bit tedious to get installed, and you also want to make sure you install on a member server, not a domain controller. So in order to do Azure Backup Server, you'll want to install the software. And just like we saw with the Mars agent, we're going to want to use Vault Credentials. Same thing. So we can download those credentials and use that to register your MAB server on premises. And then, as it says, post-infrastructure preparation, please use the on-premises Azure Backup Server to configure backup. So you're kind of done in the Azure portal. Does that make sense? So let's fast forward to you having Microsoft Azure Backup Server installed on your machine. This is what the interface looks like. There's also a corresponding PowerShell module you can use as well. For the purposes of 801, we just need to know from a high level how to use the software to perform hybrid cloud backups and restores. So as you can see down on the left-hand side, we start on the monitoring page where you can look at job data and alerts, etc. I actually would want to go down to management first, because this is where you register your servers, you configure your storage, and then your Azure integration. So when we go to production servers, this allows you to onboard machines in your environment. Notice this button up here that says Manage VMware. One of the value propositions of Azure Backup Server is you can capture and protect Hyper-V as well as VMware machines. All right? Now, when we click Add, we're given a choice right on the outset. Are you going to deploy the agent, the Mars agent, to Windows servers or VMware servers? Let's click Next. We choose how do you want to do this? Are you going to directly orchestrate an install of those agents, or are you going to do it in a different way, an attach method? This is where we can browse our domain for those computers. And as you can see, we've got credentials, whether or not you want to do a restart, and that's it. So essentially, what this step does is it deploys the Mars agent onto each of your target servers in your local environment and handshakes them into your backup server where they will show up here like local DC1 does in my environment. The disk storage is where you can create and add to storage pools. So I've brought in an entire disk on this server, a separate disk that's drive E, and I've given over that entire volume for use with Azure Backup Server. Now, you can't create tape target and more robust scenarios with MABs. You'll have to get a license for DPM for that. And don't be confused when you see references to DPM in Azure Backup Server. The truth of the matter is the UI and controls in MABs is virtually identical to the user interface and controls in System Center DPM. So that's why you're going to see DPM even though we're actually in the free Azure Backup Server. So a good pattern to think about here is to take your storage that's available on your server, install storage spaces, create a storage pool, create a volume or volumes in a storage pool context, and then you can come in here to Backup Server and bring those volumes in for exclusive use. You should note that, exclusive, not shared use by Azure Backup Server as a local disk-to-disk backup destination, okay? And then lastly, the first time you go in here, this is where you provide your credentials. I've already included my credentials, so I'm already hooked into Microsoft Azure. Looks like there's a warning of some kind. I want to take a look at that at some point. But up in the controls here under online protection, you've got managed subscription that allows you to log into the portal and verify your subscription settings. If you want to do a registration, here it is right here. This is what it looks like. And then we've got a configure option to do throttling and encryption and that kind of stuff. So you should know that for both MABs, as well as when you use just the Mars agent with Windows Server Backup, you're configuring the backup jobs and following their status locally. And you may in fact be storing backup snapshots locally, but you're also integrating an online cloud backup in your Recovery Services vault, okay? So once you've set up the back end here, it's time to go to protection and you create protection groups. I created a protection group here called local DC1 Hyper-V config. If I right-click the protection group and go to modify protection group, we can take a look at its properties. And basically a protection group is a scenario for data protection where you can bring in X number of servers. It looks like I brought in 2. And because Backup Server is aware of different workloads, you can see SQL servers, you can just come in and grab those. Hyper-V and virtual machines, you can come in and protect those. Shares, which could be both administrative and non-administrative shares, as well as volumes. You can modify these, bring these into scope here. I'm going to grab system state. So I'm just adding some additional stuff here as I'm modifying the protection group. I want short-term protection, that's disk-to-disk backup. I want online protection as well, yes. Here's our retention, recovery points, synchronization, basically our metadata for the backup jobs. I'm just clicking through. We don't need to get really into the weeds on every option. Select the data source you want to protect online. Well, I added 2 more elements. I'm going to add those to my Recovery Services vault as well. What is our backup schedule? I have it set to every day at 9. That's fine. There's our retention policy, then our summary, and then I'm going to update the group. So that same procedure pertains to creating groups as well as modifying existing protection groups. And so the idea is that at each schedule, Backup Server will run a job based on the settings in each protection group. Nice. Success is what I want to see for results, so let's click Close. I want you to understand that you can manually create a recovery point at any time. It'll light up on the toolbar once it finishes thinking about what it's doing right now. While we're waiting for that, let me look at the recovery side of the fence here. And what we've got is browsing your DPM dataset, which is all, again, in SQL Server database. And you can search recovery points based on different workloads. As you can see, Exchange mailboxes, SharePoint, files, and folders. I have a backup of a Hyper-V host server configuration right here already selected. And we can just, in the case of a restore, choose on the calendar which restore point we want, where we need to recover it from, and then we can click Recover to issue a recovery process. Here's the recovery wizard, and the specific options here are going to differ depending upon what it is that you're recovering. For example, if we were recovering a Hyper-V virtual machine, that would have one set of options. Matter of fact, as this says, it's defaulting to recover to original instance, which would overwrite the original host component. We could recover as a virtual machine to any host, or just copy the contents of the backup to a network folder. That same thing would apply to files and folders. We could overwrite or replace the files and folders where they originally were deleted from, let's say, or maybe you could restore to an alternate location. So that's the recovery side of the fence here. Let me go back to protection one more time. See if, yeah, it looks like we're still cooking here. We're still operating. We can check our data source health up here using these filters. And of course, we can always come back to monitoring to look at overall job status. All right, so that's recovery. Just because I can't help myself, I want to go back to protection just to see if Backup Server is ready for me to work. It's a little bit syrupy on the system. But I wanted to let you know that in addition to the scheduled backups that will happen at the protection group level, we can also select items in the list and create recovery points manually, as you can see here. And that's available programmatically in PowerShell or in the console, as you can see. So the idea is, because the Recovery Services Vault is a platform as a service solution for backup and recovery of your Windows Server machines, regardless of where they are, there are some common Azure Resource Manager control plane options that you should be aware of with regard to this. First of all, you should know that the Recovery Services Vault has soft delete enabled. Now, this is available only for your Azure VMs. It's basically a recycle bin that protects deleted backup snapshots for 14 days. So if one of your colleagues were to delete or prune a backup snapshot, you do have 14 days to pull it out of soft delete state. I'll show you how to enable and disable soft delete for a vault. It's enabled by default, and honestly, I would suggest you keep it that way. Now, more recently, Microsoft calls the feature in a pretty unimaginative way security features, but there's also an option to protect, basically to do a soft delete functionality for your hybrid backup snapshots that are stored in the Recovery Services Vault as well. You just need to know where to get to those controls to make sure that they're enabled. Also, to help you if you need to do a restore and your primary or production region is unavailable, you should know that Recovery Services Vaults replicate. You should know that snapshot retention depends entirely on the backup policy you configure. In other words, how many daily, weekly, monthly, or yearly snapshots do you want the Recovery Services Vault to keep? In the next lesson, I'll teach you about the instant restore area, which is a really nice way to shorten restore windows. But in this lesson, we want to look at the other elements, mainly the retention aspects of the backup policy. Lastly, for high availability, Recovery Services Vaults use geo-redundant storage. This means that your backup snapshots are stored not only in the primary region where your Recovery Services Vault resource is located, but also a Microsoft-selected secondary region. Microsoft has a collection of what they call region pairs. You can look in the Microsoft docs for Azure paired regions to find out what the paired region is for your primary region. But this is good because if you're in an emergency and you need to retrieve snapshots from a Recovery Services Vault and there may be an outage in your primary region, this would give you access to the secondary region. In this demonstration, we're going to look at Recovery Services Vault properties, and we'll look at backup policy in a bit greater detail. So here we are in our Contoso Vault East Recovery Services Vault, and I want to start by going down into Properties. This is where Microsoft put some of those controls I told you about earlier. Specifically, if we come down under Security Settings, Update, this is where we have our soft delete, which interestingly is off on my machine. I'm going to want to change that for sure, so let me enable that. And that's going to pertain, as the parentheses say, for workloads running in Azure. If we want workloads running on premises protected against accidental deletes, we would want to enable what Microsoft calls security features. So let me make sure to save that change. Next, if we look at encryption settings, update, this gives us the opportunity, as is pretty standard across Azure now when it comes to data, doing either a Microsoft managed at-rest encryption key or a customer managed key. If you're going to do your own key, you can use any key management solution, but it's really easy to store your encryption key in Key Vault, given that Azure Key Vault is already there in your subscription. Okay, so let's come out of there. I'm just touring some of these options. And lastly, I wanted to show you, here's where we can get to the Mars agent by simple link and also downloading our backup credentials. If you need the Vault credentials at any time, you can grab them there. And then we have backup configuration update. And as this says, you can change the storage replication type. You can save money, for example, by staying locally redundant within one region. It defaults to geo-redundant, but the catch here, and I'll mention this again in the next module, that you can't change the option after you start protection. So it's something you'll want to think about early before you actually run any backup jobs. Now, with regard to those policies, let's come down under Manage, and this is where we have backup policies. And let me show you the components that go into those. I've created a couple of them right here. Let's take a look at my Azure VM backup policy. Actually, instead of that, let me just show you that we have an example of two different policy types. If I click Add, you'll see what I mean. The 4 Azure backup scenarios for which we can do a policy are Azure VMs, Azure file shares, and this is useful when you think of something like Azure File Sync, which we'll learn about elsewhere in this training, SQL Server in Azure VM, and SAP HANA in Azure VM. That's useful. I'm going to say that this is an Azure Virtual Machine policy, and I'm going to call this Windows Azure VM policy. Now, I want you to understand that these policies that we create in the Vault are going to protect only those 4 workload types, and all 4 of those workload types are Azure only. You saw earlier in my previous demo that you create your policy for your on-premises backups using either the Windows Server Backup tool or MABS, all right? So we've got, first of all, our daily backup schedule. You'd set that obviously in your target time zone, whatever that is. Mine is -6. We'll talk about Instant Restore more in the next lesson, but this provides a shorter recovery window by holding between, I think it's 1 and 5 days worth of backup snapshots in an area much closer to the source virtual machine to make recovery a lot faster. Then we have, as I mentioned, daily backups are going to be kept for X number of days, and then we can configure weekly, monthly, and yearly based on your compliance requirements. So 2 take-home messages, well 3 really, take-home messages I want you to see concerning these backup policies in the Recovery Services Vault is number 1, they pertain only to Azure workloads. Number 2, what was number 2? They're modular. That is, you can create them and then add them to different backup jobs. Number 3, they have those different workload scenarios, and I forgot what number 4 is. Now, to finish this out, let me come down under Protected Items, Backup Items, and here's where we can see the various backup management types and backup item counts for those scenarios. Okay, so we can see it looks like as of now I have 1 Azure Virtual Machine backup item as well as 1 from Azure Backup Agent. Looks like I have 0 showing from Azure Backup Server, but we now know that once our first backup, our protection group backup happens, this backup item is going to increment, obviously. I just want you to see that we now understand all of these different management types. You've got the Mars agent, native Azure workloads, that would be this, 2, 3, 4, System Center DPM, and then Azure Backup Server. And then what you can do is come in and inspect each backup item, and the options that you can do with each depend upon whether it's a local or cloud workload. Here, this is a backup from my local DC1. And the idea here is that we're storing the backup item in Azure, but we would restore it on-prem using the Windows Server Backup tool. And the same thing would apply to the DPM and Azure Backup Server scenarios. Now, if it's an Azure virtual machine, we've got, again, a list of backup items, and there the interface is much, much different. We have these various restore controls that we'll learn how to use in the next module. Last thing I want you to see here is this blue banner, which may not be in the portal by the time you're watching this, I don't know. It's basically a notification of the Backup Center. And what the Backup Center is simply meant to be a centralized management interface for all of your vaults. Specifically, if we come down to vaults and then vault, we're given the choice to create recovery services vaults, which have all of these various data sources that we already know about, or a backup vault, which has a different set of backup data sources, specifically the Azure hosted database for Postgres, the blob service in Azure Storage, Azure Managed Disks, Azure Kubernetes Service, and Azure VMware Solution virtual machines that looks like it's in public preview at this point. Again, Backup Vault isn't yet on the objectives, but just in the name of forward thinking, I wanted to mention it.
Welcome to Lesson 12, Manage Recovery for Windows Server. This lesson follows directly on the heels of the previous lesson. Specifically, we examine backup and restore operations for Azure virtual machines. We begin by configuring backup for Azure VMs and learn how to recover those VMs by using temporary snapshots, particularly restoring them to new Azure virtual machines. Lastly, we'll learn how to leverage the other Azure options for restoring VMs, including in-place disk restore as well as file recovery. Let's begin.
In terms of backing up your Azure Infrastructure as a Service virtual machines, we're going to use the Azure Backup Service. This is a zero infrastructure at-scale platform as a service offering from Microsoft that gives us VM backups and restores with unlimited data transfer. In other words, the Azure Backup Recovery Services Vault is a hosted storage repository in the cloud, and we don't have the problem of paying for data egress. Normally, say with a general purpose storage account, you're not charged for inbound access into the storage account, but you are for outbound. Nope, there's no data transfer costs with Azure Backup. You're going to see in the demo that Azure Backup supports things like availability zones and cross-region replication. This is to ward against the problem of needing to do, say, an emergency Azure VM restore where your primary region is unavailable. Supported scenarios for Azure Backup include, of course, Azure VMs. Now, although we're focused strictly with Windows Server in this AZ801 training, the skills that you pick up in this lesson apply just as much to Linux and Azure as they do Windows Server for Azure. I mean, we're going to see there's some differences in terms of Linux doesn't have the volume shadow copy service, for example. As you'll see in the demo, I want to do most of this teaching in demo rather than having us look at slides. There are a number of Azure VM backup templates. We can back up file shares as well as Azure virtual machines that are running local instances of SQL Server and SAP HANA. That's particularly useful for us database administrators because, you know, if you've backed up a relational database or an SAP and in-memory database, there's quite a bit of moving parts going on there beyond just something that you can capture with the VSS service. Now, the reason why Azure Backup is not called Azure VM Backup is that it's hybrid cloud aware, number one. In other words, from our Recovery Services Vault, we can schedule backups in so many different hybrid cloud scenarios. We can use the Azure Backup feature in Windows Server and load up the Microsoft Azure Recovery Services agent. This is called the MARS agent. And this would allow us to back up individual machines. Now, it doesn't have to be a virtual machine. It can be a hardware host in your environment, or it could be a virtual machine that's running in another cloud. The MARS agent is going to be specific to an individual Windows Server host. There's also support for Microsoft's own enterprise backup solution. That's System Center Data Protection Manager called DPM. And there's also a stripped down free version of DPM called Microsoft Azure Backup Server, or MABS. And the benefit of using DPM or MABS on-prem is that they're aware of Microsoft Cloud workloads like Exchange Server and SharePoint Server and SQL Server, so they can do customized workload backups, besides the normal stuff like file and folder, whole disk, and system state backups and restores. Now, you do need to know those acronyms for your AZ801. You know that MARS is the Windows Server agent that you can use to back up off Azure machines singly. But if you want to do at-scale backup and restore on-prem, we've got DPM as a paid option, and Azure Backup Center, or MABS, is actually free. Now, when you're backing up Azure VMs, the Azure Recovery Vault is taking incremental snapshots of your virtual machine's managed disk, and it's going to capture both the operating system disk as well as any data disks that are attached. Note that your temp disk is not included. And to save space in the Recovery Services Vault, which you're paying for after all, we have incremental snapshots, which is good, that we've got a parent managed disk and then n number of incremental snapshots that go along with it. But the good news is that you don't have to worry about the plumbing there. One of the value propositions of the Recovery Services Vault is that all of this complexity is abstracted away. We can just use Azure Resource Manager clients like the Azure Portal, Azure PowerShell, or the Azure CLI to automate this stuff, automate our backup processes. Now, these backup snapshots are offered in one of three consistency levels. The best consistency is application consistency. This means that the snapshot was successful, that the volume shadow copy or VSS writers were able to capture the in-memory state of the server, as well as pending I/O operations. This is great because when you restore that disk as either in place or as a new VM, as your case may warrant, this means that you can bring that Azure virtual machine up to the state it was at the time of the backup. So application's definitely what you want as a standard for your snapshot consistency. Now, in Windows servers, if the VSS writer experiences a failure for whatever reason, you'll be given a file system consistent snapshot. And here the guarantee or the service level agreement from Microsoft is that you're not guaranteed that the VM upon restore would come right back up to the point in which it was backed up. You might have to do some cleanup operations. Crash consistent is the snapshot consistency that you don't want as a general rule. However, you'll see that if Azure Backup takes a snapshot of an Azure virtual machine that's shut down at the time of backup, this is what you'll get. And that should make sense because if a machine is stopped and deallocated, how in the world can the Azure Backup Service capture memory state? There is no memory or pending input-output operations happening. Now, again, I know that AZ801 is all about Windows Server, so we've got all this VSS talk. You can, in fact, back up and restore Linux virtual machines in Azure, and you can even configure application-consistent snapshots. However, there's some additional work you have to do in terms of injecting pre- and post scripts. You can check the Azure docs for that. The article is called something like Performing Application-Consistent Backups on Linux Azure VMs. The hallmark here is the instant restore feature that's part of the Recovery Services Vault. Now, as you can see from left to right, we've got our Azure-based Windows Server virtual machine, and that VM has not only the OS disk and the data disks, but also the configuration of the VM. And if we need to do a whole VM restore, hopefully it makes sense that it's generally not sufficient to restore only the disks. We need all the configuration, in other words, the VM size, the availability set versus availability zone configuration, all of the properties of the Azure VM resource. And so what we've got is a capture, a snapshot of the configuration and the storage. But what happens with Recovery Services Vault is that there's a temporary snapshot holding location that Microsoft calls the Instant Restore Area. And you can set this to store 1 to 5 days worth of snapshots. Now, it's temporary in as much as they're only in the instant restore space for a period of time. Every backup snapshot will eventually go to the Recovery Services Vault. And in that Recovery Services vault, your snapshots will stay forever unless you prune them. Why do I mention this? Well, because before the instant restore area became available, your restore windows were much longer. You see, the reason the instant restore area exists is because the hop, in terms of the transfer of the disk snapshots between the VM and the instant restore, is much shorter than the second hop into the Recovery Services vault. Do you see the benefit? That means in a restore scenario, you can skip that long first step of Azure extracting the snapshots from the Recovery Services vault and placing them in instant restore. They're already there, so you can restore from a snapshot and dramatically reduce your restore window. So the instant restore feature is fantastic. You configure the instant restore properties in your backup policy. So this is a case where your primary virtual machine, in this example, I've got a hub virtual network and I've got a Windows Server VM named Web1, and that may, who knows, be catastrophically damaged, or maybe the region is unavailable. It could be a platform issue with Azure, but you may need to restore the entire VM. Now you have a choice. Are you going to try to restore the VM in place? Or are you going to do, say, a trial restore? This is a common thing that I hope you and your team are doing, these so-called fire drills, where you practice automating a restore process, say, to a disaster recovery virtual network. And in that case, you can verify, number one, that you and your team know how to do the operation, and number two, you can verify the workflow of bringing up the VM, et cetera, et cetera. Now, of course, there may be some fix-up operations. In this example, you see the restored virtual machine coming up with a separate private IP. You'd probably want to duplicate your production VNet and use the same subnet and private IP layout, because if it's a production VM, you want to get it up and running. But then again, I do want to put in a plug for the other half of the Recovery Services Vault, and that's the Azure Site Recovery, or ASR feature. We use ASR to do failover recovery. You see, we have to remember that with these restore operations, no matter what, you're going to have downtime because you have to stop and deallocate the source VM. When you're using Azure Site Recovery, you're replicating a live Azure VM, or frankly, a machine off cloud or on premises, into a disaster recovery environment, and then you can perform a live failover to that DR environment. Here, this is kind of old school, a V1 approach, where you would restore an entire virtual machine to, say, a different virtual network. Now, there's other options, of course, particularly one that comes up in practice is, well, okay, I can restore the VM to an alternate location, but what if I want to provide an alternate configuration? We talked about the disk storage and the VM configuration. It tells you right in the portal you have to use PowerShell for that. That's not exactly true. Here's the flow. You want to make sure that you've got a storage account ready to go to capture this process. And you'll actually just restore the disks. We're going to cover that in the lesson next, actually. So you'll just restore not the whole VM, but just the disk storage, and those disks and the VM config will be placed into that storage account where you can fetch the underlying Azure Resource Manager deployment template. The idea is that you then modify that ARM template and then deploy the VM using that modified template. Now you can do all that with Azure PowerShell, but I'll show you in the demo you can do most of this work in the Azure portal itself. For our exam purposes, you just need to know this top-level flow. I'll go deeper in the demo. What are our Azure VM recovery options? Well, so far we've seen that we can restore an entire VM, both its storage and configuration, to another virtual network. That's good for fire drill, trial restore, migration, whatever the case may be. We can just extract the VM disks from a backup, and you could convert those, generalize them, and convert them into an image. You can use the ARM template approach that I gave you a moment ago to deploy or restore that virtual machine with an alternate configuration. Now, one novel point is what if we do in fact want to keep the original VM in place? We don't want to delete it and recreate it. Because if you've worked with Azure VMs for any length of time, you know that there are plenty of dependencies. You might have a public IP attached to the network interface. You might have a lot of other specialized network interface configurations, network security groups, custom DNS, etc., etc., etc. So we've got this feature in the Recovery Services Vault called In-Place Restore, where you can basically swap out just the storage. That would keep the VM resource and its configuration and dependencies in place, and just swap out the storage. This is very convenient indeed. Now, you'd still need to stop and deallocate the VM, so you're going to have downtime. This is not Azure Site Recovery, but it can dramatically reduce complexity, if nothing else, in a catastrophic restore scenario. Now, lastly, if you have need for just recovering individual file system artifacts from a backup snapshot, we can do that. So let's say you've got a Windows Server VM in Azure that's a file server, and you're not using a storage account file service that I think you should. But anyway, you have files and resources on that VM, and therefore in the snapshot, the production VM, maybe the files have been deleted or crypto-lockered. I hope not, but let's say. You don't necessarily have to replace the disk or restore the disk to another location and mount it and get into it. There's a file recovery feature that uses some really clever engineering that we'll cover in our upcoming demo that allows you to extract individual files from a backup snapshot. Well, we've covered a lot of theory. Let's spend all the rest of our time together doing a unified demo. Here we are in the Azure portal, and I'm focusing in on Recovery Services Vault. This is the Azure product that serves as our base of operations for Azure VM backup. Now, when we create a Recovery Services Vault, let's take a quick look at the creation workflow. You simply provide a name and a region, but I want you to understand that the region here is very important. Your region needs to match the region of the Azure VMs that you're going to protect. Now, if you're doing Recovery Services Vault to back up off-cloud machines, it doesn't matter. But in terms of integration with Azure VMs, they have to be in the same region, and that's an exam alert. So if you're asked the question on the AZ801 exam, you have 3 VMs in 3 different regions. How many Recovery Services Vaults do you need? The answer is 3, all right? So anyway, let me come back using the breadcrumb navigation, and let's take a look at my Contoso Vault East. And I want to draw your attention to some settings that are pretty important, but they're kind of tucked away, so you might actually miss them. Under Settings, Properties, this is where we can get to if I scroll down. Our configuration and security settings. For example, if we go to Backup Configuration Update, note that you have a storage replication type, and I set mine to geo-redundant. Locally redundant means that your backups are kept within your home region, within a single data center. That doesn't provide much resiliency to your backup snapshots. The geo-redundant option ensures that Microsoft replicates your backup snapshots to another region. And then, as you see, if you have geo-redundant set for your vault, you can enable cross-region restore that enables us to perform restores in the secondary region. This is particularly helpful if your primary region is unavailable. Now notice that once you start a backup job, this control becomes grayed out. So you want to think about and set this as early as possible, preferably during your Recovery Services Vault deployment if you're using an ARM template or a Bicep template. And then, as I said, we can enable cross-region restore, but that's a non-reversible storage property. You can see that that control just went gray as well. Something else that I want to show you is under Security Settings. If we go to Update, your backups by default are protected with soft delete. Now, if you're familiar with the soft delete feature in the Azure Storage account, this is a similar property here. So this means that if any of your colleagues, let's say, were to delete backup jobs for Azure VMs, you should be able to pull those back. If you want to look at retention and defaults, I would hit up Learn More and go into the docs. I just wanted to show you these options because, like I said, they're not only important, but they're kind of hidden away. Lastly, if we come down to the very bottom, if you're going to onboard individual Windows servers that are outside of Azure, and you're going to use the MARS agent, remember the Microsoft Azure Recovery Services agent, you're going to need the backup credentials for your vault to allow that Windows server to handshake into the vault. And this is a place where you can directly download those credential files, as you can see here. All right, so anyway, if we come down to getting started, notice that we've got two streams, one for Azure Backup and one for Site Recovery. We'll go down Backup. And we're given basically an interview. Where is your workload running? We could be Azure Stack, Azure, or on-premises. If it is on-premises, we can do various workload backups. And the questions that were asked here are going to be related on what we choose. For instance, if we're selecting on-premises file and folders, part of our infrastructure preparation is going to either be singly installing the Mars agent on individual machines, or you can use MABS, the Azure Backup Server, or DPM. I'm going to step back, come back to Backup. We're going to do an Azure Backup. So in this lesson, I need to force myself to stay on topic. So Azure is our workload, and then I want you to see that there's 4 backup scenarios. We're going to choose VM, but notice that you can back up an Azure file share. This would be useful to protect any file share shares that you have in your general purpose storage accounts. And then, as I had mentioned, there's particular backup templates for a SQL Server running in an Azure VM and SAP HANA in an Azure VM. Now, let me open up another browser tab, sign into the portal in another tab, because there is another hosted backup solution called the Backup Vault. It's not mentioned specifically on AZ801, so we're not going to go into it. But this has some additional scenarios for backup. Honestly, just being totally candid, I'm not sure why Microsoft has a Recovery Services Vault and a Backup Vault. Some things that come to mind are, we know that Recovery Services Vault has both the backup and the Azure Site Recovery, whereas the Backup Vault is specifically for backup and restore scenarios. But anyway, one of the templates that you can do in backup vaults is to protect the blob service of your storage account. So we now have hosted scheduled backup available for 2 of the 4 services in storage. That's been a long time coming. So I'm going to choose virtual machine and we'll configure backup. This is the backup policy. This is where you can select a policy from your library. I don't have one, I just have the default. So let's create a new policy, and I'll call this Azure VM Backup Policy. And we choose our frequency of backup, daily or weekly. And we choose our time, what time you want it to actually happen, and the time zone that you want to use. I'm in Central Time, -6, so let me select that from the list here. Central Time, here we go. Here's the instant restore property, like I mentioned, and it defaults to 2 days, but we can go up to 5 days. And then we have our retention range. Notice that we get a daily backup retention, and then we can configure weekly, monthly, and yearly backup points as well. This is useful to maintain compliance in your organization. I'll tell you, I've put in quite a bit of time in my industry doing backups on-prem and data centers. This is so much easier, isn't it? Lastly, for configuring at-scale backup of Azure VMs, we can click Add under Virtual Machines. And again, this is going to show only VMs in the same region as the vault, all right? And in the same subscription, too, as far as that goes. So I just have a couple available. I'm just going to enable it on Mem1 right now, and we'll click OK. And then lastly, we enable backup. Now what happens is, you're familiar with the extension model. Azure's going to deploy the VM snapshot extension to that virtual machine, and then it'll be available for backup jobs. Now, in terms of individual Azure VMs, you can, if you want to, configure backup on a single VM by VM basis. If we go in the portal, for instance, into the VM and go to backup, we can just tap into a Recovery Services Vault directly, as you can see. Select existing, as long as it's in the same region. Choose our backup policy, and then enable backup. But this isn't particularly scalable. In a business environment, chances are you want to onboard multiple virtual machines, be they Linux or Windows, it doesn't matter, it's the same procedure. That's how we would do it. Make sense? Okay, now let's look at restore scenarios. Well, one more thing actually. In terms of doing a manual backup, let's go over to DC1 for example, and then let's come down in the settings to backup. Once you've enabled backup, you've got a different interface here, and this is actually the same interface that we're going to see in the Recovery Services Vault. You can see we can force a backup, we can restore VM, we can do file recovery, And we can get alert and job information, and we can see our list of restore points down below. Tell you what, let me show you this from the context of the Recovery Services Vault. It just makes more sense. Before I forget though, let's revisit our MEM1 machine that we just enabled for backup. And I'm going to kick off a backup process manually on this machine. Right now, it's going to perform the first backup sometime tomorrow morning in my time zone, and I don't want that. So in order to do a manual backup, we can just trigger that here, backup now. We can specify or override our backup retention, and then we'll click OK. And that triggers that backup, and away you go. Now, back to the Recovery Services Vault after all. Let's go in there, and I want to show you some stuff. First of all, I want to come down under, let's see here, down under Monitoring. We've got a separate jobs list for both backups and Azure Site Recovery operations. So of course, we've got our manually triggered backup happening in MEM1 right now, and we can come in and view its metadata and view its details, leaving nothing to the imagination. And this is going to be tracked after the fact as well for historical purposes. You can export those jobs as a CSV file. And then from a more global standpoint, don't forget about Azure Log Analytics and being able to report using the Custo query language that way. Now, if we scroll up a bit, we've got protected items. And again, there's the two streams within the Recovery Services Vault. For ASR, that's replicated items. And for Azure Backup, that's backup items. We're going to go to backup items. And here we'll see a library based on the type of how many backup items you have. And look at all the different options. We've already talked about the first four. But then in a hybrid cloud scenario, if you're using System Center Data Protection Manager or Azure Backup Server, that's the free version of DPM that doesn't have as many features. And then there's the Mars agent. So anyway, I'm going to go to Azure Virtual Machine. And we've got our DC1. Let's go into its properties. And this, like I said, is the same interface that we saw a moment ago in the context of the VM in the portal. Now I want to draw your attention down to the bottom. You can see here I have two application consistent backups, and I intentionally stopped the VM last night so that Azure being it, would create a snapshot while the machine was turned off, and we can verify that that's a crash consistent backup. And we now know the difference between application consistent, file system consistent, and crash consistent restore points. Okay, now let's finish by taking a look at restore VM versus file recovery. Okay, let's go to restore VM first. Of course, the first thing we need to do is choose our restore point. So we'll click select. And because we know the difference between application and crash consistent, I'm actually going to select the most recent application consistent snapshot. Click OK. Now, as you can see here, there's two restore configurations. Do you want to create a new virtual machine, or do you want to replace existing? Create new would be a trial restore. It would also be where you just want another instance of the production virtual machine and say a different virtual network. We have to remember that because Azure virtual networks are air-gapped by default, that is, they don't have any connectivity, there's not going to be a problem to do a create new with all the same properties as the production Azure VM. As long as it's running in its own VNet, there's not going to be any conflict. It says to create an alternate configuration when restoring your VM here in the portal, use PowerShell. And that's true, you can use PowerShell, but I'm going to show you how we can do most of that work in the portal momentarily. Anyway, the create new scenario has two subtypes. There's create a new virtual machine or just restore disks, all right? If you're going to create a new VM, we need a name for the VM, obviously a resource group. We want this to be generally a different virtual network, subnet, and then your staging location is going to be a storage account. And it has to be a pre-existing storage account that you've got. I have the one in East US right here that's applicable. And that would bring up the VM in that new location using the snapshot, bringing up the storage, and also matching the configuration of the source virtual machine. If you wanted to restore only the disks, what you need to provide is a resource group and a storage account. That's all you need to restore just the disks. And why would you do that? I've already mentioned it, but what I'm going to show you next is in the case where you want to restore a new virtual machine in, say, a different location, but you want to do an alternate configuration. I'll show you how that works. Second restore configuration is replace existing. And this use case is where you need to restore a production Azure virtual machine, and you don't want to recreate anything. You want to use the existing resource with all of its dependencies. Pardon the typo here. That's obviously a bug. And when you do an in-place restore, of course, the source VM has to be stopped and deallocated so that the storage is unlocked. You just simply choose, again, a staging location and click restore. Pretty easy. Nice. Okay, let's go back to our Contoso Vault backup items. Actually, let's go down under monitoring to backup jobs. And let's draw that scenario quickly, okay? Let's say that for DC1, we want to create a new virtual machine in another virtual network that will also match most of the configuration of DC1, but we do want to differentiate it. We don't want to restore the configuration of the production virtual machine. So what I did already, I've already got the souffle baked. I'm going to take it out of the oven. I just did a disk restore operation on this machine. So if I select the restore item, come over to view details, you'll find that when you do a restore disks or a recover disks operation, the job page in the Azure portal will give you the URI or the full resource path to the underlying ARM template. So in this case, it's giving us the path right down here. Notice that it looks like in my chosen staging location, in my TIM storage 001 storage account, the Vault created a container starting with the name of the server, the snapshot, and then in there stored some JSON files. And I want to show you this. Again, I'll open up another instance of the portal in another tab. Let's browse to my TIM storage account directly. And what I want to do, I'm going to make use of the in-browser storage browser here that's in the portal. And let's go into blob containers. And let's find that DC1. Here it is right here. And here's the configuration of that machine. Notice that you get 3 JSON files. There's really just 2 that you need. Let me actually grab these. Let me copy all 3 of them. Be easier for me to use something like Azure Storage Explorer actually than individually downloading the files, but whatever, I'll go ahead and do that. And then in File Explorer, let me head on over to my Downloads folder, and we've got our files here. Let me right-click, open with code. Here I am in VS Code. Now, of course, you'll want to rename these JSON templates. Here is the Azure deploy. This is what you really want. This is the main template. And it's going to define the full configuration of that virtual machine. And if I scroll down, you can see that it's parameterized and there's some variables. It's not bad JSON for something that Azure created itself. We also have an Azure created parameters file. Make it easier to pass in new values. And then we've got a config file. And this is just an extract of the Azure deploy where it gives you the specific configuration. Because if you're wondering what exactly is comprised in an Azure virtual machine's configuration, it's stuff like the hardware profile of the VM. In other words, its size, the storage profile, the disk layout, the caching options for those disks, etc. The networking, the placement group, all that kind of stuff defines the configuration, and this allows you to just snapshot that. So you would then run your deployment specifying that JSON template that references the disks under the hood. And if I come back to the portal, there's actually a deploy template right here. So you can run a custom deployment directly from here. You can edit the template definition and make updates right in the portal. Not that that's necessarily the most comfortable experience. I'm just laying out options, all right? That's all I'm doing. Okay, so let's finish this by going over to, let's go to our vault. Where were we originally? Backup items, Azure virtual machines, and we were looking at our DC1 backup items. And we just finished looking at the restore VM scenario. The last thing we'll do is file recovery. And this is that bit of clever engineering that I mentioned, where you can recover individual file system artifacts. So watch this. I'm going to choose my recovery point. I want the most recent app-consistent recovery point. And then we'll click Download Executable. And that's going to dynamically create a PowerShell script wrapped in an exe, a binary. And in order to unlock the PowerShell script, we'll need to provide a generated password. Now, this is all assuming that you're on Windows. However, you could also do this on a Linux host. You'll find that file recovery will use Python and create a Python script. And it's a very similar workflow to Windows. I just wanted to presume that question in case you had it. Okay, the script file is ready, so let's download that executable. And I'm going to copy the password to my clipboard. Let me see, where did that go? Here it is. Looks like it's in my downloads folder. Let me double left click that executable, and then I'm going to right mouse click to pass in the passcode. That unlocks the script, and here we have a notices and information thing that we'll want to read at our convenience. But what I want you to see is that file recovery launches a PowerShell process under administrative context. And then we'll bring up the iSCSI initiator on your Windows machine. In other words, using the iSCSI service, it'll make a connection, believe it or not, to all of the disks in that backup snapshot and mount them. So as this says here, open Explorer and browse for files. After recovery, to remove the disks and close the connection, please click Unmount Disks in the portal. So let's minimize our PowerShell. And there's some additional implications, actually, regarding disks that are encrypted with Azure Drive Encryption. The exam doesn't get to that level of complexity, but that's certainly a real-world issue here. And it looks like my local computer is unable to fetch the unlock key. And that makes sense because with Azure Disk Encryption, I'm using Key Vault. I would strongly recommend, if you're interested in this topic, run a Google search or go directly to the Microsoft Docs and look for Azure File Recovery BitLocker and learn the guidance directly from Microsoft. But in my case, I'm going to go into File Explorer, and I want to draw your attention to what's now my E drive, this 127 gigabyte disk that appears to be a local disk, but it's actually not. This is from the backup snapshot, and I want you to know that not only will the C or operating system drive be mounted, but also any other data disks. And that's what I'm getting the error on. Evidently, there is a problem with that script where it couldn't unlock the BitLockered F drive. I'm not sure about Windows, because with ADE, you encrypt both of those. That's actually going to inspire me to do some research after I stop this recording. But I've transmitted the point. To finish out here, let's come back to the file recovery screen. And, well, actually, let me not do that. Let me go back to File Explorer one more time. I'm getting a little ahead of myself. The idea is that you've got individual file system resources. You can literally use a command line tool, or you can come into the File Explorer and you can copy out any resources that you need from that snapshot. That's the value proposition. And then when you're ready to unmount, you can do one of two things. If you want to do a cleaner unmount, you can click Unmount Disks. The other thing you can do is simply let it run. It will mount for, I believe, let me see, it should be in here. Yes, these drives will remain mounted for 12 hours. And there's also some fine print down at the bottom I want to make sure to at least say verbally. It says to restore files larger than 10 gigs, you should restore the entire VM, or I would add restoring the disks. In other words, don't abuse the file recovery service. It's not intended for large data transfers. That's the second bit of small text. The data transfer rate is severely throttled. It's not even 1 gig an hour. It's up to a gig an hour. So Microsoft really wants you to use this just to pluck individual files and not huge database data files. This is not the use case for that. So let me unmount the disk, and then I'll go about my business. Thank you.